So I talked to him and said, like, who's the best friend? And which one of the best friends is like, Musk.
Yeah.
Right,
That's how the parking lot is. This is gonna be a place to be.
Yeah, sorry.
I was gonna say, I said, they're gonna have to build a bigger facility.
Notice all the little kids.
Yeah, it's called Second Saturday. We do food distribution out there. We normally, the team helps whenever we donuts and meals are out there.
It looked like there was all these little kids.
Families lined up to get food.
Well, that's the community.
What's that?
That's the community. So those little kids are not students here.
Oh, no.
Oh, okay.
It's food bank distribution.
Oh, okay.
They bring a big food mobile, they bring food bank mobile pantry out.
Okay.
And we're distributing. Vegetables, fruit, whatever.
Yeah, I was looking at that. That's football.
I was gonna, that's what I thought.
We're not that bad.
But I said, they sure do look small, and I'm thinking,
I thought it was.
I mean, they come square for the
We
academics,
had
not
a
for the
good year
football.
this year.
Not for the football.
Yeah, actually, they should come here for the football. I mean, this is a big sports school. Kind of
And
magnet.
not football, not typically.
Yeah,
Baseball, predominantly.
Basketball.
Basketball. I thought they were getting ready for a baseball game.
I don't know, my kid's not he's not a jock. I've been here.
kind of reinforce leadership sometimes.
You want me to share this or really? You want me to? All right. I'll do this. All right. So, so I'm going to go ahead and get started with something that I've just been dying to show you, because it's fun. And I think you ought to come down here. So come down here. Because some of this I'm going to do without the computer, because you can.
How close? This close? Crowd, yeah.
Come down and crowd. That shirt's perfect. No, don't go away. Oh.
That was planned.
Maybe. All right, so this is a camera that Aaron Hill, when I was at TRI, we've been messing with vision all year. And we have, so we use a network camera. Some people were using USB cameras, and my guys got to the point where they were having it do a pretty good job of finding the target. But then with the lighting conditions changed, it was a real problem. So, and then there were a couple of times when they didn't get out there. There's always a time they have when you get out on the field and do some calibration, like for your cameras. And first time they didn't get out there, first event we went to, next event we went to they did, but then still it just didn't seem to be working correctly. So, so the first thing I'm going to do is I'm going to reset the values on this. So this is just like it comes out of the box. Okay, so the first thing I did was I downloaded, this is Piximon software, and the camera is a Pixie CMU 5, and so I bought it on Amazon. It was $67. Our team has a Prime membership, so that we get lots of stuff within 2 days, or if we need it quicker, we can do that too. So the very first thing I did was I didn't put the software on the computer. Okay, so no software. So I just have this unit, and I'm really bad about, I actually read instructions. So so I didn't just start like press, well, okay, I did start pressing buttons, all right? But then I read the instructions about how to do it. So so this is just something I 3D printed, but I'm gonna try your shirt, because this is totally unprepared. Now you may need to come just a little bit closer, because okay, it's right there. All right, so what I'm going to do is I'm going to hold the button down. It's just being powered off the USB right now, is all. So if I hold the button down, it's gonna cycle through some colors down here. So it's gonna go white, and then it's gonna go through different color profiles. And so I picked the 4th color profile, and you'll see that it's blue right now. Okay, that's because that's your shirt. Okay, if I turn it away from you, it's not blue anymore. Okay, if I use this instead, oh, hold on, I need to set I didn't set the profile yet. Okay, now it's set. So now if I turn it away, I don't know, is it colored now? Well, it might be getting your blue.
Not sure, yeah.
Your blue's not that close, but
So it's definitely blue as you pointed at Joe, and kind of more of a green.
okay. So now so I'm going to take this object here, and I'm going to hold the button down, and I'm going to choose the red profile. That's the first one. Red is just like you could say the first profile. It just uses colors here to designate which one's which. If you can see the LED, it's pink right now. The object's more or less in the center. I'll press the button, and now it's got a lock on that. So if I show it this, it'll be pink. If I show it your shirt, it'll be blue. So it's picking up the different, it's got 2 color profiles in it now. Okay, so all right. I also have a multimeter here, so I'm going to go ahead and call up the Piximon software now to show you how you can use this to interface with your computer or with your robot. So the Piximon software lets me do some fine tuning, and you can look up there and see it's identified both objects. Okay, and it's placed the rectangle around there. The camera's a little bit off right now, so there I turn the camera so it's right. And so it's putting rectangles around the different things. If I set it correctly, it will pick the largest area, and it's going to tell me where the center of it is, the XY coordinates. There's different ways to communicate that information. So if I go here to configuration, first of all, these are the signatures, and so I could call this one, this first one is this pink object, so I'm just going to type in pink for it.
So when they say S equals 4, S equals 1, they're not referring to like the score of how well it's identifying there. It's just
No, it's the signature. Signature is 1, signature is 4. Now you see signature is labeled pink.
Okay.
And I can come back in and say, all right, this 4th one, this was blue. And so now they're just, the signatures have names instead of numbers. So
But when you were configuring it earlier, it didn't matter which, if you stopped on red while you were looking at him, it's gonna.
red would have been his blue shirt. The red color is only, there's 7 signatures, and so they're just designated by colors.
Okay.
Red, I don't remember from this, like red. Well, you saw them. I could just hold it and go through them, right?
Yeah.
It's kind of like the rainbow, except there's one. Cyan is in there. It is like red, orange, yellow, green, or red, yellow, green, cyan, blue, purple, something like that. Okay, so now open up the configuration again, and I come over here to interface, and I have choices about how I want it to communicate. So it's got a protocol, or sorry, it's going to track you.
Oh, good. As long as it doesn't have a heat-seeking missile.
Yeah. No, it'd be firing a boulder, right? So there's an Arduino interface, SPI with SS, I2C, UART. They have a Lego interface now. And then there's analog and digital Y. So when Aaron told me this kind of got me excited because I always like simple. So if I choose analog, digital, XY.
So it's X, and then you have to just choose another one for Y?
No, you can only get one of the 2. If you do the analog. If you're doing like
So only has one
I2C,
analog output.
yes. So if you're doing I2C, you can get X and Y. But if you're doing analog, you only get one or the other, but you don't get both. Which for us is fine because we want to use this to autonomous. So it's like we drive over the obstacle, and then the moment we drive over the obstacle, now we can start looking for the target. We know the distance. We just drove over the outer works. So the distance is pretty much set. As long as our shot has the right arc on it, we have a lot of, there's a pretty big sweet spot for taking the shot. So that's the idea, is now we just need the left and right. Okay? When I actually mount this on our robot, which we should have this on our robot at TRR, it'll actually be turned this way. And the reason it'll be turned this way is because we want more vertical view, so we can be close or farther away. The left and right, it can just turn some and find it and go, oh, I got it locked. Because there's two pins on here. There's a digital pin and there's an analog pin. The digital pin lets you know there's an object, that it's locked onto something. The analog pin now tells you the position of it. So return this to its position. I selected the, let me make sure, yeah, analog, and I did the apply, so.
Could you just do 2 cameras and get an X out of one and the Y out of the other?
Yeah. Yeah, and at $67, 2 cameras is still cheaper than our network camera that we were using, so. And it's handling everything itself, which is nice. It's not.
It's all on board, all the processing is.
The only restriction is how much megabits you can send back over the network. So you can put 40 cameras in a robot.
And all this processing is going on board of the camera, or is that just the color profile on the board?
Everything's on the camera right here.
Okay,
It's
it's
a-
a system on chip.
Yeah, and it's just out, so right now it's not outputting that XY because I have Piximon running. So if I shut down Piximon now, and just to be safe, I'm going to unplug it and plug it back in.
As our programmer's concern is all that processing power, sucking up all the capability of their, and it was more the bandwidth thing, they were sending video back.
So this thing looks like a light sensor or a limit switch or something,
Yeah.
processing wise.
Yeah, it's just signal out. Are you planning to use the digital one too, Scott?
The what?
Are you planning to use the digital input too?
No.
You're just using a lot?
Well, oh wait, the digital output? Yeah, so the robot knows that it does have a lock. So,
So it'll tell you I have an object, and then it tells you how far away that object is.
it tells you the
from
X.
center.
Yes, yes.
You can have multiple outputs.
Tells you the angle.
No, so if we do it into that analog digital,
Oh, yeah,
yes, the camera has a digital output and an analog output. The digital is just, is there an object in the field of view? The analog is your X value.
Is it X or is it angle?
It's
It'd be like
X.
it'd be an angle in that direction, wouldn't it?
It's X. So if the center was here, it'd be
It only has still.
like 1.7
You
volts.
need a.
So your
0
zero
volts,
is the left edge
3.3
or the right
volts.
edge? Your 0 is the left edge?
Zero's left.
You need at least 2 measurements to get angle. You need 2 sensors separated by distance.
So I'm going to set signature 1 here. And then make sure I've got the analog X. There we go. Okay. So now if I look at the voltage here, that voltage is telling me, I may need to reset my. Yep. So now as I move the object around, the voltage is the X coordinate of the object. I still see the color of the object, so it's giving me an idea of how well centered it is. But,
How quickly does it respond?
well, let's see.
Well, right now, you also have the response of the meter.
Right, and it was still, I mean, I moved it, as quick as I moved it, I saw the meters changing, so I think it's pretty fast. I think it's like 20 milliseconds maybe?
Most of the delay is probably the refresh rate on the density.
Right, it's the delay is here, not in the camera. There's a lot of documentation on the system, so,
Because if your control loop, say you're trying to aim your robot, if your control loop is too fast, then it just falls apart.
So here's the CMU Cam 5 Pixie documentation. So,
This is like the new light code.
let's see, you were asking how quickly it,
Your refresh rate.
yeah, I want to say it was 20 milliseconds, but I don't want to take the time right now to look through it.
But they document it.
Given that you're comparing the time of an electronic activity with the time of a mechanical activity,
Yeah.
it's very unlikely that that will be the bottleneck.
Yeah, but you need to know.
No, I mean to say, the.
No, I agree with you, but you need to know what the specs
We should know, because this,
ahead of time, because it might not be that way.
Yeah, if it is poorly designed, something.
so anyway, so this just seemed really cool. When I got it in, I started playing with it, and it was like, wow, that was pretty easy. The one thing that I have had a little bit of trouble with, and I just had it again, and that is, like I didn't know, and I couldn't find anywhere where it really said that I can't have the Piximon, like if I turn the Piximon software back on right now, so now the voltage is not responding.
Because it's sending the signal to the analog output.
I think it's sending the signal to the, I think it's using the USB to communicate, and it won't use the analog at the same time. So now if I close the Piximon software,
It just jumps as soon as you close it.
yeah, the voltage,
Yeah.
yeah. And I didn't see that anywhere in the documentation, and so that was a little frustration for me when I was first playing with it. And I kept trying to look, like, how do I enable, was there some way to enable the analog X or analog Y? And I was missing it. And there is something here in the documentation that tells you, something about, it can only do, like, if you have I2C going, you can't have analog X, which makes sense because they're using the same pins anyway. If you look at, there's a port diagram here. So we'll look at the port pin outs. Okay, so pin 1, and that's how I have this hooked up. So right now, pin 1 is the digital input output. So this is telling me whether it's seeing something or not. Okay, pin 2 is 5 volts. Right now I'm taking 5 volts off the USB cable, but I have this connector set up so I can take 5 volts off the digital power rail, off the power rail from the Robo-Rio. So I'm not going to have a special voltage setup, special power setup for this. I can just plug it in. I've got 2 PWM cables here, 2 PWM crimps or housings that I can plug in. The Robo-Rio can handle about an amp, I think, on the 5 volt power rail. It's 1 or 1.1 amps. This draws 140 milliamps, so 0.14 amps. So it's not an issue, but unless I had 9. For those of you that want a bunch of them, 40. And then, let's see, pin 3, that's my analog out. So that's what I'm hooked up with the multimeter right here. And then I also have 6 and 10 connected to ground right here. And the only reason why I did that is because those wires run to these PWM housings here, the 3-pin housings. And if I don't have 2 wires, 2 crimps into it, when I plug it into the Robo-Rio, if there's only 1 crimp holding it on, it doesn't stay well. So I always have the students put at least 2. So this is my analog signal and ground, and then on the other one, I have digital plus 5 volts, and I have ground on the other one. That's all I have set up. So I think that's all I know so far. Yeah, there is a pan and tilt I don't know if you saw, when I was looking at Piximon, when I was looking at Piximon, you have, there's a pan and tilt demo here, and sort of a signal. And that's for you to do, I guess, have it automatically track it.
How well does that work with the retroreflective tape that we're typically given?
Sorry, what?
How well does it work with the retroreflective tape that we typically put around the bowl?
Right, so, my student, he was playing with this. Of course, he didn't want to use analog X and Y. He wanted to use something else, more complicated, I2C or something, for whatever reason, because they like complicated. But they spent a little bit of time trying to get a really good, match on it, and it did a good box around the target. But we hadn't tried a lot of different light settings yet, different lighting arrangements. I have done, in fact, we could kind of try this right now, is if you, so I'm showing this, lighting this up here, and if somebody wants to go flip the lights off over there, or at least one of the switches, and see, how well does it, the lighting conditions change. So maybe what I could do then is set another color profile, because it's going to, you can have up to 7 profiles in there. So for this lighting condition, I could come in and set another signature.
Can the processor you connect to it change what signature it looks for?
It looks for the largest one,
So it's scanning all signatures and picking the largest one?
yes. So I think right now, if we turn the lights back on,
It should switch back.
so it's seeing signature 1 now. So I could set it for different lighting conditions. So in the case of, you're at a field and one end is a little darker than the other, you set, and like, I know when I was watching people at Champs and they were setting their cameras, they were doing them from front, left, right, on each end. Well, that would work with this, because you have 7 signatures and they would only need 6, and they could see the target from each side then, each one of the 6
When you
targets.
power it off, is all this stuff lost?
No, it's still, so I'll
It's
power
in
it
some-
off.
It's
So
in some
you said that
non-volatile memory.
Front left with right, because the lighting conditions would be different?
Yes, that's what they were doing. We just shot from the front, so we only did the front.
On the field and where all the lights are up top above you and everything else, you
Right,
could
right.
have a good lit row on the right side and left side's dark or something. So, in every match field.
So now if I call Piximon back up,
Yeah, how do you do that if you had a competition and it's got like 3 fields that you're competing on?
well, you're competing on, so there's the,
No, they never, the only ones where you can get different bills in MSC. There's never a time you're being able to except MSC. Chance run on one field until next Saturday, and that's all they're not saying.
there it is, so I power cycled everything. And so we're still getting the image.
Dixie Mom, get you there.
What?
No, we're just talking about, would it be nice to have a problem with the online side?
Oh. Yeah, it is nice.
Yeah.
Okay, I don't know if I had anything else on it yet. I think that's all I got.
So this, I'm sure it won't do distance, it won't do color.
It only does, well, it only, what do you mean?
Like the distance range,
It doesn't do distance ranging on its own. I mean, if
combine it with two.
you're doing like the I2C, I don't know what all the information is, because it could give you the size of the rifle. I'm sure it does. So if you've got the size of a rectangle,
It
then
doesn't know
you can do distance off of the target.
because it doesn't know the real life size in the out there. It can only give you what's in the
Right, but if you know the real life size, you can,
And you can do that.
Yeah, and I'm almost 100% sure.
if you know this real life size and the angle,
Straight home.
Right, you get real, yeah, you get
you need the angle as well.
You need the width of the object, and then you need the X and Y width of the.
Right. Once you
Okay,
have the
but
X
you
and
also
Y-
need to know your angle,
You can figure that out, though. If you have a, square thing and you go like this, then the top part's the relative.
Oh, I know what
Like, all the rectangle changes. Yeah. If you
Oh,
know the
okay,
true
in both
rectangle, you
dimensions.
know what's,
In both
you
dimensions.
know what's shown to you.
As long as you know what you're looking at and exact dimensions of that, you can start calculating angles and everything else to measure your distances.
So the thing when you were talking there a moment ago and you mentioned the lights, and so I was like, oh yeah, the lights are sometimes a problem. You see the lights back there, right? So you can come in here in the settings and you can tell it, let me see if I can find the right place. There is, maybe that's only on the, so there it's blacked out the light, but I guess that's only for, that's not saved on the Pixie. So you don't, so when I just did that, all I did was do that in this view. But if I am just running the Pixie, I'm not gonna be able to, I thought I could,
There must be a way of, if you use the I2C, to go and set it to do that. To maybe initialize it to do that.
maybe, I don't know yet. I was just pretty happy with what it was doing so far.
In theory, Phil, you can also, you could connect it to the USB or whatever, you have to write all of the code, but you could write all of the code.
So, you said, how things they calibrate to the center, right and left, center is easy. When you calibrate to the right, left, but through the camera, you can't possibly know if you're at the right or you're at the left. You can know you're definitely either at the right or left.
Right, but so in this case, it doesn't matter, right? Like,
In this
it's just-
one.
You're just assigning values to it, and then it just allows that object to be
Typical
tracked.
behavior would be
Right.
identical.
Right, the behavior would be identical, it would just, it just
As
allows
long
you
as
to track
it's
those
matches
6
up.
objects that are slightly different shades of whatever light you're shining.
As long as it's matched.
And I don't know what, because I was watching like 1241 was out there while we were on the field. And so then they were going to each side of the tower. So I don't know exactly if they were just trying to find a value that worked best for all of them, or when they're on the right side,
No, but as he says, since the field is symmetric, you just need to know that you're not in the center, because you're.
Well, not even if you're not, sorry, as long as you just know the target's in front of you, that's all this camera is checking about right there. You just want to know that it's centered, whatever the target is centered. What most of the teams, a lot of the teams are doing during camera calibration isn't even doing the full calibration. A lot of them are just taking photos at those sites and then using the photos to calibrate afterwards.
Yeah.
You're gonna have a lot of time on the field.
right.
So they're taking just photos of the image, getting what is reflected back, and they do all that.
That's what my guys would, they would do a screen capture, and they would have the information so they could come back and look at it later.
Yeah.
So,
So if you end up, hey, we can't shoot from the right side of the field, fix it. You now have it, and then you can go over it.
Right.
Get it that way.
Or, you can't shoot from that side, so you don't go there.
Or at least somebody trying to.
You just don't let anybody else know it unless they're
Hopefully they have
really
it
good
down
at
there.
scouting. Okay, I think that's all I had on this guy. Sorry.
What other vision systems do people use or software?
So I have a slide out, I'll talk about sensors, but basically, so vision stuff is a very wide open field. So you can go from the oldest thing we used to have was the original CMU cam, which was not nearly as nice as how they've gotten to the 5 version. And it couldn't track a lot of things, it was pretty bad. It would give you basically all the reductions going on. This is much better at doing tracking and forward. You can do onboard robo radio vision tracking. So like there's LabVIEW blocks for it, there's some Java stuff for it, either over a USB camera or a network camera. Or you can offload processing away from the rotary, so the processor rotary is not training on doing all that. You can have it do it on either an onboard processor or an onboard coprocessor, so something like, there's teams that go all the way to using sort of small laptop, which is a little probably too much, to other microprocessor boards that you've heard of, Raspberry Pi, Eaglebone,
Jetson.
quite a few Jetson if you want to get really crazy.
Yeah, that's what my guys did.
The Jetson TK1 is really advanced GPU, lots of cores.
And they only burned up one.
A lot of teams here were using
Oh, no.
a little thing called a Kangaroo PC, which is a Windows 10 Windows development board, so you can like directly run Windows on it. It's called a Kangaroo PC, about $200, and it's a little thing that went with Windows, so all the stuff that you would run on like a driver's monitor, how my kid is good at programming Windows apps, they can do it there. RIP is something that was released this season, that's graphical or like something, image graphical or image programming. And it makes it much easier, so it's kind of like Piximon set up where you can go in and be like, oh, this is the target I want, and this is how to get into the color shading and everything. So instead of like figuring it all out, it's a nice little movie that lets you do it. I know that was John, it was less thinking very good one, I'm not sure.
There were a lot of settings in Piximon where you could do, like, when you do a color signature, there's a slider you can move that controls the, I guess, how much it rejects or accepts signals. And then you can like have a minimum brightness and you can adjust the camera brightness. So I didn't play with those. That was something that supposedly my students played with when they were working with it, or the programmer was playing with, programming his two helpers.
So most of the vision processing stuff is run through either what's called OpenCV, which is Open Computer Vision, which is an open source one, or the NI Vision libraries, which is the LabVIEW vision stuff. And it's just kind of where you're running through either one of those two pieces of software. I'm pretty sure you can use some of the OpenCV stuff. The other,
So the OpenCV, you mean you're not doing it on the rotary?
you can run OpenCV on Roborio. So some people do run OpenCV on Roborio. It's just, you have to make sure how much are you attaching it. You don't want to stop getting drivers.
And it coexists with LabVIEW?
I don't think you do it on LabVIEW. I've never heard of anybody doing it, but if you're using LabVIEW, most of the time you can do LabVIEW stuff. If you're doing it for Roborio. What one cheesy boost this year took us all to kind of where I think they'll eventually get to. I started running with December a little bit too, but never got out of it or what. But they use an Android phone, they're running a whole X5 on theirs. So it uses that camera, does all the processing on board, and sends it back over USB to Roborio. And they work there.
And you
Those
said
guys are crazy.
the bandwidth constraint you said is on what goes from the camera to the Roborio, right?
No, so the bandwidth constraint is what you're broadcasting over the network.
Okay, I
Like
see.
wirelessly to the field network. So you only get 7 megabits from your Roborio to your driver's station. Anything on board the robot can use as much as you want. But they don't care. Yeah, they don't care what's happening on the robot. You can have 20 computers, gigabit Ethernet, you can do it.
As long as it doesn't suck too much power and survives the.
Yeah, as long as the battery can power it, you're
No,
fine.
they don't care. That's your problem.
The Android stuff will eventually get built more, like it's still tricky right now, just even getting the computers to connect and talk to each other. Like playing around, you can kind of make that work. But I think
So when they use a smartphone, that makes sense. How did they get the cost concern? Some of those are $400.
yeah, the ones that aren't, just aren't.
Okay.
Probably on
The
TV
next
and-
fives aren't.
Okay.
Fine for less than that.
Yeah.
I can do it, I mean, I was doing it on, so just sending like the video back, so like I had a whole setup where I was using, on Black Friday, last time I was selling $10 Moto E's, and I had it where I could plug it in over USB to Roborio and send the image back to the driver station. And then in theory, you do the processing or whatever, you write an Android app on that and do the processing and send back at it. I never got that far, I never did anything like that. But yeah, this is a very simple way to get running.
This was another this was a processor that my guys were going to use in 14.
Yeah, you can use things like this.
So
Those are the little things, 'cause any Windows in my kid, but it's too problem. We don't have to boot out, it's just hit the power switch and never actually does anything else.
right, well, it's the same thing with the Jetson.
Yeah, any outdoor computer, you have to be kind of careful with how you're turning it off, turning it on.
So the Jetson, when they would get to, they were doing vision processing using the Jetson, I know that they would keep the robot powered up, and then they would press a button and hold it down on the Jetson to put it in the power down cycle, so that it would power down properly, just like you want to shut down on a laptop or something.
One of the nice things about the eventual task of using the Android phone, which will be coming at some point, for a lot of reasons, namely because FTC is all using Android as their control system. We can get a lot of stuff that a lot of students come up through there. Not just like online, but one of the nice things about using the phone is they're allowed to use its battery, so the phone just never shuts down, or you don't need to. So it can be running vision processing the whole time, and it's always up, you know. So they're a lot more about your battery than your vision processing support. Okay, how do you want to go through the rest of the stuff? We want to start with component,
You want what?
how do you want to go through the rest of the electrical?
So I'll follow your lead. I think everybody knows the basics, except we have one person that's kind of new, right? Who else is brand new?
We'll just sit over here in the parent section.
Well, that counts for
We're
something.
supporting Alan.
Oh, you're supporting Alan,
Yes.
so you're brand new, but you have him.
Yeah,
So-
exactly. We don't need to know anything else.
4192.
I'll handle this side here.
So if we wanted, I could sit down with like 2 newbies that we have here and kind of show them on my computer, kind of what I would say that they should do, and then you could talk to the other people about, like a breakout.
Okay, so let's see, so we can do, so we can get that robot to do everything on it, mostly, it doesn't have a rewrite, I can grab the other ones. So what do people have questions about in terms of electrical stuff, that people have done it a little bit before? I kind of want to get a feel for what we want to talk about. So everyone, this is we have the breakout section where we talk about what is your everything and kind of what's into where. We want to talk about electrical best practices stuff, how to like not have radios reset.
Where were you looking? I mean, there's some specific little questions that we've got as far as the practice of hot gluing your connections into the radio. Standard, is that?
We don't hot glue. We use
I've
Goop.
seen it some.
We use Goop.
It's between team and team. So we did for a little while this season. Maybe
There's a blue Honda parked out in the parking lot.
no.
They need to move it for the food truck.
Oh, do you have a blue Honda also?
Blue Honda too.
Oh, I have 2 blue Hondas.
Scott, you were saying something different?
So we use Goop instead of hot glue. And Goop is just an adhesive, but it's like hot glue in that it stays a little bit flexible. The thing I like about Goop is I consider the hot glue to be a little bit more brittle. And so a lot of times the hot glue will, when I used to do other types of robots like Best and stuff, and kids would want to use hot glue to hold 2 things together, a lot of times you could just like pry it a little bit and the hot glue just pop. Where with Goop that's not going to happen. So it's more like a silicone type feel to it, the flexibility, but it's not. So it is flexible, so you can pull it off, peel it off the connector and stuff like that. I'd say the only thing that my kids do wrong with the Goop is they like it too much. So they use they'll put too much of it on, more than they need to, because the idea is just to keep it from rattling loose. Or in the case of the radio, that's a place where we used to have a lot of problem, was the power to the radio.
Right.
And so it'd just do this.
Yeah.
And all it has to do is just brown out for just a minute. So that's goop there. We didn't have very many electrical problems this year or last, so we've been really fortunate. But one that we did have that was kind of bizarre was, so every time the kids drove over an obstacle, almost every time, the robot radio would reset. And so, you know, we gooped the connector, we checked and make sure all the wiring looked right. A problem we've had on like the voltage regulator module or the pneumatic control module is sometimes if you have a little whisker off the wires, that just that little bit of whisker can short and it cause something to reset. So, you know, we looked over everything, we couldn't find a thing, and finally after, I guess somebody was watching it as it went over the obstacle, the battery cable was coming over and just tapping the top of the breaker, the main breaker, just tapping.
It wasn't opening the breaker,
It
but just long enough.
just tapped it, and the only thing that would reset was the radio.
Your main breaker.
Yeah, it was just tapping. So when we were at TRI, Kleinbots, they've been telling us, you know, they came over and they asked questions, and they said it just keeps like resetting. I mean, it's perfect when we're in the pit and we're moving around and shaking and all this stuff and nothing happens. The first time they drive over an obstacle or a rough crossing, and then the radio resets. And so Emily and I went over there. She was our electronics sub-team leader. We went over there, and like immediately we saw the power cable was loose. We just said, you know, we just think you need to tie this down, that'll solve the problem. And it did. They also replaced the main breaker because it had been hit a bunch of times, but I don't know if that was necessary. I think
Yes, it was something on Cheap Delphi they were talking about. If you barely tapped it and it would do that, that's a bad main breaker. You should replace that as
Yeah.
well.
Yeah, that's the breaker. It's one of the few actual flaws of the main breaker. That's probably the most reliable part on the FRC robots. We've had it since, I want to say, 2000. It's been the exact same part number. So the main breaker is pretty good at what it does. Okay, so do we want to do the split thing in the sense?
I mean, I think it would make more sense for the
Oh, we did.
brand new people. I don't
We've been
suppose-
experiencing this since Alamo, so probably.
So the two brand new people, does that make sense to you that we would just, we could just go set and talk about what you should do as, like, once you get your kit of parts with the wiring and everything?
I'll go too.
Yeah, so anyone who wants to kind of get the basic refresher over how the electronics work, we'll go out with you.
Yeah.
You can sit on nice couches with the robot.
That'd be good.
You mute your mic.
Mute my mic?
Yes, they're recording the whole time, so that'd be weird.
Press the button on top.
Yeah,
Okay.
or you can have it all the way down.
That would just hold the button down, right?
Well, let's think about this too.
I want to know what they're doing now, what's happening in here.
So we're gonna go over the kind of more detailed wiring stuff, of how to not have the robot radio reset and everything like that.
So, Alan,
Yes.
you're going to get a copy of all these documents, right?
Yes. Yeah, this one, I can give them to you guys for sure. I was working with Al to try to get it sent out to a bunch more people, but Al being the lead robot inspector, chief robot inspector. So, this is basically, after this season, when a bunch of people's radios were having all those issues, I compiled a bunch of stuff from other inspectors and stuff that I've learned through fixing all the radio problems, and kind of just went through how do we not have radios reset and keep robots on the field as much as we can. kind of general things, you can start running into problems. Strain relief is one of the bigger ones. Just because you get wires pulled out throughout random places. Not every, if you can do every single wire, do it, but by no means you have to. And that's normally just a zip tie somewhere. Just probably take the robot out.
You want me to take it for you?
This will be much easier. That's some example of what's going on.
That's right.
Thanks.
Alan, are you sharing all these with us?
Yes, we can. I don't see if I can do it right now. Do it to the folder that will be shared. And are there crazy frequencies on crazy respectful?
Oh, I
No
feel
judging, no judging.
Ours is just this.
It's that one. Okay. Okay, so, right, any way that you can strain relief wires is a very good idea. This is the one I don't understand how TVs don't do. Before any wire goes on a robot, pretty much I get gunning, almost everyone. Myself or like 3 other people on the team have the ability to pull as hard as is necessary to make sure we actually break everything before it's going to break on the field. Because no matter what the crimper is, you can still get bad crimps every once in a while, and a bad crimp just ruins a match when a motor dies or something. So pretty much the only ones we don't do are Anderson ones, because that crimper pool, for the most part, gets it right every time. That's the only one we have, because it very rarely fails. All the other ones do.
You should still do the Andersons, just as a matter of course, because people put the wrong size wires in those. And
Well, so it just depends on who's, so if one of our electrical people is doing it, they're doing it like on a talon or something that's the right wire and everything. They know they don't have to give you the touch those other ones. We do have all the small ones, yeah. If we're doing something out of the ordinary, we still do. It's just if we're doing, if it's the 10 or 12 gauge that we know it is, we know it's the right tool.
I would suggest you add a step where, well, I would put it in terms of whoever crimps it, as soon as you crimp it, you do the tug test right away. Because people will do a pile of wires and say, I'll come back and do it, and they don't do it. So it should be as soon as you crimp it, you do the test. Otherwise, it doesn't get done. And secondly, that somebody else comes through and does a pull test afterward. And the mentality of the first person is different when they know someone else is going to come look at it.
Right, and if I was that detailed over this whole document, it would be like 8 pages, so I can't do that. So like, it has to be readable and people have to actually like, hopefully gain information from it. I agree, but we can't do that. There has to be some amount of people actually using the document, because it's already 5 pages. Tug testing is probably one of the biggest things you can do to avoid electrical failures. It happens constantly that wires pull out. We still have wires pull out over time, but if you tug test them, at least it prevents the failure quickly, or prevents the quick failures. Same with bare wires being exposed. I'm constantly amazed by looking at people's robots who have copper sitting around, and they're like, that's not going to short. It's probably going to short. This is especially a problem in any of the little screw terminals, like the Robo-Rio power, any of those, even the wide Mueller connectors or everything, the push connect that are on the Robo-Rio and power diffusion boards and things. So anywhere where there's a wire being inserted, there shouldn't be bare copper. So especially with like wide Mueller things, we get a lot of bare wires there. You're sitting right next to positive and ground. They touch a little bit, and that's when your 5-volt rail starts dropping every once in a while. You get all these intermittent failures because it's just when 2 little wires are touching together and ramming into the shock. Proper quick disconnect, so we were talking about Anderson connectors and a proper crimper. Very important, so pretty much every motor we have gets one of the little Anderson power poles on them, and we have a proper Anderson crimper. You can color code them to whatever you want. We just made the switch this year to all be purple and white, so most of our stuff will know that it's ours.
And there's so many colors available
Yeah.
in those connectors that you can color code everything, so that if you had to disconnect different motors, you knew you could only match up those colors.
Yeah, if you want to color code stuff, you can. Depends on how crazy you want to get with it.
Right.
We do it all. We label most of it, and just buy in bulk the colors that the two colors that we want. This is another one that people don't quite realize. They route the wire through something that's going to be moving, and you start pinching things. We had a brief problem with that. Where there was one way you could route the sensor to the ball sensor on our intake. That was totally fine and never failed. Like if you zip tie it to the bottom of the tube instead, as soon as the intake would come up, it would just cut it every time. Like, how are people still, like, we eventually trained it out of people that if you ever cut that wire, you can't zip tie it to the bottom, or if you ever have to move that wire for some reason. This is a big one people don't do. They'll just, in queue, they're not looking at
Other
the
question?
It's kind of off that point, when you mentioned that you've had that problem before. To what extent do you get involved in the kids doing that? And do you point that out to them, do you guide them?
Oh, yeah. If I notice it, we fix it, especially during competition season. So off-seasons are very different, like we saw the way it ran at your eye. For the most part of the off-seasons, depending on which one, how involved I am, what we're planning to do with the coaching stuff, I give it to the kids entirely. Mid-season, a lot more of that is, because I'm there with the robot and the drive coach and stuff too, so even in queue, we're checking things, when we're back at the pit, there'll be people in the pit checking things. And it's a big team effort to try to catch all the little problems. There's tons of little problems, there's so many. And we don't have the process in place that a team like 118 does, where they can, like, here's a copy of their checklist that they have. We got closer this year, no one near that good. But we try to get through little problems, but they still pop up. But yeah, we're doing everything in our power to avoid that. Colors and gauges, this is more of an inspection thing, but it's amazing how teams can get this so wrong. There are so many times where teams come and have to rewire the entire robot because they decided to use green wire everywhere or something that's not legal. And it's getting better now, I think, but for a while there, pretty much every year I was at one of the events I was at, we have to rewire large portions of teams' robots every legal wire.
Read the rules.
Yeah, we standardize pretty easily on 12 and 18 gauge, where anything that needs bigger than 18, we use 12 for, and anything that needs smaller than 18, we use 18 for.
But you're still using PWM wire.
Yeah, still needs PWM and stuff, but
You're talking about power.
just power wires, where if we need to power something, there's no, like, if the motor happens to be on a 30 amp breaker, and in theory you could use 14 gauge, we don't. We just don't know 14 gauge, so that nobody ever plugs it into a 40 amp breaker. The weight savings and everything isn't worth it. Like, we only buy.
Simplicity of
Yeah.
parts and.
Yeah, we use 10 for some of our drivetrain stuff, but largely if there's some mechanism or something that's getting like a 12, just because we have a bunch of it and buy it in 100 foot spools. This is another one that we do, or I do most of the time, kind of depends on who I'm playing with, but in queue, when you're kind of doing that, oh, your robot's nice, you know, giving them compliments and stuff, I'm also looking through and noticing really bad things about the robot and trying to fix it prior to a match. So there's like, if you're playing with us, I'm often like zip tying people's batteries or anything zip ties to do that so that their battery connector doesn't come off in match. Like I'll actually feel around and pull while they're 6 gauge at the power breaker, make sure it's actually tight. Like lots of things to your partner's robot to help avoid them dying in match too.
Do you get feedback back?
Do they get mad at you? Very rarely, and again, it depends on who, right? So I'm not like putting my hand in like the cheesy poops robot and checking their wires. Like it's a very different level of you gauge the level of how much you trust them to get it right and how much you can do. And some teams don't like being around you. You kind of gauge that from where they're at, right? Like you start a conversation with them about their robot, and you start talking to them, and they're there standing with you. I'm not like very rarely like sticking my hand in the robot where they're not around. That'd be really weird. I wouldn't want something to do that to me. I'm not doing that to them.
Do you ever feed that back to your scouting team? What you fight?
I mean, it comes up during our scouting meetings, where we go, no, we played with them, there was a giant mess around our lines, like, we couldn't, like, part of our thinking is, can we repair them quickly if we need to, all that kind of stuff, and we do that during the scout meeting. Batteries are another big one, people don't take care of their batteries. We don't do as good of a job as I would always like, but it's pretty amazing how bad some people's batteries and wires are running off the batteries. This is a system that I've used for a while and works pretty well. Al used about the same system, where you basically add, we completely get rid of the hardware, like the nuts and bolts that come with the batteries, because they're bad. Like, I don't know why people use them. And we switch to actual number 10 bolts with lock nuts and lock washers that actually dig into the battery terminal, so you get a very positive lock and you can never move the battery cable off that at all. Like, it's extremely tight, extremely locked down. Yeah, this is one of the bigger things that has helped us, is just switching to an actual lock nut on the batteries. Like, if you just use the little Phillips head screwdriver and nut that comes with it, you just can't get it tight enough to stay. It's pretty impossible. We use a ton of heat shrink. So this past season, when we got our new batteries, we found a new process that kind of basically like strengthens that connection as much as we can, so we can't bend it down to that joint. I think it ends up with 3 or 4 layers of heat shrink on top of each other, like there's different types involved. But it works out pretty well to get it a pretty rigid connection down there, so it stops being flexible, that stops being the breaking point. Because the place where we most often break wires that we haven't repaired in a while are at the crimp to the wire, or the bare wire is, and if you keep flexing that over and over again, you eventually break it.
This year, we bought a bunch of number 6 welding cable and replaced a lot of it, and that would actually be less of a problem because the cable itself flexes. A lot of the battery cables that you get from Mark or whatever, it's really stiff PVC. So if you grab the Anderson connector and just move it, it transfers a lot of stress to that screw terminal.
Correct.
But with the welding cable, it's so flexible, it just doesn't do it, and it's finer strand copper, which again is more flexible, and it wasn't that expensive. This is way nicer to work with, and especially since this year our robots are really tight, then bending that stiff cable around is just too hard.
Yeah. The better the battery cable you can get, the better you're going to be as well. We don't use the regular Mark cable either, we use some other.
Yeah, something we have to train out of our new students is picking up the battery by the Anderson connector.
Oh yeah, absolutely.
That's the easiest.
That's literally like
They yelled at it, but
that's a very, very bad thing if you do it on our team. That's one of the worst things you can do on our team. You do not pick up the battery by its connector. At all, ever. This is one I don't ever quite get. Teams always, just because Mark ships the battery leads as 12 inches, teams leave them that way. It's just that's the best thing to do. Ours are all shorter than that. I think we went down to 8 was where we finally settled. That seems to work pretty well. It just got a little bit extra cut off, allows it to be a little tighter, and it allows everything to just fit easier, and you get a little bit of a current off because you have less resistance going to the rate plus wire pack.
Something teams might want to consider is, depending on the design of your robot, if this is your battery, you can, often people have the cables tightened on so that they come straight up. Depending on the design of your robot, you may actually want them sticking straight out.
Right.
The only reason you'll fight this a lot.
The batteries can be in any orientation.
Right.
Correct. The only reason I don't normally recommend ever doing straight out is it's very hard to store them. Depending on how you store your batteries, it can be extremely difficult when you're sticking out at the right angle. So we make sure to design our robot so we don't do that. And so that it works in every robot that we use, and other people's robots, and we can still borrow batteries from people, right? So if you design your robot where you need a very specific battery orientation, if you need to borrow a battery from someone, it's going to be very hard to do that.
How often does that happen where you're borrowing batteries?
Ours, it's more like for like demo events and stuff. It's normally never competitions because we'll bring no less than like 10 to a competition.
If you're on a smaller team like that, we used to be with you guys when we lived in Northwest before your time, when we made it to elimination Because as a smaller team, you just couldn't afford it.
Yeah, we'll still in an elim sometimes, like, one of the first things somebody on our team is doing is as soon as elims happens and we see who doesn't get picked, if we have a friend team that we know has good quality batteries, we normally go, hey, don't pack it up, we borrow your batteries for elims, and like, take their whole cart. Like, I think we did that with Body once, and like, had their battery cart for elims. Not necessarily just for us, but for the entire alliance, because you have some random team who may not have batteries, who don't trust the batteries.
Good reason to identify your own batteries so you can get them back.
Oh, yeah, if you don't label every battery you own, like, it should be, like, we label it by year and the number, and then most of ours are named with some sort of color, with respect to, so we have like a aquamarine battery and all sorts of weird ones, but, so we know which ones have been used in matches, and which ones, you get some of the kind of weird, people thinking that one battery is better than another for matches and stuff too, but most of them all work at this point. Yeah. Number 7 is never lift the battery by its wires. This actually does very bad things to the internal of the battery. You can completely dislodge the connectors on the inside. And then you don't necessarily notice that it's broken, but it is. This one's a little bit hardline, but largely, if we ever drop a battery, we label it that we dropped it, and then we try to avoid ever using it in a copy of the match again. Because you're just not sure if you have a damaged cell or impact on the battery is a very quick way to damage one of the cells on the inside of it. And if it happens, you'll be just chugging along at 12 volts and then drop to 8 because the entire cell will just be gone. And that was not a fun way to lose a match. So we normally don't ever use a drop battery in a real match. We think demos and stuff until we determine that they're okay, but we still won't use it in that.
It might also start leaking.
It's really hard to get the sealed lead absorbed glass panel to leak.
We had one crack open and got acid everywhere.
Right. It's very difficult, but I mean, that you'll notice quickly if you drop it. It's more just if you drop it a little bit, like if it's a foot off the ground and you hit it on concrete, you might have damaged yourself on the inside. I mean, there's nothing you can really do to tell, except you'll eventually see it when you use it, where you just get a sharp spike back and forth.
Since every match this year.
All right, so this was the main breaker thing you guys were talking about earlier, where according to Al, 1 in 100,000 of them have this manufacturing defect, where if you tap on it lightly, you'll see the lights flicker and stuff, where it doesn't quite get a full connection all the time.
Anywhere on the main breaker or like?
On like the red power switch, so you literally tap the power switch and you'll see a little bit of failures. They also, some of this is superstition, some of this is real. Take knowledge that you want, so I didn't put all of this in here, but it's most of the time, if you've ever tripped the breaker once, if you've ever actually popped it, it will pop faster in the future. Which I'm not entirely sure why. Maybe it's superstition, but teams like the Poofs and lots of people who have won world titles refuse to use the main breaker after they've ever blown it.
It's a fact, even in general industry, breakers, if they trip before, they trip easier.
Right. So we don't know how much or how often or what it will take, but just to be on the safe side, we normally don't reuse our breakers for competition or about competition or about, like we normally, whatever our competition or about has to do one on it.
Don't they come in the kids every year?
Yeah. So we try to make sure that the newest one is on the competition.
There's, when you, because, especially since you have a DC system, when you open it and you're pulling high current, you'll get arcing and it'll burn the contacts. And even if it doesn't trip easier, the contact resistance will probably be a bit higher.
But Al will tell you it's not true, which is why I don't think the engineering system, a lot of this is run by Al. We just run through Al before we go, which is confusing, but we get some pushback. But yeah, we've always run a new one. Also, you can cool them before a match. Like if you have a robot that trips breakers, it's not illegal to like run compressed air over it before a match, and you will slow down how long it takes to trip breakers. All of the breakers on the robot trip by heat. There's not some magical current measurement, it's always heat. So if you have it cold at the beginning, it will take slightly longer to heat up. Most of the time, it's so slight, if you're gonna be popping a breaker, you're probably still gonna be popping your main breaker, and you should redesign the robot to not pull that much current. But it is possible to do it, and especially between, if you're pushing the edge, it makes sense to cool it back down to at least room temperature, like during high-end ELA matches, that's how we used to do it, our 2013 robot, when we were running 6 in and didn't have a very efficient drivetrain. We would get close, and we did pop it a couple times that year. So before every ELA match, we would cool it, just to make sure it was at least back to normal.
Do you pull anything other than the breakers?
We would blow across the sims and our, we had old 775s as well, so to make sure all of our open air motors were cooled as well, going through E-Limbs. That robot was not built super efficiently. I prefer to have robots where you don't have to do that, but that was built very close to the edge where we were almost popping breakers. This is a pretty easy one for people to fail at. The nuts on the breaker are quarter 28, not quarter 20. So you'll have kids just grab a random nut and you strip it, and it's cross-threading and get a bunch of messes. We used, I think on this year's robot, it was the first time we swapped to actual quarter 28 lock nuts instead of just regular nuts, so we can add lock nuts on there so they don't move. Because we're not going to use a regular nut anywhere else on the robot, we use it on our battery connection. And then I think we have a star, or one of the external two lock washers underneath it too, to kind of grind into the little spade connection with a little lug. This is another one people don't do, insulate the wires at the breaker. This one I check through inspection whenever I'm doing robot inspections to make sure those are fully electrical faded. This is when people are starting to realize it's important, and people have a little bit more now. They've had it for 2 years. But this is probably the thing I do on more robots than anywhere else. Like literally before almost every match to my alliance partners, if they're around and if they feel comfortable, I will just be pushing on their 2 little breakers. I do it on our robot almost before every match. Just because if it ever comes out, it just ruins your day. Because if this guy comes out, your robo really dies. And it doesn't have to come out very much. It can just wiggle a little bit, and then it's
3 millimeters or something.
Yeah, it wiggles just a little bit, and it resets, and it's awful. So we go through and just make sure they're fully down on every robot that we're playing with, and every one that I ever inspect. It's a very little thing, but it works out. In the same way, these ones we need to make sure that their batteries are tight. I don't have the threads on here, but I think I didn't end up finding, I never bought a lot of these. You can get metric lock nuts and put those on there as well. They're metric, I think they're at 6 cents. No, I think I bought the lock nuts on them, we ever replaced them.
Properly? With master or something like that? You get them from a master or something? Probably on it.
So some people use really big lugs.
Yeah.
I don't have the wrench.
You need those skinny lug connections to get onto the.
Yeah, I don't have a good picture of it, but yeah, if you get a really big lug, it won't actually sit on the metal base that's down there, and then it'll like only be transferring current through the nut and the bolt kind of, and not the actual bottom lug connection that it's supposed to be. I've seen a few teams do that, and then you also sometimes can't put the cover on that you're supposed to, and things like that.
Or you get the lug flip, so you don't get the flat side down.
Oh yeah, that's really bad. Don't do that. The flat side should be down, connected to there's a little metal plate underneath it, and you want to make sure the lug on the table is actually connected to it, and you can transfer current well. I think on this year's, I think we did the same thing we do with batteries, where we put that external lock nut, which kind of looks like this, on the underside, so you get you basically get those 2 things digging into each other, making it so it's a completely positive connection, and you can't rotate or move at all. Oh, here it is. So this is the little connection we're trying to bolt to. Oh, this is the one we use lock. Yeah, this is the one you use lock watch on the bolt. That's right. They flipped it around on this one. They're not studs.
Yeah, that was the design improvement.
Yeah, so we have lock washer under that, and then we put another lock washer underneath our connection here.
But then that does make the bolt the transfer.
No, it goes through the washer too. Yeah, so it's the same way we do it on batteries. So we have washers on both sides of batteries that dig in.
That's the one where you're saying if you use the wrong kind of lug, it just doesn't go down, like some lugs are wider.
Yeah, like if this, the face of this lug right here, like literally this tab, will just be too wide, and it won't actually contact this thing, it'll hit on the plastic. And that's a very big problem. There's a lot of debate about this one, this whole section on wire ferrules. What's it? They have. We really like it. We found a system that works pretty well for us. The crimping gets a little weird, but it makes it so much easier to connect things.
Do you use it on your power or motor wiring, like the 10 and 12 gauge?
Yeah, only little stuff.
Because we got some and put them on a 10 and 12 gauge, and at TRI, some of them started coming apart for some reason.
And this is not. Some people want to consider that.
Try one. We'll take a look at one of the robots.
Yeah, but I don't know.
Where is AliExpress? Is that out of China?
Where's what?
AliExpress.
Yeah, that's China.
Because we were able to get those from
This is
Ferrell's Direct, so.
Oh yeah, you can buy them from wherever. They're just, for robot purposes, for the most part, you can get them far, far cheaper if you import them. You can buy the same import one.
Is you actually apply heat to it, it'll hook us on the wire?
No, those are just insulated, but we crimp that part of it too, and that seems to work pretty well. So we run that same crimper up at the metal and then back to the crimp too. That holds it even tighter.
You vary it every the crimper, you vary it every time?
Yeah. Fully down. We normally do it twice on the crimper.
So does it not actually close as hard when there's something like that? Because it closes completely, when you shut it, and then it's empty.
Yeah, so there's springs on the inside of that thing. So as it's going, we get very good pressure.
Are you doing this for CAN bus and everything?
Yeah, so this is everything that goes into the little white needle connectors. So the little white needle connectors get it put into it. So all of our solenoid wires going into the PCM.
Has anyone had any problems with those little white needle connectors where some Gorilla student is pushed too hard on it and the little white thing never comes back up?
We had a couple, but if you stick one of the ferrules in there, into the connection and kind of push around, it only pops back up for us.
We had two PCMs where someone damaged it.
And you couldn't get it back out?
No.
Okay, because I was able to do it. I think before I was using the ferrules, like I used the ferrules on the left, but I also take a little Huntington screwdriver on the inside and pop it back up too. Or like get the little metal tab and pull back out and turn the white.
I think we got.
Yeah, so for people who want more, to get some little bit more information about the whole ferrule thing, this is a full white paper on why Mueller says to use them. Al's one of the few people who kind of is pushing not to, but they seem to work very well. They have like a bunch of different shapes you can do and all this stuff. Everything about it says that it's a better way to do it.
So how is that different from soldering the ends, just tinning the ends?
A couple things. One, this insulation boot covers all the wires, so you don't have to get exactly right on your insertion distance, right? It's also way faster. It's way faster, right? So I can do the crimp, I can strip and crimp a wire inside the robot if I need to. It's way harder to get in there. It's
It's really hard to see that.
You also, if you do tin it, you're not gonna get the right profile. It's most of the time gonna stay round, right? And so, I don't know if there's a picture or anything. But the wide mirror connector is just a flat blade pressing up against something, right? So if you have a round thing, and you just press it, you're only contacting the points, right? So the crimper tool that we have generates that square. And so now we get the contact on both sides, and you get a much bigger contact area, you don't get any arcing. They're not designed, if you read all the specs on them, they're not designed for tin wire. They're designed for either stranded wire or,
Right.
This is still flexible.
right. So it's either, yeah, so they're designed for stranded wire or with wire barrels. If you don't get the exact right size, if you don't get the exact right size, that's where you start getting into weirdness. We only had one size from the year, and a couple times we were running really tiny wire that we had to like double over and stuff to try to get to work in a couple places. And those are ones where we would do it and we would make it work, and I would try to test like crazy to make sure that it wasn't gonna come out. But you wanna try to have all the right sizes and do it. Yeah, we had very few problems. I think we had one or two come out all year, with nothing major. Okay, now into the fun part that everyone wants to talk about. So, this may or may not be useful when we talk about the open mesh radio, because currently it's illegal to sell these radios. They had to pull them all from the market. The FCC decided that there was the firmware inside of them was too easy to configure to break wireless standards and things. So you're not even allowed to buy them right now. So we're still running them at off-season events, but you can't get them. So we don't know what the radio is going to be for next year.
So that was a one-year radio.
We don't know.
Okay.
So we might have, well, that one specifically was. The next one may be the same company, just slightly different. We're not.
Same hardware, but different software?
They'll have to, as far as we know, this current radio won't be used next year no matter what. They'll have to do another rev of the hardware. Like, it may look the same, but you won't be able to you may be able to use this one, we're not sure. Like, there may be two different radios you're allowed to use. But the product that they'll be selling next year will be slightly different and have a different model, because they can't sell this one. So there's a bunch of debate on where the antennas are. I promise they're here, because this is an image I took, but this is not an image I took. This is from the FCC filing for it, so like, I guarantee you they're here, because I went and found the FCC filing for the radio, because Al was telling me that they were on both sides of it, and that's not correct. They're on one side and the front. So if you're mounting it in a robot, it's important not to have a bunch of metal surrounding these two sides of the radio, as you're just going to cause interference. The barrel connector, this document has the specs for it, so if people want to get their own connector or get their own wire and things, you can. Several people have used the wrong connector, where you get a barrel that's either the right OD, but a slightly different ID. Like, you can get barrel connectors with different specs. And then you'll just get a loose fitting, and you'll get power sometimes and things like that. Even if you're using the proper one, it's not perfect. So I can briefly talk about either a small amount of tape, hot glue, something to hold it in. We try to zip tie and strain relieve that cable very well, and we still end up with a little bit of hot glue on it.
If you get I've seen two styles of the power cable, one where it's straight and one where it's a right angle.
Right.
And the right angle one is perhaps easier to secure, because if you wrap something around the whole thing, it tends to hold it in.
We've done this on one of our, on the practice spot, but we ended up doing something different on the advanced robot, or on the real robot. Al suggested you basically put, for a very simple fix that works well, you put an adhesive tie down on the top of the radio, plug in the power connector, run the zip tie up to that adhesive like zip tie mount, and now it's much harder to pull, because you're pulling on the zip tie mount, not on the connector. There's no path to pull the connector out. even in that case, I would still somehow positively secure that connector as much as you could with tape or something. People have shock mounted their radios where you mount it on some sort of foam, so you take a little vibration out of it. This is another one. A lot of teams screw this up where they end up using some old Ethernet cable that they found in their lab or something, clips bad or completely gone. They plug it in thinking it's just going to stay there and work, and now they get intermittent connection issues with the Ethernet cable coming in and out. They'll also, some people will bend the Ethernet cable way too tight and actually break some of the strands on the inside of it, because most of them are solid, not strand wire. So you can snap those.
I think I've also seen some teams that'll put a small pigtail with a female connector on it, and then that's what they plug into, so that you're not always plugging into the radio itself.
Right, yeah. So that those, I think they're Ethernet port savers or something,
Right.
or whatever you want to call them.
Same with the team laptop. Have that pigtail, so you're not wearing out the Ethernet connection on your team laptop.
Okay, so power over Ethernet is an extremely nice way to deal with the radio power problems. The radio is really robust in that you can have both power connections in, so you can use the barrel connector and power over Ethernet at the same time. If you unplug either one of them, it still stays on. Yeah, I just found out by testing. But that's very useful, so that if the power does come undone on one side, you still have power from the other. And you don't, it got rid of all of our radio reboots when we started doing that. Yeah, so the Ethernet connection is latched, it's more secure, it doesn't come out most of the time anyway, but having the redundancy is even better. Here's the exact pin specs and stuff for what you need to do power over Ethernet. It's not any of the actual like industry standard power over Ethernets, which use like 48 volts, and they're on different pins and things. This one is specifically 12 volts on 4 and 5, 7 and 8 are ground.
So you're making a custom Ethernet cable then, so you can plug into the VRM?
You can. The other way, you can just, this is a PoE injector that's sold by the people who make the radio. That just takes a barrel connector in on one side and does it. So you're still left with the barrel connector, which is not.
You haven't solved that problem.
Right, not necessarily the best, but you have the barrel connector somewhere else that you can glue and tape or whatever you want to do. You can make a custom Ethernet cable if you want, like some teams do, where they just like strip out the wires and literally just do it that way. What we have done is we were using this guy right here. So we cut the ends of one of these and feed that into the VRM. And then the other end is just Ethernet to the device. So we don't use one of the ends. We just use, which I think we just use the female end. Look it up again, but we cut off one of the wires, get those power leads straight into the VRM. And then this just powers the radio directly. And they're cheap, so they're a pretty easy solution to that problem.
Hi teams, FRC Robotics Engineer Kevin O'Connor here with a video.
First actually releases some really good videos that they don't publicize at all, and they make it really hard for teams to find.
For veteran teams, these are the same Wago connectors, the same
Which
breaker
I don't know
slots
why.
used on the previous power distribution board, so you may already be familiar with this. But if not, these connectors here are the connectors that accept up to a 30 amp breaker. They're designed for wire gauges from 10 to 24 gauge. These larger connectors here are designed for wire ranging from 6 gauge to 12 gauge and are designed for the 40 amp maxi breaker. So I've got a little 16 gauge wire here to demonstrate how these connectors work. You use a small screwdriver, insert it into the connector. You want to try and keep the screwdriver flat. You're ending up on top of a little actuator here. It then begins to open the space for the wire to go into. So then we're going to, we've got that open, we've got our screwdriver held in. We're going to insert the wire all the way. We're going to let the screwdriver down, pull it out, and that's all there is to it. For the smaller connectors, the wire should be stripped approximately 11 to 12 millimeters, which is about 7/16 of an inch. For these larger connectors, it's a little bit more, 12 to 13 millimeters, right around half an inch. So that's the Wago connector.
This might.
Could you use Y-Muellers for those?
Sorry, what?
The Y-Mueller cover,
The ferrules?
yeah, the ferrules for those.
So,
We used them and they, at TRI, they started coming off. They were crimped on there last the competition season and then they started slipping off. So maybe don't.
yeah,
Every wire or something?
Yeah, because of the way the crimper is, it's the same crimper all the way. It's unlike the fast-on connectors or the other crimp lugs where it's color-coded and the crimp
It's a
is
specific
sized.
crimp for that size.
Yeah.
Right.
So perhaps you're at the upper end of what it's really capable of doing properly. It may be the crimper we had. Maybe if you got a different brand crimper, it might do it better, but it sounds, the one we got was off Amazon. It's probably the one everyone else is gonna get. So I think next year we won't do it on the power.
and so the reason we don't do it on our Wago connectors is we've never had problems with them. Right, so I'm not gonna add something to our electrical system if we haven't had a problem before. Those ones are deep enough to where what you strip off and what you insert never leave bare wires. The connection is solid on stranded wire, it works well. We've never had an issue with it, so we're not gonna add something that's in it.
Those connectors are probably originally designed for a couple hundred volts. And so if you look at it, the wire goes way in so that there's enough distance between the actual contacts that it can't arc.
Right.
But the little guys are meant for low voltage, and so they're really close together, and one little stray strand can touch. And at low voltage, you don't have the arcing problem, so they can be really, really close. Those, actually, we were talking to Mark here, those Y-Muellers that get damaged, I had actually contacted CTRE, and they will repair it for, I think, $20. So if you have a damaged one and you can't fix it with whatever you do, send it back. We didn't have time, so I did it, but it's not, I had equipment that can do it at work, but most people won't.
Yes.
The other thing is that, I can't remember the team number, but on HandyMark, there's a team that's developed a tool, but you have to do the black and the red at the same time, but it's a specific tool for those connectors.
Yeah, and you can find them, we normally just,
Instead of a screwdriver.
we just find we normally find the nice, good Phillips or the flathead that we like. Like there's every season, there's one that either it happens to be the one that we're using that year, and it ends up doing it well for all the different sizes and stuff. It normally stays in the electrical box so that it's there, and we like the screwdriver just because you can be farther away, you don't have to get your hand in as deep, and yeah, you don't have to leverage all the time.
I noticed you had something on your agenda on robot design. Make sure when you design your robot, you know, it shows you stick the screwdriver in. Make sure you have space for it, because the original layout we had this year, our head manager was saying, yeah, go for it. And then I pointed out, there's no way you can get that tool.
So the other thing that we've built when we come across that problem, so a couple of our parking spots or some of our tiny things with past robots, what I've done is you can take an Allen wrench and a grinder and make a flathead on an Allen wrench, and then you can just do it from the top over the L, and it works fine. And then you can do it in no space at all, as long as you have vertical space. So we
still have to
definitely
build
grinded
the
our own
wire.
Lego tool before. Yeah, grinding your own Lego tool is not necessarily where you want to be, but it does work. Yeah, so you don't want to tin these wires at all for that same reason. You basically, when you have the stranded wire and when you get that compression down on it, all the little strands fan out and you get a big contact surface area.
Is there any time where tinning wires on robots is a good thing?
Only if you're soldering.
Yeah,
If the joint is completely soldered
should be the only time.
Yeah,
I know there's people, I won't name names, who advocate soldering all crimp connections, and I strongly disagree, because all these manufacturers that make these crimp connectors, they put millions of dollars into the R&D to make sure it's a proper gas type fit, or gas type crimp, or connection, without doing anything else. And what I've observed is, it's taken me a long time to get good at soldering, and most of the people involved in FRC do not spend, they're not able to spend enough time to get good at it. And if you do a crappy solder joint, it either does nothing, or you ruin the wire, you heat the wire up too much and it melts the insulation, and or what's worse is the solder wicks up by capillary reaction up the wire and makes a section of it essentially solid wire. And then, especially on things like your battery cable, if you can really get it that hot that you can make it wake up, then when you bend it, it will fatigue right at the very end inside your insulation, and you won't know it. And it'll fatigue, and then you'll get to where only half the strands are there. And then eventually none of the strands are there, but it looks like it's there. But if you pull on it, it comes apart that much. So I strongly recommend people don't solder any crimp connections. It's a waste of time.
Yeah,
If it's done properly. If it's not done properly, I don't think that it'll make it a whole lot better. You're better off getting the proper tool and learning how to use it. Those were designed to be quick and easy, because probably in industry, people had a hard time soldering the stuff.
I think the only ones, I think we didn't solder any connections except for, we have little flag connections that we use on the back ends of like the 775 Pros, and we solder all those because we don't have the proper crimp tool. It's like we were crimping it poorly and soldering them to make sure that they stayed on.
Yeah. But even then, when you said like, if you're soldering connections together, then you can tend to, when I was hot solder, you always actually create a mechanical joint with the wires and the solder just kind of pulls that. And so tinning beforehand prevents you from doing that. And we had a lot of kids that would do those spade fingers on the back of the motors, and they tin the wire, put it up against the spade and solder, and things would fall right off.
Yeah, and so we even use, we stopped soldering straight to the motor. We use a little flag connector that is designed to fit over those tabs. And then we soldered those to the wire, but then those just go right on and get zipped and it gets strain relieved. So that we don't have to solder these motors, so the motors stay. So we can just pull the wires out and swap the motor if we need to very quickly. So we were talking about wide angular quite a bit. We can get their video, and this one was, I think this one. Oh, I think this one's like a comment or something.
The CAN connections on the power distribution panel, and the CAN connections on the Robo-Rio. Right there. These connectors are designed for solid or stranded wire, though I would recommend using stranded on your robot, ranging from 24 gauge, such as this black wire here, to 16 gauge, such as the red wire here. We'll talk about a little trick or something to keep an eye on with the 16 gauge in just a little bit. When you're using this wire, you want to make sure that you strip to the proper length, which is approximately 5/8 of an inch. This wire on the left has been stripped to the proper length, securely held in the connector. No wires sticking out past the edge of the connector. This wire in the center has been stripped too long. So it has silver wire or copper wire that you can see sticking out of the connector here that can potentially short out. You want to make sure to cut that wire, remove that wire, cut it down a little bit shorter, and then reinsert it. This last wire has been stripped a little bit short, so it looks like it's well secured, but if we pull hard enough, the wire will start to stretch, pull out, break strands, things like that. It's not a secure connection, so this wire should have been stripped a little bit more before it was inserted. This last wire we have to take a look at has some small strands here that have ended up as little whiskers. This is something to be careful of, especially with the larger gauge wire, but you want to...
And this is why we use ferrules largely, is to get rid of this. Just because you can do it if you're taking your time and doing things well, but as soon as you have to do a swap, mid-tournament or something, you have to do it fast. It's way too hard to get it clean and to get a clean insertion while it's in the robot and it's very deep. With the ferrules, you literally just push, you don't even have to hit the white button, you just push it right in and it just works.
Check this on all your connections to make sure they don't have these whiskers sticking out. So I remove this wire, and you can either try and get the whiskers back in line, twist the wire up a little bit, or you can cut and restrip the end of the wire. So to use this connector, I'll pull a couple of these wires out to show a little bit more clearly. So, to remove any wires, simply depress the button. I like to use this little Wago tool, it helps, it's a little bit cleaner, but you can use your fingers as well. You can twist the end of the wire because this connector is intended for solid or stranded wire. So I like to twist it up a little bit, especially with the larger gauge wire, that helps avoid the whiskers. So we're going to depress the button. We're going to insert the wire slowly straight down into the connector. Let go of the button. Do a little tug test to make sure we're securely seated. And no wire sticking out of the connector. And we're good to go. That's all it takes to use the wide muller connector.
Were you able to use the ferrules with the 16 gauge? Because I kind of remember there was one side, I think it was probably the 16 gauge, where if you put the ferrule on it, it wouldn't actually fit in.
I don't know if we ran 16 to everything to it, but yeah, it would make sense.
I think we had the 16, I think just, you had a hard time fitting it in to begin with. And then if you put the ferrule on it, I think it ended up too big to go in those.
Yeah, I don't know if we used 16 anywhere. I think we only used 18 in all of our stuff. So we were just doing pneumatics load and everything. So the only major problem the one that's the hardest to do with these is the compressor in the BCM. But that one we normally just we put 2 wires in and then put Andersons on the end of those wires and leave them in there always, and then just swap the compressor with the Anderson connections. Yeah. Do not tin the wires. Even though they say they're intended for solid, everything I've read has not said you should use solid with these. They make other versions that are, from what I can tell, but I don't think these ones are.
I'd probably argue that solid copper is more soft than strand.
That's true. Yeah, so this just goes through how to do it. Blah, blah, blah. Okay.
When you're checking for whiskers, use a flashlight. Because often this stuff is buried deep and you don't see it well, and then if you use a flashlight,
you can reflect it.
If you notice little shiny bits.
Yeah, if you use the ferrules, you get rid of all of that problem, which is very useful. That was our biggest thing from this year compared to last year, was just being able to push those in really fast, make pneumatic changes or any other PCM changes really, really fast. Okay. So that's what I have on wiring tips. Any other electrical questions?
The other thing is, the routing. You have a lot of models and stuff. People, they just run things everywhere. Give yourself space, like route it in nice channels so that you can troubleshoot wires. You can follow it from the beginning to the end, and if you can't, you didn't do it right.
Right, and also a lot of labeling, making sure you have a nice map of what's plugged in where. So if you just look at your OREO, you can tell what sensor goes where. If you unplug something, you can be able to plug it all back in pretty quickly.
What works well for wire labeling?
So
I mean, you can buy the shrink tabs and things
So
like
we
that.
tried to do this year and didn't do as well as I would have liked, is we actually bought one of the label makers that's designed for like IT pros to actually do wire labeling. So it'll print like the sideways ones that you can wrap around. It'll print a much more flexible label. Yeah, so it's actually a nylon label that'll wrap around and it prints it like a bunch of times sideways. So you can get a much better label. We didn't do the entire of it as much as I would have liked. The wiring didn't come out as clean as I would have hoped this year, but it was okay. It was serviceable, which was good.
Do you have any tips around avoiding electrical noise?
Where are you seeing it?
So I don't remember the exact situation, but we were doing something during a build, and someone came over and we were getting stray voltages on our lines. And he said there's probably like some electrical coupling or something going on. And so what he told us is avoid wires that are too long, so you're not making loops in your wires, because that'll cause coupling.
How did they sense stray voltages.
That's what I'm trying to
What tool did they use to determine?
Off the top of my head, I can't tell you, but what was happening is even without powering on something, something was turning on. So, and he said that was his tip, but
Because the wires in the robot realistically are not that long, and the power levels are realistically
but unless someone
not
uses
that-
excessively long, which we were.
Yeah.
Yeah, so in general, you should, no wire should be longer than it needs to be, right? Like, it just, it's bad practice, there's lots of reasons to not do that. So you're gonna be taking more current, just, you're gonna add more resistance to that power path, so if you have a motor on the other end of it, you're gonna lose power to that motor, right? Because it just takes, it has more resistance to get electrical current.
So
to the motor.
resistance for sure. What I didn't think about, what he said is also, if you're too long and you're somehow trying to fit it in, if you make loops, then
Yeah.
you also worry about
Yeah.
inductance.
Yeah, well, if you make a loop of wire forms a transformer and
Yeah.
it's
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 inductive.
more efficient for picking up the electrical energy than just, well, a single wire is a single turn transformer. If you make 10 turns,
Yeah.
it picks up 10 times the energy. So, but it depends on what you do. If you, like your signal wiring, like I've had the kids keep the like PWM wires and CAN wires and all that, the control wires, away from the power wires. So like this gentleman is saying you have wiring channels, you should really have two. One for your power wiring, or two sets. One for your power wiring, one for your control wiring. Because the energy levels in your control wire is so low that any crosstalk between them, the circuitry that they're using to design these control systems should be able to reject it.
Yeah, and I mean, so you can do that, and if you're having problems, that's one of the things that we'll step to, but you can also run PWM cables along your power lines, and most of the time you won't have trouble.
Yeah.
It's like, a lot of the time, most of the time you won't have problems, right?
It's a rule of thumb that you can get away with it, but if you
Yeah, why-
don't do it,
yeah, why-
the probability that you will ever have a problem goes down dramatically.
Why,
And if you're crossing them always, like if you can cross perpendicular,
Yeah.
that's better.
Right.
I see. Cross, right. Keep
But
on.
even if the two channels are, say, 1.5 inches apart, the magnetic coupling drops off with the cube of the distance. So if you can just separate by a little bit, it diminishes it dramatically.
Yeah, like if you're doing, so if we're doing long runs, if we have like an arm or something, we'll normally do that where power goes to one section, it'll go to the other. But inside the electrical bay, a lot of the times where you just happen to be running all your speed controllers and they have to run along the same path for a while, we normally allow it.
But it doesn't make
Just so you
sense
don't
to have
always
any kind of
space
shielding or anything. That's like overkill.
You have to do something with the shield. You have to terminate the shield properly for actually to do anything. And most people don't actually know how to do it. A lot of the stuff is digital. It is, the concept of the digital signaling schemes is that it is got a very large noise margin.
Right, I got
So it generally resists it. And a lot of, I don't know about the current motor controllers, the older ones used an LED, they had a photocoupler input, and you had to run a fair amount of current for it to actually turn on. So you in these systems, you just can't induce enough noise to turn on that motor controller. And then with the CAN bus, it's got 120 ohm termination, which is a very, at each end, which is a very low resistance. And for you to couple enough energy to make it change state, your system doesn't have enough energy to do it. So you can, to a large degree, run it wherever you want. It was done that way to make it that way. So I'm not saying do anything you want, but a few simple things.
Yeah, that's
and then
positive.
your probability of having a problem goes down dramatically.
Yeah, so in the sense that, yeah, I'm looking for tips like, because even if it's unlikely, when it happens, it's a nightmare to figure out what happened. So
I think
it's better to not
often-
even have the risk.
I think often when people have noise, it is more likely an intermittent connection than external energy coming into the wiring.
Okay, because what we were having is like some random behavior, like movement
Yeah.
from, I forget which
That or
part.
software. Being a hardware guy, we blame the software.
Yeah, well, that's what everyone did.
But often it ends up being the software.
No, so in my case, I'm a software guy, and it was very easy through some very simple testing to eliminate software as a problem, but people think software is magic and it can't do
But
it.
what also happens is sometimes it is happening through the software. Like you've got a sensor that has an intermittent connection, and now the software sees something and gives commands it shouldn't be, but it's garbage in, garbage out.
Yes, yes.
So,
It would have to be, Drew would have to be paid.
Speaking of the CAN bus terminations, is there best practice if you want to terminate not at the voltage regulator?
So I was actually talking to Scott McMahon, who helped design the original Jaguar, like the black one that did the first time we had CAN bus. And he basically said, and what 246 did this year, and what I was surprised by, was basically, unless you go to 500 to 1,000 feet of CAN bus wire, he said you don't have to terminate it anymore, it's fine. And they ran that termination, and they didn't have a problem. They didn't have a problem.
I had the same discussion with
pretty
a
amazed.
guy from Holy Cows who works at Qualcomm. And he said, you can do a star as long as the stubs are not very long. And it sounds like on a robot, you just are not gonna have a stub long enough.
Literally, so
It's all about the star.
you can do what, like, it's so robust now, you can do whatever you want, apparently. Like, they said if you start seeing problems, fix it, but you can probably test a lot of things and get away with it.
It has to do with the time of flight, like the speed of light going down the length of cable. And you're not gonna have a length of cable long enough that you're gonna get the reflections that are gonna cause you a problem.
Play with things you've never seen. We're gonna talk about those too. If you're not, I don't cover, I may not have the pictures up there for what I passed around, so ask if you're not sure what they end up being.
Yeah, there's a sleeve.
Alan?
Yeah.
Can we do a 5-minute break?
Oh, yeah, bathroom break, sure. Questions? Which one?
Oh, this one? No, it's not, this is great.
This thing?
Oh, is it
That's a switch, limit switch.
This is one of the big CNC, like, I found that after 2013, but it would have been great to know, like, if you were running into the pyramid, it would have been perfect.
So in, this isn't like an all dimensions?
Exactly.
It's an industrial limit switch. It's not the little
Crappy one you get fried.
Yeah, you got some idea, right.
We had one switch that used one of those little limit switches as the hard stop for this arm.
Oh, that's a problem we have.
It worked several times until the switch exploded.
No, so I was discussing this yesterday with.
And then it didn't stop anymore.
I was discussing this yesterday with, the challenge we have this year, we have a linear driven shooting, say pixels of all kinds of pictures. So ideally, usually we use a limit switch to stop it because it can't go too far down. As a certain stopping point. The problem is how well it works depending on the rate at which it's coming.
And so these ones are great, but when you're doing the bigger wires,
You cut the motor the right time, but its momentum would keep it down. So we needed to kind of know its angular velocity and stop it at different points. So that's a problem we're currently
That or you know you're getting towards the end, so you slow down.
Yeah, so we were discussing like PWMs, no, I mean what you call PIDs and all things. So I'm still trying to solve that problem. We're working on it right now. We're thinking of using a potentiometer to detect actual position and use a PID to maybe kind of calibrate the speed
I think this is
it covers it, and so if you're using the bigger straight wires.
I think that's a.
So it almost keeps
Some
it
sort of
in place.
magnetic.
Yeah, so it keeps those little bits.
So what is it detecting?
It's detecting the presence of ferrous metal.
Oh, that's interesting.
So
They're trying to plug in something like
cars,
this.
so if you have an arm, you have a.
I see.
A steel piece.
Oh, so almost like a limit switch, but.
Yeah,
Almost like
but
a
it's
photo.
not,
So you would
it's
use
not
them on
contact.
everything.
So we use them
And
on
it's not
everything,
gonna wear
but
out.
one of these.
Yeah,
Because there's no.
because the thing with limit switches is,
So these are,
again, with your speed, I've seen ones where when you do it properly, it doesn't use the switch as a hard stop. You kind of go like this.
Yes,
But then I've seen ones where it went so fast it went like that.
right, oh, I see.
And then it kept going.
Yeah,
You can buy it.
And then those mechanical switches
I
that
bought
bounce.
blue on one
Yes.
side and red side.
And contact bounce, and it is possible for your software to not sense that properly or get confused. And so.
have you guys used potentiometers?
No, mine doesn't.
Our team has not been very good at using sensors.
Yeah, ours is worse.
And not this year, but last year when we went to championship, the head programmer said, oh, it was too hard to use sensors, and I lost it. I told him, okay, look, you go over to the other end of this facility where the FRL championship is being held, and I will tell you, I can guarantee you that 80% of those teams are using more sensors than 80% of the FRC teams present.
That's basically all it is.
It's all autonomous, so at the championship level, they all know how to use sensors fluently, or they wouldn't be there.
Yeah,
They
it's not,
wouldn't be there.
it's not difficulty so much as unwillingness to learn.
Yeah,
Well, there's been so much time.
yes.
They never get to the sensors.
And I think part of the problem or whatever is that at FRC, the mechanical is like so cool.
Okay, so
Yeah,
basically.
Yeah,
and then
cutting and
because
ripping
of
hard
driver
things.
control, you can have a driver that makes up for the lack of sensors. In FLL,
So in
FLL, to progress beyond being a rookie, to progress beyond doing the low-hanging fruit, you absolutely have to use sensors,
So in my
or
case,
you will not progress.
so my daughter is she's a sophomore, she's the only programmer in the whole team, and so by definition, the only one who did, and she's a sophomore, so she's like 2 years ago, didn't know any programming. And unfortunately, I'm a programmer, so I teach her. So it's kind of, she's drinking from the fire hose. And I'm trying to tell her, when you do Java, programming is programming. When you do robots, programming is not just programming. Programming is mostly sensors. Like programming is not writing code. It's mostly like figuring out how you will interact with the world.
It was cheaper.
What sensor makes the most sense?
Yes.
And-
In a sense of what can you learn about the world,
Yes.
then how do you use it in your code?
Either not getting it
So
funded.
you have many options, like when at championship a couple years ago, my son found someone that he used sensors in his FLL robot in a really innovative way. And found someone that used a different sensor to do the same thing.
Got it.
And it was sensing colors, where it had all pieces of different colors. And you had to pick up the one that was a different color. And most people were direct and used a color sensor. But physically, the way it was set up, there were difficulties with it. He used an ultrasonic sensor. And then he found someone that used a light sensor. Because the light sensor had more range than the color sensor. But neither of them were using them to sense the color directly.
So often it's about being as non-innovative as possible. Anyway, I need to use the restroom while I'm
I bet you had that experience.
It's got a top section.
Yeah. This is a hall sensor.
Proximity, yeah. So it does any metal. Any inductive metal, right? So any ferrule metal. So it's still, yeah, but they're very nice. So like we can literally, you can just sense bolts. Right? So you can mount a bolt head on anything. You know, just those are like.
So it's got its own transmitter. Alan, so these have their own transmitter.
I had so they do kind of like cheap banner sensors.
As this green guy is, I never changed proximity sensor.
Never get through the cases, eventually clock. Just my experience. For myself, my wife, even our dog drinks filtered water. And then I like it. Easy to fill, so I just stick it under this bigger
What number of bottles
Is
is
this too big?
We able to get it hooked and actually make it work.
Once you there. Maybe even as simple as things like.
Yeah, we were able to, we're slightly bigger ones, so we were kind of just making do with what we had, and making it so.
There are, we've got
Well, we
seniors
did it in
that
bulk.
I'm okay with them getting refreshing and softening. We want a mentor. The student still has a hand on the machine, but there's a mentor there.
It seems like you're going up with
The bigger picture, where's it gonna go?
Yeah, they were using, I was using power tools last year. Very excited about it.
Sure.
But it's, you know, it might be-
True, but there's also, it's a small signal wire, and it's not pulling any current. And we have more now, what we're doing is it's a test.
We build it like that.
And we made it so they can, and a lot of FRC, you get it to work, right? There's not, it's not a product, it's not going out to another company, we can't repair if you need to. As long as we're not saying basic.
I would not change it.
So that,
So now we don't.
Eventually,
So this you don't go all the way into the order.
So I really actually do it twice, so we do the silver and then the bronze.
So that's a good development.
I scrapped them. And then once I started doing that, I said,
build CDs to hold it.
With the first build.
To me, that seems like a good feature from there.
No, they just said so.
No, I did, I remember like being amazed by, or like, it was kind of like all those things. You know, actually sometimes
it was really hard to find the actual point.
Yeah.
The first one I find that it's that was like $10. Yeah, like 80 or
well, the Deutsche connectors are more like a model type. I guess I like, one is like 50 or so they have a SAR
Oh.
Those are like a SAR pattern instead of a, they're not meant to be
You'll get a special.
I mean, it really would not have. But it was
we probably put a power rating.
They're better than anything else out there.
Yeah, as long
Yes,
as they're
all that.
No, really, we
standard, yeah.
If you
Yeah, just that, the nice thing about Anderson are basically standard across teams, so you just can swap stuff and find it when you need it. Depends on where you buy them, but yeah.
In fact, right now, this guy doing that.
Oh, yeah, we buy the wire connected, we buy the connector separate, it's like, I think on the ones where we get it, you buy this, and then this is like $2. Yeah, you buy the cable already, and then you just
And they're actually used exactly
That's
to work.
exactly
So we have a company that makes cables and make the cables for
Then they
us.
say, there's a checklist.
I never tried to make that myself.
So either on a laptop or on a piece of paper, they should give you a description.
Yeah, so we
Here's
just.
all the parts.
So now I want to go back.
So these guys are. Instead.
I know what these are.
What?
I'm just.
It's a blank,
But then, so they use it,
basically on the side.
we would just.
So, you know,
You've used those before? or-
Yes, we've used, well, just limit switches in general.
Okay, but we take it.
Because she's in a, more of a homeschool situation for next year.
Just after, I mean, they still, one of them, they're still going to have, way back.
We found to make them actually stay at least, because we currently send and make sure current installation. sure you have any failures when you started doing that.
We only crimped the barrel.
A lot of those
Except for the big wire.
So we had problems with just doing the barrel, but we're also, we were only using one size for everything, and so I'm not forcing it over this year. Like, if you go and find the right size on everything, a lot of it. So we buy these at a certain length, so we buy them as 8mm, and that's the right length. Idea from all the express.
The robot, and those things,
You can get them on wire barrels, finding different gauge.
They have a table showing this wire size here, and then you can get different lengths. There's different colors for that size, so this part number is for 20 gauge, and then this other part number, and there's different part numbers for different colors.
Yeah, so we were literally just
It takes a
testing.
little while.
Should we also come and
Yeah, so in the China ones, you can get any color, any size. So I got red and slightly bigger barrel, so we can probably start using those. Yeah, we were like 1,000.
I think they already
And whatever you said.
you don't mind
we
girls
could-
It took a little while because some wire sizes, color selection was smaller, so I picked them so that we only had one red, one green, one yellow.
Right.
So that
more cool stuff on, they take more cool stuff off the robot
wire
than
size.
on your
I think there was one instance where a really big wire and a really small wire had the same color.
Right,
We're not
and
confused.
again, and we're not, and for our team at least, we're not trying to do much. I think we're gonna probably save the red and the blue and be able to make everything work that we need to.
That's
Right?
what,
You can
that's
get into
what
where it'll
actually
say,
attracted my son to.
So other than
and
this,
as long as
the
you're
parents and other.
we only use it for white mailer stuff. We don't use it anywhere else.
You may need to order a couple because some of the stuff like these can wires and some of the other ones, that they just come with, you're forced to use.
No, I see what you're saying. I'm saying, we got through the entire season using just this one and forcing it to work, because all of it is just low level signal
Yeah.
and low power, right? So it doesn't actually matter how you make it work, as long as you can get the current. And so we were able to make it hold with just these. We were okay on this one side.
work with kids, then we can pick up.
So they're gonna go in
We've got about 8 different
And
sizes.
how do you use the size?
on each different wire, right? So-
Different wire
Because
sizes.
you're gonna go from, you have, basically, we would need anything from 16, 18, 20, and probably 22, 24.
Yeah.
So like, if you want to do it, you really need 6 different ones.
Yeah, and then
If
we
you wanna
added
just do it
14 and
quickly.
12 gauge also, so
Yeah.
we have, and I don't think I think I might take those and throw them away.
Looks like you wiring it. Yeah, I don't touch what you get wire. So we try to standardize wire as much as we possibly can, and just the connectors. So like, we have 2 connector bins, that's all we have to take. They're sorted, we know what goes on there. Like, we don't have to take, people who aren't even really trained, we can say, hey, crimp the blue ferrule on there and go. And it works. Okay, I think they're still out doing other electrical stuff, so we can get started on a kind of brief intro to some sensors. Okay, so this is just kind of an overview of everything that's available. Stop me if you have specific questions. I passed some different stuff around, so you can kind of see them. They're gonna be, the stuff on the slide is probably not the same as the stuff that I passed around. So just kind of let me know. Sensors are used to give feedback to the robot, so they're in places where you're either gonna have the robot doing autonomous things, or you need to actually, or you wanna help the driver do a task. If the driver can do it without sensor input, then there's no reason necessarily to give it to them if you're not actually improving their work. Like, largely, you shouldn't just be adding sensors because you can. I mean, if that's what your goal is, that's what you want the team to do, that's fine. We try to do stuff that's gonna help us win matches and be a more competitive team. Right, exactly. Teams like to do cool stuff. If that's why you want to be in the program, you want to do cool stuff, feel free. I have no problem with that. That's just not what I'm going to talk about, and that's not what drives us. Human senses, I like to talk about this just because for some reason there's this giant myth that we only have 5, which would be really terrible things if we only had 5 senses. It would be awful. Like, not knowing when you have to go to the bathroom is a pretty horrible thing. So we have a lot more information coming into our brains, way more than 5 senses. I don't know how we keep perpetuating that myth to kids. But there's even just when you talk about sight, there's so much stuff that we're getting, visual processing that we're doing is more than just sight. Touch, proprioception, if you've never heard that term, is how you, say you can tie your shoe without looking at it, or you can untie something behind your back. It's literally all the little sensations you get from your muscle joints and the movements going on your skin that you know where your body is, even if you're not looking at it or seeing it. You still know where all of your body parts are. Temperature, pain, all those things are normally classified into touch. Taste and smell, there's a ton of stuff going on in your taste and smell receptors.
Are we getting ready to do sensors?
Yeah, we were just starting.
Oh, this is perfect, because they just asked me about sensors. Well, Alan's going to be talking about sensors.
We timed this well. I'm going over how it's a giant myth that the human body only has 5 senses, and it makes no sense that we keep that kids up.
Yeah, I don't know why we...
I don't know, it drives me crazy.
I'm with you.
Hearing and balance. Balance is probably one of the bigger ones that we just tell kids is hearing, I guess. I don't really know. But
It's part of the ear.
it's part of the ear. It has to be the same thing, right?
That's right.
But being able to walk upright and not fall over is a pretty useful sense. And then tons of internal sensors that we never talk about, but things like bladder and hunger and thirst and oxygen and all of these other things that we can your body can tell and you can feel if you're, you can tell if you're thirsty or eating things or your head hurts or all these things that you can sense. So there's tons of stuff on a human and all organisms. Like the robots are a little less sophisticated unless you're building a really cool robot.
Look, I'm going to take notes too while Alan's talking.
Okay.
I'll still help.
This is a pretty basic, there's 2 basic types of sensors. Now we're getting a lot more advanced sensors that kind of diverge from these 2. And we talked about them a little bit when we were doing the camera demonstration. But there's digital sensors, which are literally just true, false, yes, no, binary. Is something happening, is something not happening? They plug into the digital inputs on the RoboRio, so there's a whole little side of inputs on our main robot controller, digital I/O. So all of these are the digital I/O ports. That's where all of these sensors plug into. Only getting a small amount of information, but that small amount of information can be very powerful. You can also receive patterns into it, which we'll talk about in a little bit.
You can also, there's the MXP port.
Right.
So there's a second port on the RoboRio that has more connections on it. So you have 10 digital IOs. You have another?
It's in theory 10.
Another 10?
Yeah, if you didn't want to use anything else on it, you could do all 10.
And then they make boards that plug into that port. It makes it very easy to access those. They give you more PWM connections and stuff.
Yep.
There's only a couple, the boards that plug into that have to be approved, right?
Well, so the boards that you plug into it have to be approved if you're driving motors on them. If you're not using the PWM outs, you can do whatever you want.
Okay.
I'm sorry, Alan, could you repeat that?
So, a little bit of a tangent, but we can go on it. This port right here is called the MXP port, and you're allowed to plug in it's an expansion port, you're allowed to plug in other boards to it.
Like Rev Robotics makes one. Andy Mark makes one now?
Yeah, I don't have the Navex on me. There's quite a few of them. Rev makes some. Navex is sold by Andy Mark, produced by some other people. There's a couple other ones that work. But basically, they're little circuit boards that are able to plug into here, you screw them in here, and you can get more expansion ports, or they can also do different functions. So the one that we use most of the time is called a Navex, which gives us a inertial measurement, so we can do gyro and accelerometer, and figure out kind of where we've turned and things like that as well. But you can also drive motors from them, so they can expand the PWM ports. And if you're using that portion, there's only specific boards you're allowed to use that can do that. So basically, the reason for that is otherwise you could have a special board that was just constantly feeding motor power so that after the match is over or before the match started, your robot could do things. And disable isn't guaranteed to work. So the only ones that are allowed to power motors are ones that first is tested and they know that disabled works and enabled works and we can keep a safe field. If you're not doing that, you can make your own. You can do really advanced stuff on the other. Sorry, back to this. So we're gonna go through kind of the digital sensors that we use most often in robots. The most basic sensor are limit switches or touch sensors or any sort of switch you want to put on the robot. You can very easily have something that's on or off. You can determine the position of an arm or something along those lines. Any mechanism, whether it's up or down. These are little VEX ones that you can run into and you can tell whether it's been hit or not. I think we passed around a couple others.
Over here, they're coming.
They're coming, yeah. So there's a variety of different things that just kind of give you a 1 or a 0. So quite a few teams like these things, so you can just run into them and tell if you've hit something. We used it this year to tell if we were finished climbing or not. For the little while we had a
And that'll be
scale
on,
device.
we're adding that to our summer build to tell when the ball was in the right location.
Yeah, so you can do touch sensors for balls. We use a different digital sensor for balls on our robot, which I believe is the next slide if I remember this presentation correctly. Nope, I was wrong. All right. So the next slide is read switches or some sort of, this is a little bit old, I would probably relabel this Hall effect switch, or Hall effect sensor nowadays. Some way to basically have a magnetic switch. So when a magnet gets near this, you connect the two contacts. So it acts just like a switch, but instead of a physical button, you have something that detects when a magnet's near it.
There's I think it's West Coast has one of these where you put a magnet on like your sprocket and you have the sensor there and it just measures the rotations. So it's a very simple way of measuring rotational speed or number of rotations.
So this is what we use, or something like this is what we use for our ball sensor. So we have a light break sensor, or a light sensor that emits a little bit of light and measures if it's reflected back at it. I have a different version, but this is like that. So this does the same thing. It shoots out a little bit of light and measures whether it comes back or not. And you can use it on a digital input and it'll just tell you whether there's something in front of that sensor. The one that we have on the robot has a little tiny screw on it, so you can actually tell how close or how far away it is. You can adjust its sensitivity a little bit. And it also has an LED on it as well, so we can tell if it's sensing very quickly. Without having to actually go to the robot, we can tell if it's powered up, we can tell if it actually sees the objects just by putting our hand in front of it and noticing if it's there or not. These are what you'd use to like follow a line on a board, anything like that. There's some more advanced ones. There's tiny ones like you see here, which is a little circuit board that you wire to. There's banner sensors, which are big $80 industrial sensors that do the same type of thing. There's a whole range of them that you can find that fit your application on how reliable you need to be, what space you need to be in to fit in, how you want them to mount. But it's pretty easy to tell if something's in a path of some sensor.
For those light sensors, when you're using them, depending on what the sensor's field of view is, you may want to shield them so you don't get external light interfering.
Right, yeah, it depends on what they're looking for too. So some of them are shooting IR, some of them are shooting visible. It depends on what's coming back and how much money you put into them and stuff too, is how good they are at getting out noise. Okay, so encoders are probably the biggest thing, or one of the more important things that we use on the robot. Those are how we tell rotational speed and rotational distance is by using an encoder. And those end up being digital sensors, even though they're giving us a lot more information, and they do that by going through a pattern. So a simple encoder is just giving you a pattern of 1s and 0s. It's on red, right? So it's just giving you this kind of up-down pattern over and over again, and you can just tell, is it turning, is it not turning? If I can draw actual squares properly, but and it was really bad. All right, so like this is a 0, this is a 1, and as it goes over, in theory, it should be a square. It's closer to right. There's actually a picture in here somewhere.
That's okay, I'll
there we go.
I'll be your band.
These are much better artists.
Wave smoothing.
This is the teacher in me.
Yeah,
Noise
so
filtering.
Yeah, nice filtering.
yeah, so basically as you rotate it, you get a 0, it goes up to a 1, you rotate it a little farther, it goes back to a 0, and you can just tell how far it's spun. What the problem with simple encoders is you have no way of knowing direction, right? So you could be here, and you can either go backwards to get to a 1, or you can go forwards and get to a 1, and you're still fine. So this may work if all you're doing If you're just putting on a shooter and you just need to tell speed and you know which way it's spinning, you may be okay. But if you start driving around, if you're doing it on your drivetrain or you're getting pushed around, you may need something a little bit more advanced so you can tell direction.
And the way almost all of these work is it's just like a photo gate. So if you have a physics background, physics teacher background, so you have a photo gate, you just have something passing through it. And so on a simple encoder, it's just a series, well, not on this one, but on the simple encoders that we use, that's what they're doing, is it's either breaking a beam or it's reflective.
So this is literally a mechanical one, and this down one, which is basically just hitting a button over and over again. Okay, so the way that we fix it to tell direction is quadrature. So this is an actual nice PowerPoint art. Okay, so quadrature encoders, they take the same thing as a simple encoder and give us that same square wave pattern over and over again, but they give us two of them that are out of phase by 90 degrees. So that little shift here that's out of phase lets us tell direction. So that if we're looking, what we basically do is we tell the controller to always ask what's happening at one of our transition points. So like from 1 to 0, we look at what's happening. And if we're at 1 and we go to 0 and this one's 1, we know we're moving in this direction. If we're at 1 and we go to 0 and this one is 0, we know we're moving in the other direction. So we're doing all the counting here, and we just check here to see what direction we're in. So this gives us a lot more information. We're still just using a digital signal. It's still just off and on. It's just off and on thousands of times a second possibly. So you can get a ton of information out of it with just a little binary signal that's running through it. The Roborio does a very good job of calculating all of this basically for us. So one of the advanced things that's in the Roborio that makes it different from like a Raspberry Pi or anything like that is there's an FPGA inside of it that's doing a lot of that calculation for us. Basically at the hardware level, taking in and accumulating all those little ones and zeros without the processor having to do all that work. And you pretty much can't overrun it. Like I tried to get a limit on how fast of an encoder rate you can actually do on the Roborio. I haven't gotten a real number, but there's almost nothing you can do. Like it's an extremely high RPM, or ticks per second that you would need to accumulate.
Like when we purchased those, they're the two that we use. They're either 100 clicks per rotation or 250. But you can also do there's another one they sell is 360, which would correspond to an angle measure.
Yeah, so as you're translating these to like your drivetrain, if you do it directly on the wheel, it's relatively, like on the same shaft as the wheel, it's relatively easy to do it. You can do it farther up the gear chain, but then you have to do the math to the gear ratio to figure out for how many turns of the encoder is how many turns of the wheel, and how far does that mean I've actually traveled. And then you can calculate, you can then tell the robot, I want to drive 2 feet forward, and it'll do it properly.
So to get around that problem, the difficulty, because we do it upstream, up in the gearbox, and all we do is we drill a hole in one of the shafts, and then it's a friction fit inside the hole, and then the encoder is only held in place by the wires that lead to it, because there's like almost no friction at all in the encoder itself. And so we just take the robot and we'll move it a certain distance, and we'll see what the clicks were on the encoder. And yeah,
That's what
it works well.
It does.
If it's not a pneumatic wheel, it works really well.
That's true.
But even with the pneumatic wheel, you would still have the same problem.
Yeah, so it's harder with a pneumatic wheel, because it's actually harder to tell your actual diameter. With the rigid wheel, it's easier to do that.
Right, but I'm just saying that the system that you're doing still suffers whether it's a pneumatic wheel or not, just like ours would.
Right.
But we just push the robot a certain distance, like 10 feet, and then we see that so many rotations, or so many clicks equals that 10 feet, and there's a conversion they use. And once they do that, then it's pretty much set unless we change the gear ratio or change the wheels out. So.
Those of you who have used encoders in your drivetrain, have you found problems with wheel spin throwing you off?
With slippage?
Yeah. Because you just alluded to it.
Well, so this year's game, once we went over an obstacle, we couldn't count on the encoder to be telling us exactly where we were. So it was, we just had to design so that once we cleared an obstacle, we could use the camera vision to tell us, you know, okay, we need to move forward a little bit, or we need to move left or right. With this new camera, we're just gonna cross, and then it's just the left or right that's gonna make a difference, but we just need to make sure we clear the obstacle. But, you know, if we would lose contact with the ground, then we don't know where we are.
Because maybe not so much with last year's game, because everyone had mostly very low power drivetrains, but this year, and maybe the year before, you had very high powered drivetrains, and just when you start,
So,
you
so
can
most
get
people,
wheel spin.
right, so in autonomous things, you can ramp up and things, so you accelerate slightly slower. A lot of times, one of the nice things about what we were talking about shifting gears yesterday is if you have a low gear, doing that in autonomous means that you're able to have more precise control of the drivetrain a little bit. But you don't want to accelerate fully in autonomous most time anyway, you don't want to gun it.
So you don't want full
If
torque.
if you can ramp up to speed, if you can figure out the right distance you want to be going, most people have enough traction on the ground where they're not spinning their wheels at the beginning.
But we just start off slow, and then keep speeding it up until it doesn't work anymore. I mean, that's how, you know, because we know that it's working properly when we're at the lower speeds, and we just keep speeding it up. We also use what you're talking about, we use, I think I may have said trapezoidal motion profiling, so that at the beginning, when the robot goes to a velocity, it ramps up to that velocity. It's very easy for the robot to track, you know, from low power up to some power, and then it keeps at that velocity until it gets close to the target, and then it ramps down in velocity as it approaches the target. And that's to prevent that very thing from happening.
I've seen that a lot with Lego robots.
Yeah, the bigger ones, it's easier just to tell it to ramp up slowly, and then if you can get all the way to trapezoidal motion profiling, which is a much more advanced topic, but you can do a lot to clean up your path and things. But even just the general stuff, if you have an encoder, you can get it to get close enough for most tasks that you're trying to do on the robot. Another digital switch that we use that no longer gets connected to the Roborio, this now gets connected to the little pneumatics module, is the pressure switch. So this just gives us a nice digital signal for when to turn the compressor on and off. And it's what controls the compressor on everybody's robot now. So it plugs into the PCM, and whenever it switches that it's above 115 PSI or so, it turns off, and whenever it switches below 195, it turns the compressor back on. That's to avoid hysteresis, because if it just told you if it was at 115 or not, you would just be sitting there going, I'm above 115, I came down slightly below it, and then we turn on the compressor again to get it over, and you just hear lots of noise, and eventually break the compressor. Okay, so those are the basic digital sensors. I didn't put in a couple of ones that we started using, which I think we passed around. I don't know where they all went.
Which ones?
The proximity sensor. That one. So this is one of them. So this little guy is an inductive proximity sensor, so it just measures if there's any ferrous metal in front of it. So instead of having to use a magnet, you can literally just use a bolt or anything that's not aluminum, and it'll detect if it's in front of its range. So we can use this we can literally put a bolt anywhere, and it'll just detect very quickly if it's in front of it. It has a little light on the back end too, so it tells us if it's sensing it. One of the nice things I like about a lot of these sensors is if you can tell on the sensor if it's reading, then you can check the system pretty quickly and know where's the fault. Is it in the sensor wiring back to the Roborio? Like, does it have power? Is it detecting the thing? Do I need to change it here? Or is it in code? Did the programmer just stop changing the right pin? Is it not plugged in the right spot? You can troubleshoot a lot easier if there's an actual feedback on the sensor telling you whether if it's changing state or not. Or if it has power at least, it would be very useful.
Is this one a capacitive?
It's inductive too, so it's just steel. Or so any ferrous metal will just measure it.
They've got the same thing for capacitance, so it doesn't have to be metal.
They can, but then you get random things near it, and I don't necessarily like that. So the inductive ones just mean I know it's a bolt that we're putting on there, and we can do it. But yeah, you can make capacitive ones too.
Roughly how much is that one and the one we have?
So those are all AliExpress too, so like $3.
Where are they from?
You can get them on Amazon, I think they're like 6 or 7. I think if you buy them on Amazon, they're like 6 or 7. They're the same thing, people just import them and then sell them here too. Okay, so analog sensors are kind of what we were using on the Pixie to determine a range, right? So we're getting a full voltage range back to the Roborio. They're going to plug into a different spot on the Roborio. They plug in down at the bottom here where we have analog in. We only have 4 here, and the NavX, or sorry, not the NavX, but any of the MXP ports can give you another 4. So you can have up to 8 analog sensors plugged into this. And they can give you, they read across 0 to 5 volts. So instead of just 0 or 1, we have 0 to 10 to 1024. So you can have this nice big range of values that the sensor can see. So the simplest one, kind of the analogy to a switch for an analog sensor, is what's called a potentiometer or a pot. And this is just a little rotary dial that has normally a range of values. It's normally not continuous like an encoder is, where you're going to be able to spin it forever. Here you can measure angle or degrees that it's turned at, so like a volume knob or something like that. There are a huge variety of potentiometers with different features, different ranges. Some of them don't have the stop, so you can go all the way around and they just reset, which can be useful, especially if you break them otherwise. So like the little cheap ones, depending on how you mount it, if you overextend something or if a kid rotates it too hard, you break the mechanical stop on the back end and normally mess up the internals and you stop getting good signals. So we started using ones that are fully continuous, like they don't have a mechanical stop in them anywhere, but they do have a little bit of a dead zone, so we have to start them somewhere in it, and then you can never break it, but as long as you reset it somewhere in there, you can zero it again in code, so you can tell it where its down position is and its up position. We find that those work pretty well. I think I got that from 610 actually, they started using it.
So we use ones from US Digital, and they don't have the dead zone.
They're just fully,
You buy them from DigiKey or somewhere? You buy them from the Bowser, DigiKey, or?
We buy them directly from US Digital, and they don't have an online. You can't buy them online. You have to fax it, or you can call.
Call, right? I'm gonna say
fax or call. Those are 2 choices.
Yeah, I mean that's I have to buy when I buy batteries. I buy them directly from MK and I call them.
Yeah.
Don't if you're not afraid to call it, you can get stuff directly from manufacturers, which is easier. And some places will just send you stuff if you're ordering small enough. They don't care. Basic gyros is, for a long time they were all analog, the ones that we used. More and more of them are moving to be more advanced sensors where they're connecting over some sort of digital communication pathway where they're doing serial communication over I2C or something like that. But you can still use just the basic analog ones. And they're telling you rate of change, which is probably one of the bigger misconceptions of gyros in robots in general. They are not giving you an angle. You can use that to calculate a angle displacement, but they do not give you, north or anything like that. They're telling you rate of change since they've started measuring anything. And then on the robot, we have to actually integrate that to get to degrees turned from our initial starting position.
Isn't this similar to encoders?
Yeah, encoders are the same way. But so, and most people get that the encoder can't give you a true angle or like a true path or know where you are on the field. Like that's more intuitive for most people. The gyro, for a lot of people, they believe it tells you if you're pointed right, which it doesn't. It tells you you've turned 90 degrees from wherever you started. So if you don't start the robot in the same place every time, it's only giving you that. And even more so, the integration just has to be way faster because you're doing it on degrees per second, where you're not measuring the same thing. So the encoder is actually measuring distance directly, where this is just measuring degrees, and it's harder to integrate and get accurate.
I
better
thought,
now, but
so I'm confused. It sounds to me like you're measuring the same thing. Because
yeah, so you're measuring the same thing. It's just less intuitive for people to get that.
Okay.
Most people think the sensor is giving you angle when it's not.
Okay.
Right.
So if you're measuring the same thing, how do you use a gyro versus a encoder? How do you choose one?
Oh no, so they're not measuring the same thing. They're measuring very different.
No, in the sense of
measuring the same
it's
sense.
looking at a rotation and measuring its rate in some ways, right? I mean, you're calculating the rate load out. It's measuring the rate of the.
Sorry, I missed what you were asking. Okay, so the encoder, you're measuring distance that the wheels spin.
Yes.
So we're getting linear displacement of the robot. If I've driven
But
from X
that's,
to Y.
you're getting linear displacement as a second order effect, but you're measuring just amount of rotation, correct?
Right. So gyro is measuring overall rotation of the entire robot body.
Ah,
Right, so we're saying we started at the robot pointing the driver station, degrees per second that we've turned right or left away from that body, right? So we're getting, it's the other degree of freedom of the robot.
yes, okay.
Maybe one of the differences is like, so when the encoder's turning, you're literally just counting like how many of the
Yes.
spokes you went past. With the gyro, you know, it turns and the voltage that you get out of it tells you, I'm
Right.
turning it 3 degrees per second or 2 degrees per second. And as you keep track of that, you know how far you've turned. One of the problems with the gyro that you don't have with the encoder is you can exceed how fast the gyro can turn. It can
I
only
see.
sense at a certain rate.
There's a maximum turn rate.
The other problem is that gyros they used to drift a lot. They're getting better and better. So I'm about to hear some stuff, I think, about that. But they drift, and so you could be setting still for 30 seconds, but the drift tells you you've turned 10 degrees.
And does it have an inertia issue where if you turn and turn back immediately?
Most of them are pretty good because they're so tiny. We're talking about the sensors are inside the silicon that there's not a lot of inertia in them. There's almost no inertia in them. They're really small.
What you might get into a problem with is if you're not sensing your robot but some mechanism, then potentially your sample rate may be too slow to pick up what he's talking about.
Right, and that's what ends up happening with the gyros is because we're integrating, you're getting an approximation of angle based on the speed velocity that you're actually measuring, right? So with the gyro, we're measuring rotational velocity, not rotation. And then we're having to take that and say, okay, we've rotated this fast for so long, that means we've rotated this much. So it's never 100% accurate. It's close, but then what we start doing and because of a lot of the push from this is because of wireless drones and quadcopters and things like that, where they need a very accurate rotational inertial navigation system so they can keep stable. That technology has gotten a lot cheaper and a lot easier to use. Now we can put it into FRC robots where you have entire inertial measurement units that basically use multi-axis gyros. So instead of just having this plane, it does all 3 degrees, so you get rotation in the X, Y, and Z. And then it also adds in a few other sensors we're going to talk about to do even more error handling. It does a bunch of math and sensor fusion to get a very accurate rotational picture of the robot. So you can tell, yeah, I can really turn 90 degrees.
It's not great for long-term positioning, but it's fantastic, especially on games like we just had, where if you're going over like the ramparts or stuff, your wheels can slip like crazy, and then you can use the gyro because it'll keep seeing what the actual robot's doing to compensate. So they're really good when used in pairs to augment each other for a lot of quick stabilization. If you tell it to go forward, you know, then the encoders and wheels might slip. The gyro doesn't care, and it'll still compensate for all of that on top of whatever, so that you can have a really stable robot, especially handy when you have like the 2-wheel drive robots with casters. It's a necessity. You can't drive those without this kind of a system.
If you watch when our guys were trying to do crossing and shooting, the robot would cross over an obstacle, and then the first thing it would do is you'd see it line itself up, and then it would continue driving forward. But there would be that moment when it's trying to make sure that it's in the right orientation before it drove forward.
So it figured out that it turns 18 degrees to the left as it crossed, and then it turns back 18 degrees to
Before
the right.
it started moving. They could have done that as part of the initial motion. They could have had it start moving and straighten itself out. Would have been fine, but we didn't get far enough into it that I got to a point where I could tell them, you know, you don't really need to straighten yourself out and then move. You could go ahead and start moving and straighten yourself out at the same time. You're going to be close enough, because then they were going to use the camera to still line up with the shot. So they didn't have to be aimed directly at it before they started moving. They could start moving and get close enough that the camera could take over. I just didn't get there.
Yeah, so one of the other sensors that we use, that's main purpose really is to correct gyros at this point, or like shock sensors. These are also all the same sensors that are in your phone, by the way. So when you're tilting and twisting in a game, or your phone measures that you flipped it sideways and things, it's using a gyro. It's using an accelerometer most of the time as well. Most phones have gyros, most of the high-end ones at least do. Many of the like the carrier flagships. Some of them just have accelerometers. You're sensing acceleration, so you're actually sensing, in meters per second squared or feet per second squared. So you don't want, what a lot of people think you can do, in the same way that you could use gyro to measure kind of your angle, is you could measure how far you've traveled just by integrating acceleration. That is a terrible plan. Reason being is you have to integrate twice, right? So you have to say, I've accelerated this long for this much time, and you have to do it again to get finally to feet. Because we're at feet per second squared, not just feet per second. We're not measuring velocity directly, we're measuring acceleration.
And the acceleration itself might not be constant, right?
Right, it's not constant at all. It's a giant mess. Like, and you're measuring, you're also, if you have like a 3-axis accelerometer, you're also always measuring gravity. So as soon as, or if you have a single axis, as soon as you tip off, exactly parallel to the Earth, you start measuring gravity.
Yes.
Which is not your robot's acceleration.
That's a second order derivative.
Yeah, so once you start doing 2 integrations, you're never going to be close to right. So any team who tries to do position in that way is not going to work.
All those robots with the lower wheel that rock a lot.
Yeah, you can use it to do things like shape sensors if you want. Like if you want to know when your robot's hit, it'll tell you that pretty easily because you'll see the spike. But what it does work well for is figuring out where the Earth's acceleration is and correcting gyros and things for that, and figuring out tip. You can also use it as a tip sensor to tell, okay, I'm tipped back here, but now I'm reading gravity is the wrong direction.
In what way do you correct errors from gyros?
Right, so they integrate it, they use all the inertial systems that are used like quadcopters and drones and things, use the 3-axis acceleration, so we're telling where the Earth is, and the 3-axis gyro, and you're integrating all of that math. Then, believe me, I don't do the math, the computer does it all. And people have written all the algorithms and stuff. You're using pretty complex filters and things to run through and get all that information together. It's basically a lot of linear algebra. But it takes it all, and you're able to get a much clearer picture of your rotational actual position from the starting point than you are with just gyros.
So you don't mean in the sense to correct error from gyro, you mean as a substitute for a gyro which is more accurate?
No, so it's literally helping correct error. So the gyro accumulates error in certain ways. It's taking the information that it gets from the accelerometer and cleaning up any of the potential errors that are in the gyro stuff as well.
And is that stuff
You're
that
getting a
like,
sensor unit that's more accurate.
Right, the entire sensor unit is able to be more accurate because it has this new information about the world around it.
so do you mean you like buy one, you buy the other, and you've got to figure out how you
You
get
could, you shouldn't.
Right, but you get it as a unit?
Yeah, they sell them all together.
Okay, I see. But
They
the
sell
software
them as an
doesn't.
inertial measurement unit that has a 3-axis gyro and a 3-axis accelerometer on board. Then even some of them have a 3-axis magnometer, which is something that's measuring, which literally is kind of like a compass. And you're measuring the Earth's magnetic field, and it's using that to also.
Like if you want a PhD thesis project.
It sounds like.
Not anymore, but if you want a PhD thesis project like
I'm
20
glad no one has
years
to
ago,
do that in
15
lab
years ago, yeah. It's been done so much now, like that's why we have drones and things that can autonomously fly, is because we have these sensors and these sensor packages, and they're cheap enough now to where they're 60 or 70 bucks. We'll get back to the IMU stuff in just a bit. One of the other regular analog sensors that people use are ultrasonic rangefinders. So just like a bat or a dolphin, and using echolocation, it's sending out an ultrasonic sound that we can't hear, waiting for the echo to come back, and using the time that it takes for that to come back to give you a distance. So we haven't used these. The only time we've used them successfully to do something cool on a robot was in 2011, where we had to hang an inner tubes on a big rack in front of us. Was in our autonomous mode. That's how we set the distance away and when to stop, was with the ultrasonic sensor, because we get sensor right off the wall.
That sensor has at least three different ways that it outputs information.
Right,
that one does. It has an analog output for the distance. It has a pulse with modulated output, so the length of time that it's on tells you the distance. And then I think it's RS-232.
It's I2C.
Is it? Okay.
Yeah, so there's, a lot of sensors have different outputs. This one I showed here just because it's the easiest, and just like with the Pixie, the easiest thing to do is pull in an analog value and just look at the different range, figure out, put an object in front of it 2 feet away, figure out what that means, and then kind of scale from there. You can get a really nice distance very easily without much programming or anything. If you start doing pulse width or anything else.
You get a voucher for one of these, or basically to pay for almost one of the cheaper ones of these in the kit parts.
Yep.
So when you use this, you've got to make sure that the object that it detects is actually the one that you're looking for, right? Because
Right, that's true. So like I said, we were doing it because in autonomous, we knew there was nothing between us and the driver station wall, and we could measure just that zone to the driver station wall.
And so it must have a cone within which it is.
It has a pretty large cone, yeah.
So it might pick up
Some of
something.
them are narrow. You can buy different ones depending on the cone and what you're trying to detect.
So if there's like a rock on the ground, it might detect that instead?
Yeah, but if there's a rock on the ground in FRC field, we have something wrong. Rock should not be on FRC.
No,
in general.
I use rock as a metaphor.
Yeah, no, I know. But yeah, you have to know that there's a clean path in front of you, so you can either mount it higher depending on what you're measuring. These are, you pretty much, the only time I've ever seen them really successfully used in robots is you're measuring distance away from pretty much the driver station. These are, nice about these is they don't care if the object is clear, so the other way you can do it is with infrared or lasers. There's some legal lasers that you're allowed to use. But if you start doing that, and you start measuring the field wall or the driver station glass, which are polycarbonate, depending on what it is, the light may just penetrate through and not actually reflect back properly. Light sensors on the diamond plate are also a little weird because the diamond plate is the driver station. Light sensors reflect weirdly sometimes depending on the brand and model and everything too. Ultrasonic seems to work pretty well against the driver station diamond plate to give you an accurate distance.
We used this in 2008 when we drove down the field and we were sensing on the left side that the wall was there. And so once we got to the point where the sensor didn't detect the wall anymore, then we knew we could make a 180-degree turn and come back going the other way. Because it was a overdrive.
Yeah, it was just a big circle you were trying to drive around with a wall in the middle. So if you could just detect when that wall ended, you could know you were ready to turn.
And you could also use the sensor because there's pretty common for wall following robots. They can use 2 of the sensors to keep themselves straight with the wall. So now we would just use encoders on the drive wheels, but at the time we weren't.
Or you could use a gyro to keep straight too.
Or a gyro, which we also weren't very successful with in 2008.
Have you guys had any problems with interference with these? Because
with 2 of them, yes.
So if you have 2 pointed at each other, the reason they have multiple things, these ones in particular have a trigger line that you can connect multiple together and they'll trigger in sequence and wait for the other one to get its reading back before it sends the next. So you can actually pattern them off and like have them not interfere with each other.
I've heard of things like motion detector systems and such interfering with these. So if you guys had,
I haven't ever had that problem, and also they shouldn't be on FRC field, so we're probably okay.
well, just in the room that you get. I've read about it, but
I've never seen that problem.
but that's the sort of thing where you show up and where you tested it doesn't have it, and you show up and then you're suddenly screwed.
Yeah,
There's
always possibilities for interference. Those ones are pretty rare. I've never heard of those ones.
So with a laser, you have the advantage that you know which object is at the given distance, right? Because it doesn't diffract.
Potentially, yeah, but so some of the lasers, it's just harder, the distance you can cover.
I see.
And what type of laser you can use. So you're only allowed to use 0 and, are you allowed to use 1? I have to look it up. But I know you're allowed to use class 0 lasers, but pretty much if it's visible and you can see it, so like any of the ones like you use for like laser distance measures and stuff, you can't use. Those are, whatever it is, needs to be able to be shined in somebody's eye indefinitely and not hurt them.
So do you,
those are the only ones we're allowed to use on FRC.
so if lasers are not allowed, is there anything you can use that does not have a diffraction problem where you don't know exactly?
Largely, there are some lasers that are allowed and you can get them to work.
We use the
It just
laser
depends.
glass.
LiDAR, there's a new LiDAR that works.
No,
It's expensive. It's like $100.
And it gets a little weird to play with. It's like, I have one somewhere. I'm surprised it's not really.
We have one.
Yeah,
We tried working with it.
Yeah.
We were able to do it in an easier way. They wanted
It's
to
not
do
true
it,
that
but
you know what you're.
problem was where it was mounted on the robot. When you got close to the tower, you might end up
We used
looking
it
through a
in the year
hole
with the
at the base
totes,
instead of the tower
and we used
itself.
to
so.
sense the height of our lift.
Oh, I see.
So it was aimed at a part of our robot, and
Hmm.
that's all it could be. But if you're aiming it at the field, you don't actually know what you're aiming at.
Unless you coordinate with the camera.
Okay.
It's strategic.
The last thing about these really fast is you don't want to use these for short range stuff, so you wouldn't want to use this for like a ball sensor on your robot. It doesn't work very well on the short range stuff just because it doesn't have enough time to get the echo, and it just, if there's something immediately in front of it, it kind of freaks out and doesn't know what the distance is. Sometimes doesn't even hear the echo because it might diffuse past it. So you want to give it at least a foot or so of room in front of it to really be able to measure anything. IR rangefinders, similar, but kind of the other way, where these are much better at shorter distances out to, I think you can do, they sell some that are kind of long range, they do almost like 9 meters, but I wouldn't want to go that far. We use them for things where we're sensing 3 inches to 2 feet or so. So we use these for ball sensors. Sometimes we use them in 2012 to measure where our ball was. They're very similar, and sometimes even the same thing as the photo sensors we talked about before. But you can, some of them will be able to plug into a digital input and trigger at a certain distance, so you can calibrate that. While if you plug them into an analog, you'll get a whole range of values out. What's nice about these is what we did in 2012 at least, was as we had one sitting pointing at like our ball path, we could literally see the arc of the ball because we could tell the distance away that it was, and we could stop it as the ball was getting, once we got to the midpoint of the ball, we knew it was as close as it would be. As soon as it started getting smaller, we could actually stop the sensor, so we'd actually stop it directly at the midpoint without having to have a button there touching it. That took a little bit more code to get working right, and it was important to where the ball was. This year, we just needed to know where it was, kind of, as long as we were close, we didn't really care. We just wanted to stop our intake, so we just use a regular digital sensors without having to do anything analog. Better for short distances. Depending on the brand and stuff, you have to look at whether it can dissect through Lexan or not. So if you're trying to measure the field or something else, you may have a problem because it may just not see Lexan. Current sensors are normally analog. Now, though, they're entirely built into the PDP, the power distribution panel. So every one of those breaker outputs over the CAN bus, you can just ask for how much current is currently going through it, and it tells you. So you could do a lot more things like making sure your motors aren't burning up. You can kind of determine how much torque is being driven by a certain motor or how much load is on it. So another way, if we wanted to detect if we had a ball or not, we could probably look at the current path of our intake motors and see when they start spiking, because there's normally a ball in there somehow, because they have more of a load driven on them. And you can turn off the intake once you've got that load, or once you can see the pattern of the ball going through it. So you can do a lot of sensing just on how much output is being driven by your motor. And it's all built in now, since every single breaker path you get the current from, or you can get the current from. They're also built into the Talon SRXs too, so if you want to get, you can ask it for current as well. They should be the same, or at least close, but if you want to have backups or redundancy, you can do that. Camera vision, I think we did most of that this morning, I'm not going to hit on it too much. But yeah, you can identify colors, you can identify blobs of color, motion. People have done things, even back all the way to 2006, one of the teams had a way that they could detect all of the balls on the field. They didn't do much with it, but they could actually tell you, like they had a camera looking at it, it would point out where every ball was in its field of view. Similar like what they did with the different blobs on here, they could notice all of them.
The driver station processing is where you have to worry about the bandwidth.
Right, because you're sending the image back to the driver station, doing the processing, and then sending values back to the rover. Yeah.
That's why people fit like the Jetson. That's why we had the Jetson on board our robot, was so that we didn't have to worry about that.
Most of the time you can still do it, so we're still sending a camera feed back over. It's just how big of an actual image do you need to send over. You can do vision processing on a very small image, because all we're caring about is a blob in the middle of a thing. We don't really need it to be HD video or anything like that to do good vision processing. At some point, whenever they reroute the FMS, that bandwidth limit should be dramatically increased, because it's like 7 megabits, which, if anyone knows anything about local Wi-Fi network, is ridiculously small, even for 6 robots to be on the field. Like, we should be able to push through that easily once we're on AC or anything. You can do. But, nowadays, if you have 6 people in your house all watching Netflix on an HD tablet, you can run that at your 20 or 30 megabits easily, possibly.
So, I heard that some cameras will also detect distance.
Will detect distance.
Yes.
Oh, okay, so that's what we're talking about here. We're talking about actual, straight, real-life distance protections is when you have something like a Microsoft Connect, where you're getting it has to put out a full IR map, and then it can tell you how far away an object is.
But there's no like regular camera that will do that.
It's not a regular camera, no, because a regular camera is just sensing the world, and it can't know what's in its field of view. You have to actually it has to be sensing, it has an IR projection basically that it's looking at, and it's getting all of these field points back, and then it can detect distance off of those. There are a few different things, not just the Connect is one of them, that does this, and that's how it's able to do that motion tracking and stuff where all the games are played, because it's actually projecting IR and then sensing, it has a sensor that reads that back in. There are a few different
It's really like a radar
point
map.
clouds, however you want to call it.
It's essentially like what you use radar for. It goes and in aircraft, it's sensing the whole field. It's not just a single point.
Right, but in this case, it's doing it all at the same time, right?
Yeah.
Like it's just projecting all of it and it's reading it all back. There's a few different types of cameras like this. In 2012, every team got a Connect, so several of them figured out how to use them well, even on board or with another computer on board. 968, the high rollers.
60.
No, not right.
96. 987.
987. What am I doing?
It's not even dyslexia, that's just wrong.
987, thank you.
That's embarrassing. I know.
Kind of.
It wasn't charitable word. I was just in China with them.
They used this very well in 2012 to be able to sense where the backboard was for the basketball game.
So what data does it give back to the software?
It depends on what you're using and what you're doing with it, but basically you can figure out, it can detect an object and roughly tell you how far away it is. It gives you a point cloud and you can tell what points inside that object and their distance away.
Right, but the point is it's detecting a whole heap of things, like let's say I'm looking for a ball or I'm looking for a goal or something.
Right, so you basically combine the same types of things you were doing with the Pixie, where you find the object you want, and then there's a separate thing that is basically the point cloud of distances, and then you say, okay, my object's here, you go look at this other map and say, okay, what are the distances in this object, and you pull a distance from it. You're basically getting two different images. You can overlay them and do things like that, and that's what the Connect does.
Is it
really
like
make
a
it work.
gigantic array of points?
Yeah, it's a giant array of points.
So that's what you get from it, is
Yeah.
an array of points.
Right.
Yeah, and you must get some data about each point, right?
Right, you do.
Well,
Right,
yeah,
so that's what I'm saying, so
every
there's a
point
big, so just like, if it's an HD image or whatever, it's 1980 or it's 1920 by 1080. So if I'm saying, the object I want is at X, Y, this and this, I go look at this other thing that says X, Y, this and this is this far away from the camera.
So you have an array, like a 2D array of 1980 by 1020 or whatever, and every point in that array corresponds to distance in the image.
And color maybe, or something.
Well, yeah,
Two
so
different
you're getting a
arrays,
full
yeah.
color image back too.
Okay, so,
There's multiple
Okay, so
things. you can do.
overlaying.
There's a full normal camera color image.
and you
And
get,
there's also this IR map image that you can overlay on top of the camera image if you want. You can get distance back. You can ask for the distance at any pixel.
so it seems like usefully utilize this information, be using up a lot of computation on your Roborio maybe.
It's not impossible to plug this directly to Roborio. I've never heard of anyone doing it successfully.
Yeah, so in that sense, that's what I'm trying to figure out, how is it used practically?
You have some sort of co-processor.
Okay,
Something is doing it, and you're doing a lot of custom code. It is a very advanced thing to be doing.
Are
I
there
don't know of
like
anyone
software
doing that.
libraries out there that help you with this, or? Not sure.
Somewhat, but a lot of it's been deprecated and things just because it's getting old. So it was released in 2011, and so it's 5 years old now. So now they're on to bigger and greater things. But there still are OpenNI projects and things like that you can go and get some of the code for. We had it kind of working where I was able to pull distance and stuff for it, but never enough to where it made sense to put on the robot. Other stuff that doesn't get used on robots very often, in terms of FRC at least. I don't think we'll ever need a game where we need a gas sensor. Hopefully not. But things like that you could plug in if you're doing other projects that exist. We've seen a couple places where like force sensors are used. did you guys try it this year where you were measuring ball weight? Or I know in
well,
12 you had like a scale, but that was, but other
Yeah,
teams didn't.
no, we were, to measure the compression of the
Yeah.
ball, we were using, or we will be using, a linear, a string potentiometer.
Oh, okay.
So it pushes and then the rate at which it is moving, because it's the same force, so the rate at which it moves is a function of how old the ball is.
So some teams are using force sensors to basically figure out how much force they can compress the ball and push on the other side of it, I guess. But it would basically tell, if you push with the same amount of force on this side, how much force went on the other side, they would calculate somehow as well. They were doing that in 2012. GPS doesn't really work, but if you wanted your robot to have GPS, you could drive it outside and do things, but in any of our arenas, largely, you're not gonna get an accurate enough signal to make it matter. Compass sensors I talked about a little bit, they're also called magnometers, and they're measuring the Earth's magnetic field. Most of the time, you're only using this to, again, help correct your gyro measurements and your inertial measurements. You're not gonna base anything solely on the magnometer, just because it's never quite accurate. It doesn't update as fast.
Well, I don't think they work very well inside either.
They work
Depends on
well.
the building.
Most of them work reasonably well inside. They don't work as well when you start getting them really close to a bunch of metallic objects,
Yeah.
which your robot normally is. But when you do use them, so even like the Navex, which goes right on the RoboRio, does have one in it, and some versions of the code actually use it to help with error correction, some don't. I don't think the one that they normally have turned on does. But they're cheap enough where they can just like throw it on and it doesn't really hurt anything. Sound sensors, again, like that would be like the glass break sensor in your car alarm or a microphone. Most of the time you don't have one of those working in your robot, but you could. There's a lot of things you could use a sensor like that for. I don't think I've ever heard of anybody doing it well. Yeah, so I want to talk about the Navex. That's the label maker that I was talking about earlier. So this is the little board. And so you just plug this right into the MXP port, it has a little connector on the backside. And all of these little chips allow you to do a full inertial navigation system. All the code that runs on it, you can just download the firmware straight to it. And once you plug in the firmware into your actual FRC robot, under the RoboRio code, you can ask it directly for things like how far has my robot turned since I turned it on, or just give me like angle in the X or Z or whatever. And it'll just tell you back angle, it'll tell you back rate. And you don't have to worry about any of the math, it just does it all for you.
Just a side note, if you're planning to use it, Andy Mark was out of stock on those for the second half.
Correct.
So
Let's buy
get this
two
stuff
of them.
ahead of schedule.
Yeah, like we just bought, I think we now own, I think I bought our third and fourth, or at least our third.
Do you guys do any sort of reset with your gyros? Because
We only use it for autonomous. We only use it for autonomous.
Okay.
Like if you have something where you need, if you're doing a more advanced drivetrain where it can go sideways and you have mechanism or some sort of omnidirectional drivetrain, then you need this way more often to keep control of it, so you can actually know where it's pointed at things. So in 2011 with the Discobots, where we had a fully omnidirectional robot, we had to do a lot of things to reset. Basically, we had the driver like drive into a wall, so we knew we were perpendicular to the field, and then reset to one of the 4 orientations. We were also doing it with a much less advanced gyro.
Really? Wow. Then I guess you'll know something.
I don't know where that went. Okay. Any other questions about the sensors, the ones that got passed around, anything like that?
Alan, have you ever seen anybody use a ribbon or a patch to take that MX expansion port somewhere else?
Yeah, you can. You can use a ribbon cable to do that. So this is kind of, this is a slightly different one. We actually, you tried to use this one a couple of years ago. But this is the kind of visual you could get out of it and take the data. So you can get, you can literally, you'll just have a plane and you can see how it's tilting in all 3 degrees.
And it holds pretty well to which way you're pointing.
You can separate them out to roll, pitch, and yaw. Yaw is largely what we're using, but you can also use roll and pitch to like try to correct if you were tipping over. If you started to twist, if you started to fall over, you can drive back under yourself to catch yourself. Or not go any farther forward if you're going to tip too far.
What sensor?
So this would be any of the IMUs. So you can get the same type of stuff out of an Navex. This is a Razer IMU, which is a different one that doesn't plug in as easily to the Roborio. But they're all roughly the same thing, where they're just compasses and accelerometers. That doesn't make sense. Sorry. If I don't put the fun at the end, it doesn't work at all. Okay. So they sell a bunch of different ones. They don't sell the Navex directly. That's more of an FRC specific product. But you can see kind of what the general robot field uses. There's a whole section of them somewhere. What am I missing? There it is. No, the wrong one. There's that. Okay, so yeah, they have a whole bunch of them. I actually got rid of some of the ones they used to have. Yeah, they have 6 degrees of freedom or 9 degrees of freedom. 6 is just accelerometer gyro, 9 is accelerometer gyro and magnometer. And you basically do a bunch of linear algebra on the inside of the processor to determine your angles that you want out of it. But those are all basically the same types of things that are used in most of the drones that are doing any sort of autopilot or anything like that. They keep them level and they keep them turned in the right orientation.
Do they give you the software libraries for that?
For the Navex, yeah, that's all done for you. You literally are just saying, you just plug in all the code and the step-by-steps that they have on their website, and then you're just asking for my yaw angle from where I set the robot down.
The Navex actually has those sensors built in. If you want the Spark Fun ones, you'd have to get your own code, right?
Most of those have, at least, like the Razer one I know is a full IMU, so it has an ARM processor on it, and it's doing the map too, and has the firmware built in.
Oh, okay.
And you would just have to you'd have to write the Roborio side of it to communicate with it and ask for the right
So that's
stuff.
just
For the Navex, all that's even already done. You literally
That's just
follow the
communication
instructions.
code.
For the most part, yeah.
And the libraries are available in like LabVIEW, C++, Java, everything?
For Navex, yeah.
All languages. Cool. But and for the Spark Fun, it depends each one maybe.
The libraries aren't built for like anything. You have to write it all yourself. I mean, there might be some team who've already done it, but it's not like published, it's not updated and official, because there's nobody supporting it for FRC.
Right.
With Navex, the company is selling it directly for FRC. It's actually a guy who's on a team somewhere, I don't remember where.
Kauai.
What?
Kauai.
Kauai Labs.
It's in Hawaii.
There we go.
One of the islands.
Alright. Learn something new.
It's really nice there.
It's the Garden Island.
I don't know much about Hawaii. I've been there once. I was like 8. I don't know what's next on the schedule.
What?
Do we have any other sensors or electronics questions? I don't remember what those actually.
Would this be a good time to tell them I have stuff?
Oh, yeah. That works.
So, when I was talking to some of the new people, we were talking about wire and stuff. So my team, we just use zip wire now. We don't use the wire that comes in the kit of parts. And so I have a lot of the wire that came in the kit of parts. Some of it from, like this is probably really old here. So I brought all of it because we don't use it anymore. And I thought, well, somebody might want to take some wire with them. So I brought a lot of wire, a couple of Ethernet cables and a couple of crimp connectors that we don't use. We actually do kind of use these, but I brought them anyway. And it was in the same container. So I brought a bunch of connectors. I also have 3 of these are the battery chargers from, I guess we were using this one maybe in 08.
Yeah, that's the one
So, but this works with the current batteries. We just don't use these anymore. And I don't know, I guess these are coming in the kit parts now with the paint.
Oh, yeah, so that's a fun story.
Okay, yeah.
I know the story. I asked the headquarters because I was really confused with
I don't know the story.
So all of the Anderson SB50s are keyed. So in theory, any one color that you buy shouldn't connect to the other color. Here's the thing, they don't sell pink SB50s. You can't buy those. What happened was the Anderson factory, they're a big supporter of FRC. They donate all the SB50s every year for all the battery connections that go into kit parts. They were like, hey, we sell our power poles in pink. We have all of this pink plastic. Nobody buys pink power poles. SB50s that are normally red, but in pink. So the person was like, sure, we don't care. Yeah, they were fine, because they're the red dye. They just ran the pink plastic through the red dye, because they don't sell pink. Like, you can't buy pink. That is just red, but using the pink plastic, but that's happened to be what they had on hand. And they had a lot of it, because nobody buys pink power poles apparently, and they just couldn't get rid of it. And I refuse to put them on a robot too, so we give the lights away too.
Yeah, so that's why I have them here, but I do have, there's one, we don't use, this wire here is stiff, and we use, our power wire is 4 gauge, and it's 3,000 strands. So it's floppy, like, are you gonna call it up?
Oh, no, I was gonna do something else.
Anyway, it's floppy like it's not like this. This is stiff. It would just lay right over. And we use that because it's so flexible and doesn't create strain.
Do you get you have to get different crimps?
No, they works okay with the 4 gauge. But it is like a tight fit.
So, for me at least, we buy all of our Andersons for those types of things, because a lot of people don't realize how to do the battery chargers properly. So if you look at the battery charger there, it has the Anderson on it, like the actual battery charger.
Oh, yeah.
And I think you did it.
That one doesn't have it on there yet.
One of them has it on there, and it's actually crimped. So what we do is you don't want to use the same crimp we use for the big battery cables, because those are like 6 or 8 gauge. They sell the actual 10, 12 lugs for the SP50s, and you can buy them from Mauser. eBay sells them. Mauser's cheaper if you buy the individual parts and if you're buying them in big bulk. I normally do eBay, but I think I can get images up faster here. But there are 2 different crimps for the SP50s. One for smaller wire that you use on like a battery chargers.
Well, this one just happens to be, this came in a kit box.
Oh, yeah, so it was
and then it was just spliced.
already done,
Yeah, so.
So you can do the splicing, but if you buy the connectors, it's just a little bit easier to do the crimping on the smaller wire. Even then, you normally still have to fold over the wire, because even the wire for most battery chargers isn't actually 12 gauge, but smaller. But at least it's easier than trying to fit it into a 6 gauge doorbell.
Yeah.
If you're doing that, you cut off the clips, do one at a time. Because we had a student go cut them both off, and then we had trouble figuring out which wire is positive and negative.
Yeah, it depends on the charger. Well, ours are striped, I believe. But
yeah.
Is that one striped? Yeah, so most of ours are striped.
Yeah, we had one that wasn't striped. And then when you power it up,
this one's not done.
when you power it up, it's auto sense, so you can't even measure the voltage. And there's nothing to measure.
Well, so, I mean, but at that point, you just connect them backwards and see if it starts charging, and it'll tell you if it's reverse or not on most of them.
Okay.
Like, just make sure your charger has reverse polarity detection. Most of them do nowadays. I wouldn't have one around kids today, because somehow they would screw it up. Most of them do. It's pretty easy for the chargers to know if they're connected backwards.
So you're welcome to take all of it, if nobody else wants it. There's 3 of these chargers, so if somebody else wants a charger, you just work it out.
And on that same kind of point, for new teams in general, go to veteran teams' labs and take stuff. Like, so much stuff. Like when I started here, I went to like Pasadena at one point, or Galena Park, which isn't a team anymore. But they were like, yeah, I need pneumatic cylinders. They were like, come over. And I just like ended up in this bin of handfuls of crazy pneumatic cylinders, because they've been a team since 2004,
Since us?
right?
2004.
Yeah. So they've been a team for a long time. So they have stuff that they just, old robots they've taken apart, things that never got on robots, stuff that they bought randomly, and they don't need. They just sits in drawers. So if you go to them and say, hey, I'm a rookie team, I need stuff,
They don't have
hand you
They don't have
stuff.
stuff anymore.
Did somebody clean them out? Did you
Yeah.
clean them out? So, yeah, 'cause they're not as
We have
easy.
lots of
But-
pneumatic cylinders.
Yeah, so if you want lots of big, huge 2-inch bore pneumatic cylinders that no one uses, I'm sure I'd have some, he probably has some.
We do
I
have
probably have the
some.
exact same ones that I took from them that I'll give you. But yeah, there's lots of free stuff for new teams. You just-
I sold some of them on eBay. But really, we had some tooth
Yeah, they're
pullers.
huge, and
Yeah.
yeah, you can get a good deal, 'cause
Well-
nobody, you should never use them in FRC.
Yeah, well, Doug Adams just decided since because you get a voucher for 2, you used to get it for 3 cylinders from Bimba. And you could, there was some limitation on what you could purchase from them, or not purchase, but what they send you for free. But if they didn't use cylinders, Doug Adams, who was the mentor for the team, he would go ahead and order cylinders anyway. And he thought, well, the best bang for my buck is to get the biggest cylinders.
I think every team goes through that phase until someone tells them to stop.
Right, so now I look at, oh, we need some 0902s or something, and so we'll order, that's what I'll get from Bimba for the free one, so that we kind of fill in some gap that we have. So we have a little range of pneumatic cylinders now, not like NASA, but
Right.
we're doing better than we used to. But, so I sold those big ones,
Yeah, 'cause
made some money for
largely,
the
if you
team.
have a giant pneumatic generator robot, it's probably wrong. There's times where it can be right, probably, 9 out of 10 times I've ever seen someone use a 2-footed pneumatic cylinder, they were wrong. Like, there's just some better way to design the robot to do it.
Yeah.
That doesn't take the weight and the amount of air it needs to do that.
So, okay.
But yeah, there's always free stuff. Like if you need like scrap wood, oh my god, please come to my lab and take scrap wood. You have all the plywood you want for 2x4s. I don't want it. Like we just took apart all of our field from this year, and I don't want any of that wood. If anyone wants really small steel blocks of like squares and rectangles that may or may not resemble the rough terrain, I have a giant bit of them. I have a truss. I don't want that either. I tried to sell it on Craigslist. I couldn't get it rid of.
Is that steel plated?
The truss?
No, the blocks?
No, it's just raw steel.
This total?
Little the rough terrain blocks of steel. There's 2 holes drilled at the bottom of each one and they're tapped. Yeah, there's always free stuff around here.
In case we don't get back to zip wire stuff?
No.
Zip wire?
Zip wire. Oh, you can go to Power Works. It's basically what a regular power cord is, like on a lamp.
They're pre-joined.
Yeah.
Yeah, they're just pre-joined. That's zip wire.
So this is what they use. I find it too expensive. 'Cause I'm cheap.
We're a rich team.
Not really. We're probably about the same budget, but I just don't like.
Yeah, we found it in 12, I don't know that we can find it in 18, or 14, we found it in 14, but not 12.
So
I think they have it all.
That I really
What?
like.
So it's short?
No, that's not it.
Where'd you guys?
Steel 2, modern price.
Oh.
I can't find it.
What are you looking for?
They're 12 gauge house wire stuff. I think it's sleeved in weight already.
Yeah, a lot of it comes up as speaker wire.
Yeah, but that's not, it is speaker wire, but it's used slightly differently, and they only have the black stuff.
See, that's 14.
Yeah, that's not what I'm looking for. There it is. Alright. So yeah, so you can get literally like 500 feet of this for $150 or 250 feet for 80.
And that's sleeve.
Right, it's sleeve 2 conductor.
Right,
So
so I think what you're talking about, Scott.
yeah,
they're
he uses
just
zip wire.
joined.
Right, so it's already joined
Okay.
together. It's flexible, it's fine, you can peel it apart. This stuff we use because one, the sleeving's white, so it fits our theme better anyway. And it's cheaper, and the sleeve basically acts as a zip wire, and it works fine. We've been using it for years, and I've never had a problem with it. And comparatively on price, it's not really close. Yeah, because 100 feet of that is 74, where 250 feet of this is 850.
Is how much?
850, or sorry, 85.
85.
Man,
850. I was like, what?
850, it's really cheap. You have to understand, I'm really good, Scott. I'm not that good.
So, what gauge were you looking for?
No, it's, I've got it now.
Oh, you went, yeah, 'cause they have 12 gauge.
It was 12, yeah.
Zip line.
Yeah.
And you can get it in 10 too. A lot of RCs, cars use it and some other stuff. And
Oh, yeah, it goes from 2 gauge to 24 gauge.
Hey Scott, if you're buying the high strength kind of cable for your batteries, you might consider getting 10 and 12 gauge. You can get it down to 10 and 12 gauge.
I'm sorry, what?
That high strength kind of wire you're using for your batteries, you can get it down to 10 and 12 gauge. Well, at least 10 gauge.
Yeah.
I got some from work that's like that. It's really nice to run. It's just so, it's like wet noodles.
What's actually next one's good?
Oh, yeah, I'm sorry. I'm getting there, Alan. Let's see. Anyone else have any questions we can help answer? Oh, no, that's still not it. What do I? Oh, well, next was inspection checklist at 10 o'clock.
Oh, we didn't do it yesterday.
What?
We didn't do it yesterday.
Yeah. And then 10:30 was drive team. So how we select drive team?
Oh, you want to do that?
Sure, I could do that. I could tell them about all the ways we've tried to do it. So we're going to make this an open discussion because I don't know, I'd be interested to hear how other people do it too.
Before we do that really fast, does anyone have any strong pizza preferences?
Pepperoni. And here soon.
Yeah, I got that one. Is that your around you? Any other?
Corona?
I don't think that's a particular.
Corona Light, yeah, the second. I'm pretty open.
Okay, so I'm going to tell you how we have chosen drive team and what has been successful. So the first successful driver, the first really good driver we had was a driver and operator. 2008, he flew radio control airplanes. He currently flies for the United States pattern flying team, radio control planes. So just incredible hand-eye coordination. We were very lucky. The operator for the robot actually did nothing. He stood next to the guy. So there was only one controller for the robot. He did everything. That game also fit very well with having a single person control the robot because you were driving around a field, you picked up a ball on the fly, and then you shot it over an overpass. So it was really easy for him to coordinate that action. He'd be driving, he'd lower the front end of the robot, scoop up the ball, and then when he got around to the other side of the field, he could shoot it over our overpass. We were alliance partners with Bomb Squad at Bayou. They had two people operating. They had a driver and an operator. Driver would get the robot in position, and then he would tell the operator, or the operator was supposed to know that he could shoot. And I watched them not be coordinated sometimes and not make the shot.
It's harder to do.
Well, in that case, it was. If you look at the game that we had this year, we had a driver that would get the robot in position, and once he was done moving the robot, and the robot was lined up, then the shooter, the operator, knew that they could take the shot. But, we had to work, that's where the practice came in. We had to work so that the driver was letting the operator know, you're good to shoot. They never got to the point where it was, they couldn't, they had to talk to each other in order to make it happen. But in 2008, he was just a senior that was on the team. He was really good, and it was pretty obvious that he should be the guy, so we just picked him. There wasn't any formal process or anything. I don't know if anybody else tried to drive the robot or not. Later, what we did was I just tried to pick the person. I just kind of looked at who we had and thought, does this person have those types of skills? So, like in 2012 or so, maybe, I don't know, 2011, but in 2012 or so, we had another person come through that was an RC car driver, not airplanes, but car. And in 2013, on our robot, we actually used a great RC car controller to operate the robot. We took it, we gutted it, we placed an Arduino in it, we connected it up, and it enumerated on the drive system as a joystick. And so, and so he was just operating it just like he did an RC car, because that's what he was used to. We kind of think of the driver and the operator as our customers, so that we throw things out and like, hey, we can do this, and we'll make them try it, because a lot of times their initial reaction may be they don't want it, because they're used to whatever they have. But if they're not happy using it and we can't convince them that it's better, then it's not on the robot, it's not in the drive system, it's not a feature, whatever it happens to be. So we think of the driver and operator as kind of our customers that way. So even the operator in 2013, that was a person who came in, no experience or anything, but I just thought they had a very good analytical mind, and that it kind of made sense that they would be able to not only operate the control, it's not like they were a gamer or something, they just could operate the control system well, and they could tell me accurately, hey, I tried to do this, but the robot didn't, and vice versa, because I wanted to be able to talk to them and get information back about the system. And they were a very good robot operator that year, and then the next year also. After that, we started, where the team had more input, and so we would do kind of like driver tryouts and operator tryouts. And so we actually had where people would come in, they would operate the old robot, and we'd have people watching them, kind of seeing how they were doing. We were taking data on what they were doing, but it wasn't just a data-driven decision, because there's kind of, I guess, say there's intangibles. You got to be able to work with people. The drive team is basically the face of your team to a lot of people. So we're not going to put somebody on our drive team that's going to make a bad impression on a bunch of people. They represent us to almost everybody. That's who, when they're interacting with other teams, it's often our drivers talking to other drivers and stuff. So we think of the drive team position as really important, not just because of how they operate the robot, but because of how they interact with everybody. So they have to be good people. Most of the people on our team would fit that, but some of them don't have as good at social skills maybe as some others, and so if we can't work on that, that would affect them. The problem with having the students, when the students had so much more input on picking the drive team and the operator, I just didn't think that we could make a decision based on a couple of runs that, I could say, that person's got what it takes to be a driver. I really needed to see something over a longer period of time. So right now, what we're doing is we have our operator. She did a good job this past year. She did a great job, almost as good as the gal did that was 2013, 2014. It's almost that good. So she's going to be the operator, there's no question. We've got a couple of people that are trying driving right now. There were 2 different drivers for us at TRI. I don't know what's gonna happen at TRR right now. It could be that our driver that we had this past year comes back, just because TRR is the UIL State Championship. That if he's available, he'll probably be driving the robot. He has the most experience, especially in a competition environment. But then, after that, when we have the remix, we'll probably have either 2 more people driving. We may have the same 2 people that we saw at TRI. But I'm gonna try to get as much practice time for people so that I can see how they're performing and then try to convince our leadership that these people should be the drivers. I have to be able to sell them on it. But that's kind of how we're approaching it right now. So the operator is set because of previous experience. She is good. I don't see anybody stepping up that's going to take her place. We're going to identify a new driver for the drive team for this upcoming year, and then we're going to have a second drive team. The second drive team is going to drive defense against the first drive team, and when the first drive team takes a break to eat or something, the second drive team is going to get on the competition robot, which is kind of what I watched NASA do. 118, they have their primary drive team, their secondary drive team or third drive team, they're operating defensive robots. Their second drive team is getting on the competition robot or the practice robot when the main drive team is taking a break. So that's how we're gonna handle things coming up. What do other people do?
I have a question.
Oh, yeah.
Do you, we've had some advice that you always try the driver and the operator as a team and that they try out as a team.
No, we've done it where we've had people rotate through different positions. So like London, who's currently operator, she also had a stint as driver before she became kind of regular operator when we were having people try out different positions. Some people just seem to have a knack for one versus the other. So I kind of see that after they've been operating for a while. They're more comfortable with one versus the other. Whenever we have a mentor event, which they have sometimes, like at TRR, they've had that. I always like to be the operator. I like to be the operator because I can be thinking about what I have to do as the robot's getting in position, and I can think, okay, I need to press X and then the trigger, or whatever it is. Whereas the operator is kind of responding, or the driver's responding on the fly to what's going on. They're seeing something happen on the field right in front of them, and they have to get from point A to point B. When we're actually driving, when we're at competition, and I'm standing behind them, depending on how well they're doing, I'll either be talking to them or I'll not be talking to them. I would rather not have to talk to them. I would rather be super coaching the whole group. And so you might see me running back and forth. You might hear me yelling some. I try not to yell. But sometimes, like this year, I'd go, park, 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 because the other robot, they'd be down on the other end of the field and they needed to be down there. And there were 20 seconds left, and I had no idea why they were still where they were. But because they don't have that field sense yet. And so that's what I was trying to do, is super coach.
Do you have like in your drive teams, like part of the qualification where like they have to take a test on like rules or drive behaviors or strategies or anything like that to see how, because there's a lot of, beyond just being able to operate it, knowing what you're able to do with the robot, what's going to cause you to get penalties, having a really good on-the-fly strategy response to the game, how do you guys evaluate that?
We don't, and until you just said that, I hadn't really thought about, having them get quizzed kind of on somehow making sure they're responsible for the gameplay. Because in my case too, some of it has happened, like we've gotten to competition and we're starting to do something, and like James, when he was the design mentor, he would go, why did you do that? He goes, that was illegal. I go, oh. I hadn't caught that nuance or something, even though I'd read the rule just like everybody else had, but we were in the middle of a match and we needed to get from point A to point B, and so one time we drove through the secret passage, we got on the batter, we got the capture. It was to our advantage to do it that time. I didn't make a rational choice that, we need to go through this passage, if we get to the batter, we'll take the penalty, and we'll get the points. All I was thinking about was we needed to get to the batter and get the points. I didn't weigh that in the heat of the match. It may have looked like I did and made a brilliant play, but I didn't.
So apart from the drive and operate, do you have a process for selecting a coach?
The coach?
And do you look at the dynamics between the drive team and the coach?
Well, the drive coach is me.
Okay, so you
And the dynamic is, do they get along with me? Because if they don't, like the kid did in 2000, I can't remember if it was 09 or 2010, and he just kept giving me, I mean, every time we talked after a match, it was just very antagonistic. Finally, I just sat him down. I said, you're done. And I just pulled somebody from the pit, made them driver, because I couldn't deal with them anymore.
Yeah, so in our case, we will pick a different coach. And to that question, for us, it's the coach who needs to be the most familiar with the rules and have strategies around rules and things like that.
I mean, I would say everybody needs to be familiar with them, but the coach is the one that, like, my role as coach usually is I'm watching the field. And so I'm seeing what other things are happening. So
You're looking at the big picture.
I'm trying to watch that, so-and-so got stuck. Can we go tap them and get them unstuck?
Yeah.
Whereas my driver really shouldn't be noticing that so-and-so got stuck.
But for us also, the coach would make a call, like you said, where it's worth taking that penalty because it's worth it because of the amount of time left.
Somewhat, but so the biggest thing your coach does, and probably the biggest reason why I switched from being pretty adamant that students should be drive coaches to me being on the field and being a mentor coach, is solely that the coach's role is so much interacting with other teams than it is with your own. It's dramatic. That is the biggest difference. Is especially when you start getting into champs and into bigger tournaments and going into elimination rounds, is handling the whole situation of running the team and running the alliance and running that match is more than most students can handle. Not every student. There are some students who can do it. It is an extremely amount of work, and you have to be thinking about way more things. And you have to know so much and what to tell, and managing the field staff and managing everybody. And there's so many relationships that are going on in the field that you don't even notice. But like when I'm during a match at Lone Star, I'm noticing who the refs are and who I can talk to and who's on the other side of the field. Am I really like when we're playing them? I know who they are. I know their tendencies and like you know a lot of stuff going on.
For you, are you the coach or is a student the coach?
I'm the coach.
Okay, because so that's obviously a different dynamic than us. So one problem we definitely had this year, which is unlikely for you because you guys, the coaches, that the coach did not fully at a detailed level understand the exact fine nuanced capabilities of the robot. So sometimes they go out and make a strategy that is not really taking into account, like the little failure points in the robot or something. They were not just immersed in the capability. They kind of knew at a high level this is what the robot does. But not, okay, when you do this, you're pushing the robot kind of to the edge of its capabilities. And when you do this, you're in the sweet spot. So,
and so that's why I'm saying that for a long time, I was very adamant that students should be the director.
no, it's obviously easy if someone like you is going to be a coach.
Well, another difference that, and this has happened at events where, I think I can use probably TRI as an example, and maybe champs 2 years ago, and that, we get picked partly on reputation, and partly because they go, well, these guys have experience with, they've played in elimination matches at champs. And that makes a little bit of a difference when you're trying to put together an alliance.
There are so many little things that drive coaches do that most people don't notice. Like, I'm telling people, like, during an eliminations run, I'm telling people, like, go to the bathroom. Like, not my kids, other team, like, the other team members is like, yeah, we have a 3-match break. You guys need to go now so you're not having to go to the bathroom in the finals. Like, that's not okay.
So in all your cornucopia of documentation, you have a list of, like, best practices for a coach, or probably not because you're the coach.
It's all different. It's different from coach to coach of what they're paying attention to and what they
No, but generic, it's like literally the stuff you're saying right now.
Some of it, but I mean, not every coach does that. There's Hall of Fame coaches, or people if we had that Hall of Fame coaches who don't probably do that, right? It's just there are different things that they do that can make them good, and it depends on
And what
how
I
you interact
do
with people and what
changes based on what my drive team is doing. So after like last year, and maybe a little bit the year before, but last year for sure, in 2015, you know, I tried to leave them alone and focus on myself getting better, you know, watching the whole field and what was going on and trying to figure out what needs to happen next. Well, I kept noticing that the guys they were making mistakes that they shouldn't be making. They were making poor decisions. So I decided, okay, well, I'm just gonna have to drive coach them more until they get to a point where they can make those decisions without me. And to be honest, I never felt like my crew from 2015, especially the operator, got to that point where they could just make decisions, and they seemed to make the right decisions without me. Last year's group, when we were at TRI even, I wasn't having to tell the driver or the operator very much. My operator especially was doing a lot of the drive coaching for just our little group because she had the experience. And the driver was just following her lead. There were a couple of times where she and I disagreed, and you know, we had to talk about it afterwards because I would give him one direction and then she would have given him another one. There was a time when you know, I could see he was thinking, and he even started to back up to take a shot with like 8 seconds or 7 seconds left. And I'm looking at the field going, no, we don't need to take a shot for 5 points. We need to get on the batter because not only are we going to get those 5 points for sure, but we had the capture done. And he, you know, they're not keeping track of how many shots have been taken on the goal. And at TRI, it wasn't, you know, it wasn't being posted. We had to keep it ourselves. And so they had no idea.
Yeah, a lot of it depends game to game. So like in 15, like I said, so even with, it wasn't just the drive crew, it was just that there was so less interaction. I couldn't really tell the other teams to do anything anyway because they were just stacking totes. So that was the only year I was between our two drivers the whole time, their voice in my head. I was counting totes. They didn't leave the driver's station until I told them to because I'm making sure that the totes are stacked right so I have a better view than they do. Like there was a lot of direct coaching that year. 14 was the complete opposite. I never talked to my drive crew. I was talking to the other people the entire time. Like, I was talking to the human player and the other teams, and my team, if they didn't know where they were supposed to be, we were in trouble and the match was going to be over anyway, because so much had to coordinate between passing the ball back and forth and when to shoot and get the human player to load in, and all that stuff, that I was managing that and not worried about my career.
So the only thing in 15 depends on the game too.
Right.
Whether you as a team can just kind of pre-agree and then go off into your corners and do it.
Yeah, but in 15 there would be times like we'd lose the recycling can, and so we have to tell someone, hey, can you cap that?
Right, and you still communicate, but like literally in 14, I was almost never between my drivers. Like they had to do it themselves because I was always with the human player or with somebody else managing the whole.
But then with you know losing the recycling container, that's more of an exception. Where what you're talking about, it's ongoing for the whole tell-off period. You're having to interact.
Like there were many matches in 14 where I was just human player coach, where I was whoever the person was in the back. I would just pick up the ball now, take it over there, put the ball in now, like direct commands, because the kids just weren't to that level yet. Like they weren't even my kids. This was whoever our line partner was at the time who was inbounding, because our guy was catching our truck shots and stuff.
In 2013, I did a lot of drive coaching I didn't do a lot of drive coaching until when we got in the elimination rounds and we were with our alliance partners. So Mr. T, they were alliance captains, and he was the super coach looking at everything happening. And that allowed me to spend more time just watching my guys. And so I'm yelling at them to, go block so-and-so, move over here to this side, watching the whole field again, but just talking to my guys. But that was the dynamic of that group.
Right, so and that happens every time you get into an alliance. One of the coaches basically should be coaching the whole alliance. It's much nicer and easier if I'm not that person.
Yeah, I would prefer not to be that person.
I prefer when I'm with somebody I trust enough to do it.
Even in my limited, 2 years worth of mentoring experience, the most aggravating thing I found in the alliances is the coach who way over promises what his team can do, way over commits.
Right,
like
that comes down to in-match stuff. That's that initial strategy meeting. It's coming in with a clear head. It's coming in with clear data telling them that they're wrong if they think their robot can do certain things, and a lot of the social engineering of convincing them to go along with the strategy that you believe is the best one.
We always, whenever, like if I come up to you and I ask you, well, how many shots do you think you can make? I already know the answer. I'm waiting to hear what you say. That tells me how, tells us something about how we're gonna be able to work together. Because if you tell me something realistic, that means not only you're competent, you have an idea of what your robot is capable of, you're also not over-promising, and we can have a discussion now and be real about it. Whereas, you'll go up to somebody, and I've gone up to somebody and they've told me oh, well, yeah, we've been hitting a shot in autonomous, from going through the low bar, and I'll ask them how many times. I already know the answer, because I talked to our scout, the lead scout, and that just tells me, something about him.
Yes.
That kind of touches on what you said earlier about reputation, and I know in our scouting meetings, that has come up, like, there are teams that rank low, but it's like, I'd advocate for them, because that whatever they're gonna do, whatever they say they're gonna do, they're gonna do it, or they're gonna die trying. They're not gonna slack off, and your team is one of them, where just know that they're gonna work their butt off to get it done. And so,
Did you say bot? Work their butt off. I like that.
And you can depend on them. And other ones, they've had a lucky run.
Yeah.
But when the going gets tough, you don't know what they're gonna do. You can't depend on them.
No, in that vein, I kind of, teams like yours are expected. What I admire is some of the younger rookie teams who their bot can't do very much. They'll come and tell you, look, we can't really shoot any shots, but we can do this one defense, and we can, we can breach this one thing, and then we can play defense. And that they deliver 100%.
Right. And
whatever they promise.
And a lot of that is
100%.
how you start the driver, how you start that initial strategy meeting is a lot of that where you go up and say, a lot of what I like to do is, what do you prefer to do? What can you do every match? That kind of thing. And I normally ask the teams kind of what they want to do. I already know what the plan is, because I already know what their robot can do, but I ask them to say it just so we all kind of lay out the page of what our alliance is going to be able to do. And then we work to the strategy that most of the time either I preconceived or they're giving actual new information. Like some people are like, oh, we can't do this because our thing broke or something, right? Then you have to reformulate stuff in your head and figure it out. But most time going into the meeting, I have what I expect us to be able to do based on what we've seen before and what our scouts have told us.
There are times when you're later in the qualification matches where teams are trying to showcase something that they can do.
Yes.
And so, then it's a judgment call based on, well, are we going to rank in a position where we're going to be actually building a good alliance, or is somebody going to have to pick us? And if it's somebody's going to have to pick us, I would rather that team get to showcase what they're good at, so that they have a chance of being picked by somebody, and then we just do what we do well, which is hopefully scoring and crossing, in this case, scoring and crossing defenses, and so forth. Usually that's not mutually exclusive, but sometimes it is. Sometimes, they want to do something, and their robot may not be the best one on the field for doing it, but I know that they want to have a chance to showcase some feature of their robot.
Yeah, like we had a chance, I think our last qual at Lone Star, we knew we were not going to rank in the top 8, we were going to be 15 or 20. But we went to our alliance partners and said, look, we're not worried about rank right now. Are you guys trying to push into the top 8? And it's like, matter. And one of them was like, yeah, and I looked at the rank, I was like, you're 40, what do you mean? And they just hadn't understood the question, and I was like, no. Do you, would you rather just make your robot look good, or do you care about, winning and, ranking points and capture points and all of this stuff? They're like, oh, no, we don't care about that. Like, oh, bad, all right, so what do you want to do in this match? We want to do this to make sure we want to test some stuff, make sure we're ready for elims, blah, blah, blah. We're not going to worry about trying to get to, 8 late low goals and get the ranking point, because we don't care. So having those discussions and figuring out how all 3 of you as an alliance can work together, right? If any one of those alliance partners had been like, yeah, we're on the bubble, we're at 10, we want to get another ranking point, we'd have low goals like crazy and tried to get them that ranking point because they were our alliance, but none of us were in that situation, so we didn't have to. Back to briefly drive team stuff. Our driver station or driving picker stuff. Ours is a little bit different. Ours is basically the people who I know we can count on to be there the most and do the work, and if I was not there, they could still run the team and drive team and everything. You have to have a lot of trust in the people you put in the robot, and not only, like Scott said, not only with driving the robot, making sure they know how to make the robot work, because a lot of times they have to be the ones doing the repairs, because it's in queue, it's not necessarily in the pit, they have to be able to do some stuff on the robot. And also just interacting with the other teams, that is a huge market. Like, if you have a jerk on your team, do not let them be the drive coach, or be on the drive team basically at all. Like, they should not be there, because they are the face of your team. Everyone is gonna know them. But like, of all the students I can name on other people's teams, most of them are drive teams. Not all of them, most of them are drive teams. Because I've seen them in matches we talk about, we do more in the strategy meetings together. So you just get to know them more often than you do the other people. Like, I know some of the pitchers on 118 and Torque in them too.
That might be like a team philosophy too, because being able to be a drive team member, I mean, that's kind of an honor. I mean, it is an honor for the team, and you are the face, and you're out there, and it looks really good. And you don't want to, even if you have your best driver that you have in your team, you know, you don't want him on the field if the only time that he shows up is to drive, because he's not really participating in the
Correct,
team.
yeah, you don't want anybody on your team. Like, human play, a lot of people are like, oh yeah, this game is just, if we should go get the football player to be the human player. No, you don't want him anywhere near that. If that's the only time he's gonna be there and he can't help do with the robot, and he doesn't know what he's talking about, and somebody asks him a question about the robot and doesn't give a good answer, no, not at all. Like, the people who should be on the field doing the robot stuff are the people who have put in the time and can do it. Anybody can learn to do whatever the task is on the robot.
It might sacrifice your overall scoring than you, but that's where it comes to a philosophy about your team. What are you about?
Honestly, most of the time you don't, because somehow they're gonna screw up, they're gonna miss a match, they're gonna do something because they don't care as much as the other people who've actually put in all the time.
Well, and I think also, it's like, we kind of look at, on the human player side, what areas of the robot do we have covered as far as needing help? And so if there wasn't anybody with electrical experience out there, well, I wouldn't worry about electrical because I'd be out there. But if it were programming, I'd want somebody out there that would at least know how to, like, well, here, we need to reboot the Robo Rio, or, oh, that's a radio problem, it was 20 seconds, you know, that kind of thing. So somebody that could fill in those gaps, so when we're in queue and we're waiting, that means that they can take care of those problems.
Right. The other big thing, and a lot of people, when we say we want the dedicated people out there, you also want the dedicated people out there who at least want to do it. Like, we see a lot of people try to force people into the role, and you can let them experience it in an off-season or something, but don't just keep forcing them there if they don't want to be there. It ends poorly. Like, I've done it before. Like, no matter how much you think they deserve it and how much you think they'll grow from it or whatever, if they really just don't want to be there and they don't want to have the pressure on them, it's bad. It can get very bad. Like, if you can get them to do it a little bit and get comfortable with it, that's great. But after at some point, if they really just aren't, you have to just let them not do it. No matter how good they are, the rest of the robot, or how much they're doing, if they don't want to be out there. Because it is a lot of pressure for a lot of people to be in front of everyone and have all the weight of the team and everybody riding on them. They're so scared of making mistakes that they just can't do it.
Used to be a lot of pressure to be drive coach.
It is. I never wanted to be on the drive team. When I was in high school, I never wanted to be. I always ended up on it. I never wanted to be.
I've heard about what are the characteristics you look for a driver is that they do what they're told. How do you view that?
Yes and no.
You kind of touched on it, that the person has to get along with you, but if you tell them, go pick up that game piece on that side instead of the one on this side, you know.
Well, after that happens, and we're walking away, and I tell the operator, why don't you finish taking the robot back to the pit? Because then I'm going to ask them, why did you go get that ball? And if they give me a good reason, if I understand why they did it and it's rational, then we'll talk about, you know, I don't think that was a good decision, and here's why I think you should have gone for the other one. And together we're gonna grow. I mean, he may have had a really good reason for doing it, and he just didn't understand, and where are we in the season too, and so it'd be a judgment call as to what happens.
And it's very much a team. Like, it is the drive team. So they have they have the right to make decisions too, because they're the ones on the sticks, like the robot may not be operating properly, right, they may not be able to turn as fast as they want in one direction for
Sure.
some reason, or something wrong,
But
you don't
then
know,
there's
it's
a
hard to
rational-
communicate, it's very hard to communicate that quickly.
Then there's a good reason
Right,
that they
so
would
there
give
should be a reason,
afterward.
and there's also a lot of times, like, whoever's driving for us know, like, my voice will change when it's something that, oh, we're listening to him now and doing exactly what he says, because something weird's happening. Like, there's multiple times where I'm like, nope, you're like, or this year, anytime I would tell them, if you're playing defense, a couple times, instead of like exiting RC or passage, I would tell them like exit over somebody's defense, and like things like that, they had to do immediately, because at any time, somebody could come up and like hit us and it would be a penalty, right? So we're doing like risky maneuvers and things, if I told them to go, they have to just do it and gun it. And they just have to listen to me and trust that I'm right, and just go, because I'm not their coaching.
It seems
My
like-
voice changes if it's something that I want them to do right then.
Right. You know, like, go.
It gets higher.
I think on our team, there's, you know, they've had this driver that this last year, he's okay, but there's other people that want to be on the drive team. And there's this one individual where, you know, building stuff, we're telling him, oh, that's a bad idea, this is a bad idea, this is a bad idea, don't do that. And he goes and does it. And in my mind, like, he wants to be a driver, and it's like, but I'll never support him being a driver, because we're telling him these things, and then he finds out that, yeah, it was a bad idea, you know.
Same thing happens when you're with alliance.
So-
Alliance partners will do that too.
Yeah.
You'll talk to them about doing a certain strategy, and the next thing you know, you'll look down and they're in the courtyard defending the other people, and it's like, what are you doing down here?
Yeah, without saying anything, without changing any calls, or like you'll agree on like, a lot of people will be like, oh, we really want to test our shooter, we had a throw on 14. And somebody's like, we want to do high goals. And I was like, okay, if you miss once, just let us clear the low goal, and then we're just gonna go low the rest of the time. Like, if it's not on, like, your shooter's not gonna magically adjust itself in the match. Like, don't do it.
So
And
some
then
of
they
the,
just like, they shot it twice, and I literally turned and just yelled, you're cut off, get away from the ball. Like, I was just so angry. Because we had all agreed exactly what we were doing, and they had all been on board, and they just refused to listen. And I was like, I literally had to like tell our driver to go steal the ball for our own partner, basically, because they just would not agree to the strategy we had all agreed on going in.
In '08, we had a team in qualification matches that was from Mexico, and their English was not very good, and our Spanish was much worse. And so it was, I had no idea what they were going to do strategy-wise when we were in the match. So
you just couldn't, you were not able to work together, even if you.
it was a qualification match.
Yeah.
It's just one of those things that made me smile, because it was kind of, for a while there, I was always kind of worried that, okay, we're going to get another Spanish team, and I'm not going to be able to talk to them.
So the weirdest, probably my weirdest driver coach story ever was Champs in 14. We had our alliance, one of the alliance members was Israeli, and they speak English just fine, everything was cool. One of the people on their drive team did. The rest of the other alliance was, I think, from Wisconsin or somewhere. And they were fine, everybody was happy, we had this strategy going in. And then we were loading the robots on the field, and one of their drivers from the other American team comes up to me and goes, we don't know where our human player is. And I go, wait, one, that's not my problem. How am I supposed to know what's going on? I'm like rationally further.
Well,
I'm setting the robot on the
know.
floor. I'm so confused what's going on. We get to the driver box. I'm like, they clearly the drive coach knows. This was just one of the drivers, not the adult drive coach. Like, he didn't come tell me or anything. So we get there, and I look around, and I'm counting people, and I realize our two guys are out at the boxes, because you had like human players that were far away, and you had one that had to load the ball into the robot. Their human player was not there, and they were supposed to be the loader. They're like counting down the match to start. I literally run to the Israeli driver box, and he's the one not on the scoring table side, grab him, he doesn't speak English, and just move him back to the driver's station. Physically put him in there as they're like saying 3, 2, 1, go. To be able to have somebody who can inbound the ball, or we would have just been completely out of that match and we wouldn't have had an inbounder.
So you were talking about the loose responsibilities of a coach, right?
Right. We literally had to move a student, which was really awkward and really weird. They weren't stopping the match for some reason.
Off your pick list, right? That team got struck from your pick
Yeah,
list.
I don't know how you lose a member of your drive team. Like, I'm still baffled by it. No one can tell me what happened. Like, I asked
You
him.
probably didn't tell him to go to the bathroom.
One of the more confusing things that's ever happened. The whole match got even weirder because we ended up somehow being able to put basically 3 live balls on the field, which is not possible, and they wouldn't give us a replay even though it was like the ref's fault. It was a giant mess.
I think a really good, if you want to see some pretty authentic drive coach interaction, the AT&T Uverse video that they did I guess they released about a year ago.
What's it called?
Robo League 2015 on Vimeo. So they followed us, Rush, Poofs,
Oh.
118, and Buchanan Bird Rush.
Right?
And,
there you go.
yeah, but anyway, there's some really good, I mean, listening to the different, because I remember after we got done watching kind of 254 in action as drive coach,
Yeah,
it wasn't a great, I mean, they didn't come across great in the,
they showed it more raw than they've shown it before, and I think that's kind of one of the problems is they don't show you the rest of the interactions, right? They don't show the mentors talking to the kids not
Right.
in the drive box, right? If you only listen to me talking about kids in the drive box, you probably think I hate the kids. Like, there's so much just yelling at Dan and telling him to go and do something, but he drives better if I'm yelling at him, like, he knows that. He knows he drives better if I'm yelling at him. He knows that, like, I don't need him to buy it, he drives better.
for me, it was really interesting hearing like Kyle's style when she's talking, of course, one of
And she
they're
is
her
the-
kids, right? Or at least one of them.
I think one of them's her kids, but she also, and I don't recommend this one, and I don't understand why she does it, but this is one of the tour guide microphone megaphone things, which I don't understand, and it confuses me, but she's the only person I know who does it. I don't even know if it's legal, honestly.
Yeah.
But
Maybe she talks soft.
I thought she used to do that because she'd had some surgery on
I think
her.
so too. I think it's legal because she can't yell as loud, I
Okay.
think.
Well, it's
But
not
she's
really
the only person
part
I
of
know
the
who
control
does it.
system.
But I haven't known it as much, but she has it come out of a loudspeaker. And 'cause I don't think she can yell, but it's still interesting to see, and you hear it throughout the video.
Like there's a, I think a pretty good discussion, an example, here I'll go to it. And this is a conversation that we were having, let's see.
Pizza in theory should be here in 3 minutes, according to the website. I don't know how good its content is.
Can they get in the building?
They'll call me. They never know where the building is. I tell them as much as I can, they can never. Volume down. Sorry, on the video.
What?
I muted it on the video. That will be inside this next HD.
200 points, so that'd be a good score. Yeah. So this is the conversation that we're having here. Is better. 2 seconds. Okay. What happened? Just run with it. Don't worry too much about the arm, but we can fix it, okay? So that's what we're doing. I'm doing is drive code. They might have just sat there and not do it. Easy. No. Hold it up. Go,
Don't
come
worry
on.
about breaking the arm more.
If it falls, it falls. Go. So the other thing that happened here, this is one of my better moments is drive code.
Whenever I push buttons.
Is, so they were picking up the totes, and they're supposed to be really gentle on the first 4. But then when they get number 5, they can lift it and it locks onto a mechanism. And so they don't have to be so careful. So I'm telling him to be careful because I know how he does.
Gets excited.
And so, let's see, play again, there it is. So if you watch him getting the, what's better, coach here. Potentiometer changes one. 2 seconds. I mean coder, sorry, I got the coder here. What happened? Just run with it. Don't worry too much about the arm, but we can fix it, okay? Stack. So right there, you need to be really careful. Easy, guys, easy. Here we go, easy, because he's bumped. Hold it up, go, come on. And at that point, I knew that I almost could have sure he was going to lose those top 2. So I just told him to go. Because it fell off and he was able to fill the rest of the stack.
Okay, we're good. Just put it on the end there.
And he only did a 5 stack while I was watching, and we were trying to cap him.
15.
He didn't get a good approach on the cam,
We can't get it.
so he couldn't pick it up. He messed up the approach.
We couldn't move this at all. Because our came out and got stuck.
So anyway, but I think if you look through there and you just watch the little drive sequences,
Yeah, you haven't seen the whole thing. It's probably the best done video on FRC.
it really gives you a good idea of what it's like to be down there as on the in the drive team.
Right, it is, it's very intense, especially with the teams who are going for a world title, like who are really trying for it, like the teams who have no robot for it that year to be the best in the world possibly.
We were trying.
You were trying, but you were, it's not the same level, right? It's not the same level when you're, right, like, yeah.
We knew that our arms
when
were.
you're the alliance captain and you think you have one of the top 10 robots in the world, you might possibly be able to win it all.
Yeah, we knew we weren't that. Yeah, you're right.
I've got a question.
You just didn't have to say it.
How did you get here? You're the
You
first
guys
person
try
to
it.
ever get here and not call me.
Scott, but you
Oh,
guys-
sorry.
Scott, you guys try anyway.
We try anyway. Yeah.
That was my earlier point, that
Yeah.
So does it help for the programmer to drive the robot to get a feel for what it's like? You know, when
Do we let the programmer?
Yeah, just to kind of get the, you know, to see how well it's responding to at least, you know, travel.
I've heard other teams have that as their approach is if they have a good programmer driver, they always make the programmer the driver, because that way it's sort of programmed for the driver. Like the driver says, okay, this is a little hard to do. Should I learn to drive better or should I just change the code? Oh, okay, in this case I'll do it in the code. In this case I'll do it with driving skill, and so I've heard teams say that. I'm not advocating it or criticizing it.
Yeah.
And I'm asking that as a question. I don't
Yeah, no.
But you won't always get a person who can do both, because those are distinct skills.
I've seen our programmers drive it as part of the testing of their code.
Yeah.
Which they pretty much have to do. The challenge with doing what he said is the person is either writing new code or they're practicing driving.
Yeah, we're not like this past year, our human player was our programmer. We're not letting that happen again. Because normally our programmer's in the pit and he's fixing something. And he wasn't able to do that. And so I had a lot more problem telling him to do something than he had less time to get it done. So normally I could say, I really need you to, because usually what happens is I've told him to do something and he did it his way anyway. And I kept telling him I need you to do this, and finally I just had to say, look, set P to this value, turn off I and D. Let's see what happens. And then it didn't work, and I say, okay, now I want you to set the max speed on that motor to this. I think it'll work now. And he'll do it after he's exhausted all his attempts. But it's a lot easier to do that if he's off the field and making those changes, and then we come back and we can try them and stuff. So.
One quick question. I agree that kids who have RC experience, whether it's airplanes or cars, they seem to have some kind of mental wiring that allows them to make this jump.
Yeah.
Have anybody noticed the same kind of thing with an FTC kid?
I don't do FTC,
Okay.
but I mean, like our game controllers, PS2 controller, and we did use Xbox controllers. So almost there's so many of the kids that can just pick it up and start operating the robot. Everything, like for driving the robot, it's just like a whatever
Yeah, but I think
first-person shooter
in
game.
my mind, it's less this than it is this spatial awareness
Yeah.
thing that happens with, I have to move this large object out away from me.
I think the advantage that an RC person has is that they're used to their stick inputs have a certain behavior with the physical world, a real physical world, whereas when you're doing something on the computer, the stick behavior is always exactly the same, no matter what.
One difference you'll probably find is that I'm not a gamer, but usually in those first-person shooter games, you only have one view.
Yes.
I used to drive radio-controlled cars, and the biggest difficulty is driving away from you is easy. but once you turn around and start driving towards you, all your controls are reversed. And you
Yes.
get the same with airplanes.
Yes.
So with the radio control, that takes time to learn. And
Yes.
then once you've learned it, you flip mentally, you can't describe how it's done. You just do it.
And most RC drivers aren't used to driving backwards very much.
Right, that's it, that's the other thing, driving backwards away from you is the driver's hardest thing most of the time.
But
The robots
it's a lot
turn around
easier if you get to a
and they're
point
going
where
the other side.
you're, like when I flew radio control airplanes, I always thought from the airplane's perspective, that was my
Yes,
coordinate axis
yes,
at all times.
yes.
So there were the guys the older guys, I'm now one of them, but at the time, they were the older guys, and I would be flying, and they would tell me, okay, when it's coming toward you, push the stick toward the downwing. Okay, that was their way to remember that the controls were reversed. Okay, which worked fine. They were talking about the ailerons. Okay, well, that meant that, okay, the controls are different for me when it's coming toward me than when it's going away from me. If I'm thinking from the coordinate system of the airplane, the controls are always the same.
Yes.
I push
But
the
you
stick
have to
left,
learn to
the
do
left
that.
wing is going to go down, just
Yeah.
like it's supposed to. The controls are never reversed.
Which
But
is
you have
probably
to
why
learn to
people
do
that
that. Yeah, you
fly
have to
planes
visualize
do well
it
in
and
robots, because
try
they're
to
always
see it.
thinking in
I guess
terms
again,
of robot position, not in terms of
Yes.
how is it pointed at you.
Yes.
Because Nick and Andrew have grown up doing all kinds of RC.
Yeah, you
I
can
would also think
cameras too, which helps, but.
Yeah.
Well,
that
yeah.
there's
But
situations
having
where
that-
the RC
Yeah.
car has to move.
But you could also, I've thought about,
Can't see.
I've asked them, do you want a button so that when you're going backwards, basically the control switch? So when you're driving the robot forwards, left is left, right is right. If you're driving the robot backwards, you just think of the robot as going forwards in the other direction. You press a button and left is left from that perspective.
You just turn the seat around.
I think it would be.
We did that.
I think it's
Yeah,
harder.
and you learn
Yeah, well, because there were two different
Yeah.
controls.
And that's where all the practice time comes in. My biggest problem
Recycling
is
so they would
my-
switch it
my
around.
mechanical people and my programming people think that they can fix the problems with the robot and never let the driver have time with the robot.
Mistake.
It's a huge mistake. And it happens over and over again, and I get so frustrated because I just turn my back for a minute. So we came back from, like we were getting ready for TRI, and we were working on the robot, and they were supposed to switch out the front bar because the surgical tubing or spear gun tubing was messed up, and so they had to replace it. They'd already replaced it. I like to do everything, like you get to the robot, you do a quick change, you do all the off-board stuff you can. So they did that, but when they did it, they went, I think this gearbox is messed up on the intake system. So they took the gearbox apart, and an hour later, the robot's not out on the practice field. So before TRI, we cut our practice time in half because they wanted to fix a problem that was non-existent. It wasn't even a problem. They just thought it was a problem, and they didn't come to see me and say, hey, do we need to fix this? They just took it on themselves to fix it because they thought it was more important to fix this whatever problem that they perceived was there instead of giving us drive time. The drive time is what we needed. We didn't need the robot, like, oh, we need a spacer there. We didn't need a spacer there. So,
Food's here.
had to vent.
I don't entirely know what's all in the boxes.
All the same or different?
There are many different things. Many, many different things.
The same but different.
Okay, there's drinks and stuff in the other lab, plates, napkins. Discuss, think of questions.
Oh, your backpack? Your LOL
There's a meat lovers over
I know
here.
that you work with
David.
There's
Yeah.
a pepperoni over
Yeah,
here.
and my son was on that too.
Okay.
And then I saw
They did
y'all.
awesome stuff.
Well, y'all did too. I mean, we were kind of back to
There's a
back.
cheese over here.
But I just wanted to say hi.
Oh,
There's a
It's nice to
veggie
see
over
you
here.
again.
your son is with secretary.
Yeah,
Okay.
Yeah, he's,
Like red lines,
a
blue lines?
sophomore,
Yeah, I don't.
wanting to be a sophomore and
Feel free, there's, yeah, there's,
agreeing to stuff.
oh, yeah, there's no place to do it. That's true.
They have to stand up.
Because the first one I went on years ago, and they let him bring step ladders. So they couldn't see over the.
So you get on
Okay.
this would be great for freshmen.
So,
It really would be.
Yeah.
we have about 4 hours-ish left. So, when Scott gets back, we're gonna talk about team organization, because there's some very different on it, so it's good to have both opinions on how you do it.
It's
And
true.
then we're also gonna talk about fundraising stuff, because we're also very different in how our two teams operate. So things that were on the schedule that we can talk about, we can figure out exactly what we want to do for the next hour or so. Pneumatics, inspection stuff, I think most of you kind of get how that process works. Any questions that you have that we haven't gone over, I can pretty much pull presentations and slides or information on basically anything, probably made one at some point. What are we not talking about that people want to hear or discuss?
Actually, a question I had from earlier, and it would have been good to ask Scott this too, was when you were talking about sensors, you were going into this sensor does this sensor does that. How do you encourage the team members to actually go use sensors more?
So we don't, we use them probably, we have them all in case we need them. We use them less than most teams probably. It's, a lot of times it's the same reason as you just don't get there. But a lot of times is we don't use them unless it helps the robot compete better. Like they're just not there to be there, right? Like that doesn't matter. So if you can make it compete better, you have to use them and make sure they're not adding too much complexity to where they're gonna fail and it's gonna make something worse. You can.
But in your design process, I would imagine at some point you look at the problem and say, we could use a sensor here to tell us when we have the game piece in, or like you use the example of the ultrasonic sensor, we use a sensor to tell us when we're at the right distance from the wall, whereas what I'm seeing with our team is that just never comes up.
So I mean, that's just in the design process, in those meetings, it's, you go, hey, how do we, what can we use
so
this
this
sensor?
precedes the design process, which is if the team doesn't even possess the knowledge base, it'll never even be.
Well, some of it, I mean, the mentors are in that design process though. Like they're members of that design process. You go, hey, what type of sensor? Most of them have, we go over in the fall, that presentation that you got about sensors is the same one that I give my kids. We go over it, we walk through, we actually do it probably a little bit longer, because it's a whole 2 or 3 hours just on that. So we have them all and we plug them in and we see how they work and stuff. So they have this idea that they all work and they know they exist. So when I ask, hey, how can we sense this? They kind of remember back to random fall day when we talked about sensors, or ones that they had used in previous robots, or ones that they had talked about and seen other robots do. A lot of that is just keeping that conversation going with the kids. So when we have, a lot of what we do on the team is somebody's cool reveal video comes out, or in the summertime, people are releasing CAD of their robot, or they're releasing technical binders where they talk about it and document all the things they got on the robot. And we'll sit down with whoever's there that day, and one of the kids will be like, oh, hey, did you just see that 1241 released their CAD and all their build-up on how they did the robot? And he's digging around the CAD, and we're going through it kind of as a group, talking about it and saying, this is how they do this, and this is how they do this. And just so for the future, we all have this same shared kind of, oh, remember how 1241 did this in 2015? We can do it the same way, or how they did it in 2016. And you get that kind of shared knowledge where you learn about other people's robots, your own, and you can bounce ideas off each other if they all have that same kind of knowledge. We watch a ton of match video. It's just on streaming all the time during competition season. So like we go, oh hey, have you seen this robot, how it works, and this strategy, and you can bounce off ideas. And not everybody gets all of it, but they keep coming up and they keep catching.
Do the team members have some familiarity with some sensors?
Yeah, because we do teach it.
Yeah.
We teach it there. We do. We try to do. We didn't do it as well. We were trying to use VexIQ in the fall to do a little bit more where they were supposed to be using it on those robots to kind of get an idea of how they can work. It kind of worked. We're going to try to do a little better this fall to get to that stage of programming and doing the sensors where they help more on the mechanical side. But yeah, so they know that they exist and they've seen it used on other robots. They've seen it used on our robots. And so they have some idea of how to solve the problem.
Because like with our team, it seems to be that sensors are a totally foreign world, and they may as well be Greek to them, and so to get them to go into it is but
since there's not really a familiarity with them, then to get them to take that mental leap that it can be useful in this situation, it's like, well, I guess so, but I don't know how to use it, and you start getting a lot of excuses. And
Right, so a lot of that is, they're not gonna necessarily be the ones necessarily even doing it, right? Because if they've never used it before, you can't expect them to implement a whole system. So it's, a lot of times it'll just be, hey, couldn't we do this here? And it may be completely off base, right? They may be like, oh, we need to spin the shaft and count how many times it goes. And they're like, what if we use a potentiometer? And then I have to explain, no, potentiometers only do angle and only a single revolution, that's not what we want to use, but maybe we can use an encoder, and here's how we go about doing it. So a lot of that is, whoever is the mentor talking about it needs to have some of that knowledge base to at least know the options available to, and be able to correct if they're suggesting the wrong thing, or saying, you know, we'll just spin it up to this RPM, and I go, okay, how do you know what RPM we'll at? And then you can suggest an encoder or some other way of doing it. A lot of that is always going to be on the mentor to introduce the possibility.
So, and the whole thing about something like that is, it's one thing to have the theoretical knowledge, say even, you know, so it's one thing to have the theoretical knowledge, it's another thing to have say, well, that's about like this difficult, it should take us about like 5 days to do it, it should take us 1 day to do it.
Right, so you can, so prototyping in the fall is useful, so if you've never used any of these, buy one, build a system that does it. If your shooter is just, currently you're giving it a battery voltage, figure out how to get an encoder on there, figure out how to use the RPM now is a great time to do it. So then when you have to do it later, it's a lot easier.
So I'm actually asking the same question I'm asking myself. And one of the things, the answers I've come up with for myself is, so usually at about the start of the school year, we have training classes for the new PO on everything. I'm thinking this year, the training class in programming, the training has just been, you know, here's how you do stuff in lab, you would drag and drop stuff. But now this year, the programming class should not just be like, you know, how you write code, but it should be.
The motor, it should be.
I almost think it should be just like a light introduction to coding, but it should mostly be sensor workshops. To say, okay, here's, you know, in 2 days, here's how you write a LabVIEW program. And I know you just barely understand, that's okay. Now let's take an encoder and build this little wooden thing, and let's put an encoder on it and use something. Now next week, let's put a potentiometer on something and have some canned workshop. That's my current thinking. And you know, maybe build a little shell for each workshop, like a little machine that has a motor driving a shaft or a.
To overcome that lack of familiarity.
Yeah, so that, the little robot you saw in the cart over here, that was, at one point, it's been kind of stripped for using for other stuff, was basically a little sensor test bed. So it had encoders on both wheels, it had the gyro on it, it had like randomly zip tied to things, it had a potentiometer.
I'd like to take a look at that.
I don't know exactly what's on it anymore. Like I said, we were stripping it for things during the season, but in the fall, that's what it was set up for.
Because
so we could go to it, we could run code, and we could show different values and kind of things, and kind of work with the students a lot more on it.
So speak for myself as a lifelong computer coder, no one ever learns programming from a book.
Correct.
And by learning the rules. People like do stuff and they make mistakes and they do things, and that's how people. So there's no point really having like a 3-month programming class. It's better to just have like a bare introduction. You don't know much, then like do something and make mistakes and fix it, and so it seems
like task-based programming, where rather than learning code, you're learning like there's a specific task you're trying to accomplish, and by the end of the class,
Give the kids
you're
projects.
accomplishing it. Yeah. And every one of those tasks are all building blocks of an assembly that makes the robot run at the end of it.
Right, even getting to a robot running isn't the hard part of coding. So like you'd almost want to give them the base code that has joysticks and going, because that's nothing, but that's really basic. The rest of it is how do you add mechanisms and how do you decide how to do things, get autonomous to run well, test when something breaks, all that kind of stuff. The basics of just having a driving robot is pretty much written for you in every language. You can find the sample code to do that. And building out the libraries and stuff. And also just finding where you can get new information. That's one of the harder things for programmers, is just learning where the resources are to find where to solve problems, going on YouTube Delphi, finding contacts like your email, whatever you need to do to talk things through and work things out, how to solve the problems that they come to. That's a lot of it.
Has anybody built a large repository for code bases?
I don't know if there's just a large repository. You normally just have to go to each individual teams like GitHub and websites and stuff to find it. I don't know any single.
A group of teams is to say, hey, let's create something for CAD coding.
So we have a public CAD repository that basically has all of most of the COTS parts that were released at least last fall. I need to update this summer. Right, have my kids updated this summer. But we went through and we've converted all the step files to SolidWorks, so we can use it, and that's public on our ground CAD. So that's almost everything you would want. It doesn't have other teams' robots in it, because that's the other problem with publishing. Like, you can link to everything, but you don't want to republish people's work.
Right.
That doesn't work. So for CAD stuff, we pulled it all from the manufacturers and things. And we gave credit as much as we could. But yeah, so that's all, that exists. Code is a little harder just because any one team's code isn't gonna like magically just work with yours. Like it's gonna take a lot of work. So we pull a lot of stuff.
You're missing a lot of information, like, you're sending stuff to port 6, well, what's on port 6? You know, and that makes a difference.
Yeah, well, so hopefully it could have written
What's
that
the
way.
gearbox on the motor that's on
Hopefully
port
that's all
6?
abstracted out to some file somewhere.
Yeah,
if you're writing.
if you just get the code, it's like, well, damn if I know what this does.
Yeah, you can
wonder if you can read it.
Most people's code, you can figure that out pretty easily. Like I read a lot of the team's code that they publish. Simbox publish code 1114, Cheesy Foods do. I go through and steal the bits that I need to, and kind of build up a default library for us that we can load on and get most of that stuff done for us pretty easily, that we can call on their other things that they've written, debug stuff, and things like that. Yeah, getting sensors integrated is tricky, but you also don't have to do that, right? Like there's very competitive teams that are limited on their sensor abilities. So if you, no matter how good you are at getting sensors, if your mechanical system is poor, it will never correct it, right? Like you have to get the mechanical system right first before the best coders and programmers in the world can make anything else happen.
But I'd say the counter to that, from my experience with this year's robot, while that is true, the flaw often is that in a specific situation, there is absolutely no replacement for a sensor to solve the problem, like what I want to talk to you about later. And the thing is that teams are so focused on mechanical and electrical that they say, let's wait till like week 5 before we even think about.
Yeah, and you can't do that, right? So you need to know if there is going to be a problem like that in your design, that you have to integrate in the sensor mount. If you're planning to solve it with sensors and programming, you need to be working on that very early.
Yeah,
if
because
you design it to not have to have that solution and if you do it with pneumatics instead, so you don't have to have a
Right.
system, you know it's a 1 or 2 stage.
Yeah, because even though it's a last choice, well, every now and then you encounter the last choice, right?
Right, and that happens, but yeah, it should be done early if you're gonna make that chance, and then hopefully prototyped and tested and know that that solution actually works and doesn't just theoretically work.
And even if the only thing that you're going to be doing is going out to GitHub and here and there and searching for code, even that you should be doing in like week 2.
Yeah, or honestly, you should be doing that in the summer and fall when you're just bored at home and you're on your laptop. Like that's
yeah, even if you're not building it yourself, it should be done early.
Yeah, getting some sort of a test bed early to your programmers if you don't have a robot already they can play with, getting something on the ground that they can drive with at least, or even if they can't drive with it, if they can spin a couple motors, something that they can download code to break stuff and you don't care about it. Because when they start breaking stuff on the real robot, it gets much worse. And people have been trying to write simulation tools for robots ever since forever, and the only good ones existed from like 2003 to 2005, and then they all went away. Actually I take it back, it was 2001 to 2003. It was really, really good from 2001 to 2003. It was perfectly outputted because the robot was so simple and the microcontroller was like nothing, it was a little basic stamp that you could simulate every single input and every single output and it just worked. Nothing else has worked since then. So you pretty much have to do it on real hardware to be able to test anything useful.
And actually talking about the importance of mechanical, in our case, the problem with the robot is it keeps mechanically failing for lack of a because we cannot keep our actuator within its design range of motion. And the reason we can't is because we don't have sensors. And we thought of it too late to have.
So in some of those cases, you can either do mechanical hard stops or limit switches that are very basic at least to be able to stop it from going out of the
So I should tell you the full design problem.
Yeah, we'll get to it later.
Yeah, I mean it's strong enough to like crush bone. If we put something with a mechanical stop, it will probably cause the hinge to fail or cause some other problem.
Right, and so it may be that you actually, we'll design mechanisms sometimes to intentionally fail mechanically. So our lift last year was a good example. So when we did the whole rebuild on the stacker last year, we built it to where if we stalled the lift down or up, it wouldn't do anything except pop breakers. Like we intentionally just built it to go over current on the breaker to not break anything and just stall the breaker. So we put them on like 20 amp breakers instead of 40, but they were on 775s. They could have been on 40s. We put them on 20s so they would just stall. so that it couldn't break anything, and we just didn't care. Like we did a lot of things where if you could just make it to where, yeah, it'll just work, it's so much easier. Like we still, eventually, we had limit switches on them and stuff, but if they failed, we didn't care. Like we just keep stacking. Because we try to get rid of failure points on the field as much as we can. Like if it doesn't need to have that much power, don't let it. There's no reason you can't put a 5 or 10 amp breaker in there. If that's all the current it needs to be able to use and not break itself, let it do it. Other questions or things that we can discuss? We wait for Scott to get back. I don't know exactly what you want to do in pneumatics. It's relatively, there's no real tricks. We can do the real basic stuff, but
Something that I don't see discussed a lot is design for manufacturability and design for serviceability. And, you know, yeah.
So maybe what I'd add to that, what you're saying is design for robustness in an actual competition. So to survive bumps and hits and.
You can CAD something that can't be built.
Yeah.
It's harder with 3D printers, but it's still possible.
Yeah, like I mentioned earlier when we were showing how you do the Wago connectors that our original design that our head mentor wanted us to go with, you would not have been able to stick the tool in. And so what good was that? You couldn't build the thing. You could never fix it. But the guy never thinks that way. Whereas I knew that you should not build that.
Right. And a lot of times, like kids, they don't, that takes years of manufacturing and doing CAD for companies to start to even think in the realm of, manufacturing and buildability and everything else.
Actually, I have coworkers that design stuff like that too.
Well, yeah, but at least it had a chance. A kid going in there drawing a part, he's just trying to figure out how to make the lines work and the thing extrude. He hasn't even started doing how it's fitting and everything else, whether you can build it. That's where the mentors looking at the overall designs and that have manufacturing backgrounds know, that's not possible. You can't hold those tolerances. We can't make that. We don't have the resources and can steer them in the other directions. That's probably one of the biggest things that I think I do as a mechanical mentor is, try to teach them what you can actually build. Especially for us, we're very limited on what we can do in-house, and there's a few sponsors that can do really cool things, but they don't understand how those things are done and what their capabilities are, and trying to teach them that to design to those capabilities. That's most of what I end up spending time on.
It's part of it also not stretching too far, because even if it's simple operations, if you have to do it too much, you just run out of time. Like on our team, our upper structure this year got built out of plywood, because the original design was all these little pieces of metal tubing, and watching the team members build the collector out of this very similar structure. It took them most of the week to get 4 to 6 pieces together. And now we have like 8 times as much. They're not going to finish. Look at it, they're not going to finish, so I had it redesigned in a much simpler way.
Yeah.
But I've got that kind of mindset, but I'm not sure. So I had to force the issue, but it'd be nice if somebody had a way of teaching that. I'm just curious if anybody else.
I didn't see like a formal class on general practices for manufacturability or anything like that.
So a lot of it comes from experience in what the tools you guys have, whatever you can build locally, the experience your team members have in building things, and the team experience with your manufacturer you have anybody even outsource them. Okay, it just didn't open last time, we tried again. But a lot of figuring out how to build things for robustness and things does come with experience, and it comes with a lot of testing. There's a lot of times where we break stuff and redesign it, and break stuff and redesign it. Hey, we'll fix that. Okay, so there's some point of our drivetrain issue. So in this case, we went through and very early on, we thought about things like where the bumpers are gonna mount and how those pieces of sheet metal are gonna interact with everything else. Gearbox integration, belly pan integration all happened well before we actually manufactured anything. The whole pattern are just wherever Yan felt that we didn't have anything else to be put there. I've been open on here a long time.
Did you have, so you had one or two people drawing up that design?
So yeah, people work on different parts of it. So like, I think, who did what? So Sarah did the electrical and belly pan, because she normally handles most of the electronic stuff. So she laid it all out and figured out where all the holes are gonna be and got it on the router and everything. And we had other people actually do the router runs, so they program the router, and actually do the cutting for that, because we use plywood for that, so we do that in-house. The drivetrain, or the gearboxes were Mary and I kind of playing around. I think Ian ended up coming in and doing some stuff once he integrated them into the drivetrain. And then Ian did most of all the drivetrain rails, and I think the bumper rails as well. He probably does more CAD on it than anyone else right now. There's an intake that's not on here, that was Will and me a little bit.
Is there a review process where, well, before it gets finalized, that somebody goes and looks at it? Is it just you that looks at it, or is it a group of people that looks at it?
So a lot of them, so it's not like, most of this isn't happening in secret, this is happening in the computer lab next door to other people doing stuff. So while things are happening, we're going, hey, if we run into a problem at least, it's, hey, we need some people to look at this, any ideas on how we can solve this, can we move something? And we're talking about it pretty regularly. The final go is most of the time me trusting the 2 or 3 people who have done it and me making sure that there's nothing crazy wrong. Like, so it doesn't get sent to the laser without me looking at it. Like I send it over to our sponsors, but there's no big review panel process. I mean, we just don't have time for it. Just not everyone's in the room at the same time. Like, we don't have, like, sometimes the laser run's getting, I'm up late getting it out to them in that next morning, so we can hopefully get it by the end of the week or something like that. So we don't have time to do everything as well as I would like. But most of the time, this is on-ground CAD, so anyone who wants to go look at it can. Most of the team members have access to it. Anyone without has access to it.
So you guys do this in week 1, right?
This starts a little bit in week 1. This year we pushed everything back a little bit more. So I don't think we really did this in about a week starting at the end of week 1. We really hammered it all out. So they built, they had CAD'd, and we mostly had built a plywood version that we actually completely assembled without motors or anything. So it didn't have any of the flames or anything, it wasn't sheet metal. And then over the next week, we nailed out the rest of the drivetrain. And then added electrical.
So what I'm really asking is, CAD to this level of detail and accuracy, typically by what point do you have it?
So we're adding things in, so this, let me see if I can pull our laser files real fast, I'm tell you when we send it to laser. Okay. So we sent stuff. First one wasn't bad. So we actually didn't send, the drivetrain was a problem. We actually got it, we were basically done with it, but we were waiting on it. So we were done with it mid-January 25th, January 30th.
Since you have snapshots, can you show me a snapshot at the end of week 1?
So these aren't snapshots, these are just the files we sent to the laser.
Oh, okay, I see.
So these are like different laser runs.
I was just curious, kind of your rate of progress with the CAD.
Where can we get that? Can we get that somewhere? We might be able to get that off GrabCAD, but that would take a while. It's not, it comes in really big spurts, basically, when we finally decide what we want to do. The actual CAD doesn't take super long once you know what you're CADing.
No, never, I'm just, even if it's a little lumpy, I'm just trying to get an idea. As opposed to, what we'll often do is we'll like build it first and then CAD it. Not exactly, but.
I forgot the other way to do this.
So at the end, the CAD might look great, but it didn't really reflect the process we followed.
I can tell you exactly what we did. So every day during build season until I get annoyed and stop doing it, we have a build one. So let's see, so day 19 of the build process, we were at that point. So that's a little over 2 weeks in. So we had most of the intake, we were working on the intake geometry for how we were going to do this weird shooter thing that we do that no one else did, and it was weird.
Who keeps his notes, by the way?
Every year I try to have people do it, so like the first 5 or 6 days and people not me, and then the rest of the time it's me. Because they end up not doing it, then I should do it.
Yeah, I keep attempting to, but it's not happening.
Every year I try to have people do it, then I do it, and then eventually I stop doing it, then no one does it. So like 24, 26, 28, 31, like it's 36, 44, we lose some, but we eventually get back. It's relatively complete. A lot of it is just because things start, no big changes happen, right? We're just doing a lot of assembly and there's testing and all this stuff, so the CAD gets kind of boring and we're not doing new prototyping and testing and things, or the blog gets boring. So we were like, these are some of the mock-ups we have of shooters that never existed. This is just routed hardboard, so this is like $6 per 4x8 panel at Home Depot, like it costs nothing, and we just click on this router and make it kind of whatever we need to. Here's that plywood robot I was talking about. So it's entirely, we did test like what we have to do to go through the low bar at different heights. We did a lot of mock-up stuff like that. This was the start of a mock-up climber that never quite worked. Let's see, is there any more? There we go. So that's one of the, this was at the end of week 2. The Friday of week 2, that's where the CAD was. Things changed quite a bit from there. Like a lot of this is very, very rough sketches, right? Like this is just random shapes and collector and things. They're not, clearly not to production level at all. I made them look pretty because I like turned on high-level graphics, but they are not actually pretty. You can see as we started, we had done, in the first laser run, I guess we'd already gotten a couple parts back, we had some prototype gearboxes coming together. I think we started actually being able to shoot in a shooter that never actually worked, but we never fit on the robot. Really? Apparently it can't play Twitter videos that are that old. Yeah, so you get some sense of kind of how long it takes to do things. I think by, yeah, so George, 24, the CAD was completely done on the drivetrain. Which is a pretty good way in, which is where we started, which is when we ended up running into problems, we tried to send it to the laser, and that, like, that's when I really stopped doing the blog, when we were freaking out, because we had no,
The laser went down that we normally use, and we had to call around and like find
another laser, and we weren't sure we were going to be able to get anything done. This is where we actually had another team robot in the middle of build season and helped them build that. This is the team from Stafford. They had a mess of stuff, so we got them working a lot better. I think this was probably the latest we were ever driving. We weren't driving until day 36, which is pretty late. So we finally got all this together and driving. Which is not necessarily a bad thing, it's probably okay. In the past, we've been better. Let's not talk about 15. 15 was horrible. 14 was far better. So we had a sheet metal chassis in 14 by day 13. We were way faster in that year. Not necessarily a good thing, but we were just way faster. That ended up being the prototype one, and we made a production one later. Because this one we did all out of 8, and it was way too heavy. You see some new CAD stuff. So that's the basic structure of the robot that you see out in the hallway was already there at day 16. We kind of knew what we were building. We didn't know exactly what it was going to look like, but you can get the idea of where it all came from pretty early. I mean, we probably had that drawn on the whiteboard,
Day 4 or 5.
and then it was probably catted up after that. Good to see that. Yeah, like this was some weird small version of 118 robot from 2008. It looked familiar. Yeah.
I like that robot, because we beat it.
The little robot couldn't?
They had a drivetrain problem. They were still doing their swerve crab drive, or whatever they called it.
Yeah, they were still.
They had one of the wheel modules, I think, didn't have, drive wasn't working.
This was us prototyping intakes on day 2. So that's the Sunday right after kickoff. We started the CAT module. We had been kind of working on this in the fall, but not really. We just kind of knew we wanted to do it. Probably should have tested it more when we decided to do it. Day 6, yeah, so this is already laid out, most of the drivetrains, control panel, all that stuff before the week's even over. That's that Friday. We had some idea of the pace. This was probably too fast. We slowed it up the next couple of years, and it's probably better off. We had some very dedicated kids to do that in a week, though. Like that. At one point,
Colin was the senior who did this at the time.
we saw holding the chassis when it got made.
And I literally had to like wake him up a couple times because he was like in the lab catting until 10 or so every night. And was like, go to sleep, like, you need to go. I'm like, stop. I know you want to be here and do this, but you're literally falling asleep while catting. That's not good.
Go home.
Yeah. I'll sleep there, and I won't wake you up, and you can just sleep at your computer. That's fine. We some prototype intakes and try to video more of it. We did the blog in 14 and 13 were better than it was the last 2 years for a lot of reasons. And this is just pushed on a chassis. The chassis doesn't actually drive. We don't need it to. We're just able to power things off of. I think in this video they're being powered off an old robot, so we literally just like unplugged the drive motors or some other thing and ran long cables to them, or just running them off another robot. We sometimes run them off batteries. We have modified drills to have Anderson connectors out of them, so then you can just use the trigger on there to drive the motors. That works really well. That's what we did this year. We do a lot of things to get prototyping done. These ones are kind of that same thing as the test shooters from that year. Yeah, so you can see those are just test shooters we did in some hallway over at Agnes.
Other questions about production schedule or anything like that?
How do you work powder coating?
Good question. We try really hard to do it. Luckily, we have a guy, who do we use? We use Royalty Metal Finishing right now, which is down in Stafford area-ish. And they have been pretty nice to us. I don't know what the rate they charge us at this point. Like, we give them stuff, and then they ask me for like cash, and they hand it to them. I don't know where. I don't remember receiving them all. Like, I don't actually know how to deal with it. It's really cheap. That's all I know. They're nice to us. This year, because we were so late on the drivetrain and stuff, to get the competition one powder coated, we did it all assembled. So all they had to do was like hang it and spray it, and that's why the only thing on this year's robot that's really powder coated is the chassis, because we wanted to get something done. And then even one of the rails of the drivetrain we had to replace. The ones like we had to replace this purple rail at one of them, so it's silver now on the competition robot. We never made it white. If we get everything done early, we can powder coat everything, but we don't have the time this year.
Do you guys build a robot that you practice with, and you build a whole nother robot right before you go that's the actual competition, or do you competition upon the one you're practicing with the whole time?
It's so big for our sponsors, especially when you're doing sheet metal, it's so much easier for them to just make 2 or 3 or 4 of whatever the part is, that we try as hard as we can to not replace things if we don't have to. Like, we'll tell them just to make 3 old chassis, and if we have to make repairs, we'll make those extra parts later, but like, they'll make all of it hopefully, all that we want for the season gets made the first time, so they don't have to reprogram the brake to do the bends and stuff. Like, the laser doesn't really matter, they can lay out the laser and it's only one guy's time to do everything, but the brake, and it's some guy's computer, and it's not slowing down their production. Anytime that we're on the brake is slowing down their production, because that's the only thing that's bending, they have to program it on the brake, and it takes a lot longer. So anything, like, we can get flat parts back from them whenever we want, anything that has bent takes way longer. It's just a matter of the resources they have, what they can do.
So we end up building them all.
Roughly, the competition robot is normally a week or so behind the practice robot, just because we build everything on the practice robot first, and if we notice a hole wrong or something, we can do it slightly nicer on the competition robot, but we're still doing the same rough modifications and things.
That's pretty much, yeah. Same thing. We had 3 sets of sheet metal made. And so one for the practice robot, one for the competition robot, and then a spare set because something might get broken. We had 2 shooter designs, and when we asked for sheet metal, we didn't know which one we were going to use. So we actually had both of them done in sheet metal. So that, and that's what we're doing this summer, is we're installing the second shooter on the practice robot so we can see how that plays out. That's an issue where if we had more mentors, we would have assigned somebody, you're responsible for the shooter, we need to know which one of these 2 is going to be better, and that would have gotten, at some point during the season, the new shooter would have gotten it on, because I think, I'm almost 100% sure the new shooter is going to be better than the old shooter. Unfortunately, it won't be quite as loud.
At one point, you guys were building Alpha Bravo Charlie, is that still, or Jolie?
We would do sort of an alpha if, like, for a drivetrain. Okay. So in 2014, there was an alpha. In 2015, there was an alpha, which was just the drivetrain.
Okay.
And then in like this year, there wasn't really an alpha. We had a pretty clear idea. I mean, we didn't do anything fancy with the drivetrain, other than, just big wheels and spacing and stuff like that. So, and I don't think we'll do an alpha like that. We probably won't do it. Well, I mean, we may do something. We're trying to do a different wheel combination of some sort. And we may want to know, like we did with the mechanicals. That's why we did the alpha in 2014. Was we wanted to see if mechanicals would work on that one.
So for y'all, the idea is that the first robot gets that practice robot, and then the competition robot's the second one.
Right, and like I said, it's not necessarily built as much as it's just delayed in its progress of getting built. So the first one is the one that doesn't take the time to be powder coated, so it's the chassis there a little bit earlier, so we're putting everything into it. We're hopefully getting it tested. So in case there's big modifications, or in case we start screwing it up, we can not screw up the competition robot. Right, so if we bolt things on backwards, or if we strip something, or something, that all happens on the practice robot, so all the extra drill holes and things are on that one that looks ugly.
That's a lead for us, because ours is practically the first robot, the competition robot in first, and then get the practice robot.
And so the only way that this works, and so there's a moment pretty much every year where we have to necessarily decide, like, right around baggage time sometimes is, hey, are we bagging the competition robot or are we bagging the practice robot? Like, it happens sometimes where they might switch roles. It's never had to, but there's always that dread if you end up getting delayed, if something does go wrong, that you can bag the practice robot. Like, there's no reason that it has to stay that way. It's wildly preferred that the nicer one is the second one and that you should bag it. But if it doesn't get done, you could bag the practice robot.
I have to switch you on this thing if you want to see something. There's a little button.
What?
Or do you want your laptop?
I'm just going to put it on that one only.
You can't do that with my laptop.
Oh, I'm sorry.
No, it's fine. It's like a cat on my laptop.
I just thought I should put my.
Yeah, you can. They can ask
Because
us.
they had questions.
No.
They could
And I
ask
know
questions
that's not
about
the intent.
what we did, so.
Nor is it in basis of.
And this is the robot we competed with. The robot that we're working on this summer is loading. He switched early.
Yeah.
So,
Early in the design process, how do you go about breaking the robot into different
areas for groups to work on?
The different areas are mostly during prototyping. So when we're prototyping, somebody's doing shooter, somebody's doing intake and so forth. And part of that process, especially like we got the drivetrain kind of worked out, was then trying to figure out, okay, if we put the intake here, like we did up toward the front, how close could these two be together? Because how close these could be together and where this was kind of determined how much space we had inside the robot. And we didn't want an external intake. Like you see some teams, they have it come over and they could grab the ball, partly because that took more time for that actuation, but also it puts the arm out there to get damaged. And so we thought if we can do the intake internal to the robot, and so the fact that you could have an opening in the bumpers, and that the bumpers could be this edge here, or the bottom of the bumper would have been 7 inches, then we tested it. You could drive right over a ball and it would just come, these two rollers here are, I want to say they're 6 inches apart, and the ball would come in. And we got all the way down to like 5 inches or something and said, no, it's not working very well anymore. So went back to 6, and I think it's probably what it is right there. So 6.96 inches. So it's the spacing between those. This is the summer. This is what we're working on this summer. So if I go back, go back to the other one. Oops, it's there. So this is the flywheel shooter. This is an articulating hood. And then on this robot, the flywheel is replaced with this flat wheel shooter right here. So there's 2 horizontal wheels now instead of 1 flywheel that's driving the whole system. The problem is that with this bar that was installed for the intake system, that got in the way of these wheels right here. So on this robot, that bar's moved up 1.5 inches, I think, compared to the other robot, which isn't a hard change to make. And we've tested the ball progression, so it still goes, the ball goes in the intake, it gets here and it gets tested for compression, and then the horizontal wheels spinning slowly can pull it in. And then there's this back wheel, which right now we call this the trigger, and that's going to hold the ball in place, and then when it's time to fire, it just rolls it forward.
So that kind of a mistake where you said the bar is in the wrong place, at what stage do you
It's not
catch?
necessarily a mistake, so they're making a modification, right? So
Yeah.
it was right on their previous shooter. It's now it's a change on the.
Yeah, no, that's what, in the sense of, okay.
But when did we decide where that, like?
No, when do you identify, is it at the stage of doing a CAD, is that stage of doing a assembly, or is?
Well, on this, it was, because this, so this shooter was in about, let me show you. So we have a numbering system for our CAD. So this is B16-300, the subassembly, okay? In the original robot design, this right here, that would have been this would be the belly pan of the robot, okay? And this structure right here is integral to the back of the robot. It was designed, this was designed originally so that this would drop in, just drop into the place where the flywheel was, okay? Well, once we committed to the flywheel, and then some other things happened on the robot, we got to a point where this wouldn't drop in anymore. And at that point, we were committed to the flywheel, and it was going to be a summer project to test out this shooter instead. So now that this has happened, this panel is, this is no longer the belly pan of the robot. The reason why this is angled down is because
That's still a little hard.
nope, this won't clear the low bar anymore. So that panel that the shooter's mounted on is this panel right here. So it is about 5 inches higher, 6 inches higher than it used to be. We can't go under the low bar anymore. But we noticed that there's plenty of teams that can do the low bar. We don't need to go under the low bar.
That's why we stopped too.
So that's not an issue anymore. So we're foregoing that. Our electronics, in fact, on this drawing, well, they are. The electronics are shown here. This is where all our electronics were on the other robot, and then some of the speed controls were down here. Well, now the speed controls and the power distribution panel are going on this shelf, which actually can slide out. And it's got cable carriers so that it can slide out, and that provides access to the battery and access if you want to see the speed controls and stuff and what's going on with them. And then down below, that's just right here, that's where the battery's going. Right there is the battery. I think he's got an end backwards in there.
I would think so.
Huh?
I would think so.
Yeah, I think so too.
I would hope your leads aren't the first thing that gets hit on their fire bumpers.
Well, see, look at that. Broom, maybe. But anyway, so those changes happened as a result. This has changed too, right up here. This was his design, one of the students' design for how to mount this top bar. This little piece of this is a piece of Lexan that's cut out with a slot in it and stuff. It doesn't provide any rigidity, so this has been replaced by, I don't think it's in this picture, no. There's a piece of angled aluminum underneath here now, and that's replacing this piece and this piece. The CAD just hadn't been updated yet. So I did it on my computer, but then when I was all finished, I didn't upload, because we have everything, well, you do too, right, GrabCAD. So we have everything in GrabCAD, and that means I log in, so when I'm done making changes here, I go back to GrabCAD, and, oh, well, I do. I have files I should have downloaded. There's 7 files for this robot right here that need to be downloaded so that it's correct. And I have 2 files to upload. I can't upload until I download these and decide, because there could be, there may not be a problem. There could be a conflict between these. So I pretty much have to shut that window down. Don't save. And shut this. And then I'll go back to GrabCAD, and I'm going to download those changes. See these files in white? I don't know if you saw that for a moment. It said locked by SolidWorks. That's because whatever was happening here was something I just had open, probably. So I can highlight these now. It'll download those changes.
Fix the battery mount change?
No battery mount change. That was all firing systems.
Oh, okay. Like you were talking about the batteries.
So now if I open up, B is because it's our summer build. So that's why there's a B at the front of the name. And it's updating the files. Okay. These arms will be back on the robot here. They were taken off in the meantime while they're working on this, and so they just probably just suppress that in the CAD so that they're out of the way. Can I make, like, if I wanted to make our CAD for that robot just public so anybody can view it?
Yeah, so you have to make a partner space.
Yeah.
You can make that public. So the only annoyance is that when you push updates, it doesn't update the partner space. You have to go in and actually tell it to, and then it will update. So like that's what we do for like the big library we release to the public.
Oh, okay.
It's a partner space. Like I make updates throughout the season, and then I forget to update the partner space. So then like the CAD is public to everybody isn't as updated as the one that we have.
Well, that's what I'll do.
Yeah.
Is I'll, this evening or while we're here or something, I'll go ahead and create that partner space. I'll add a link to our website and you can download. We've got, the CAD that I have is back to 2011.
You should put them all on FRC Designs too if you want to publish something.
Say what?
FRC Designs is the big CAD database for other teams.
Okay.
It's probably the best place. If you just want to output the set files and send them to
Okay.
Everything is, somebody starts.
All right, so let's see what got changed here, if anything. So I know one change may have been that, like these holes right here, I don't know if they were there before, but the machining is there for them now. Because that's what one of the students was working on, is we have a little mill, CNC mill, and so they used HSM Express to do the machine paths. And so he's teaching other students how to do that right now, and that's probably what I just updated, was I added the machine.
I don't know if it is useful to you or not, but they'll give you full works if you ask.
Who, HSM?
Yes, if you don't want to use Express anymore, if you need to do any 3D stuff, they'll give you all of it for free.
I see another issue here is, and he hadn't fixed this yet, so this spacer is probably 1 inch long, and they discovered that they need to go back to, well, it doesn't look like 1.1. That spacer is not right. Because you may notice there's a little space between it and the versaplanetary that it's supporting. So that would be that won't pass design review.
Okay, so we want to get into team organization and fundraising.
Okay. And I have no reason to say. We have a big problem on our team, or we did, where people were saving assemblies all the time, even though they didn't need to, and they would break stuff. So if I make a change in a part, when the assembly gets opened later, it will automatically update the part. I don't have to worry about, did I save the assembly or not, so. Team organization. I think that's a PowerPoint. I don't think I want that. No, I don't want that. It's not really that helpful.
It's just, you know.
So we have a folder called Team Organization, and inside the folder is 2017 Texas Torque Leadership. So I can show you where we are right now with our team leadership. So you can see our president is Claire Zhang. She was interviewed for the job along with London and Noah. Those were our 3 candidates for team president this past year. We interviewed them and asked them some questions about, kind of what they had in mind with the team, what they thought their biggest challenges would be, and so forth. And then the other question we asked them, which was new this year, is we wanted to know, we created this new position called vice president, and the vice president is chosen by the president as basically their assistant, because there's so much stuff the president has to do, and so we wanted, and the president can't be at all the meetings. So this allows for that division of labor and for the president to not feel like they're having to do everything. And so Claire was torn between selecting London or selecting Noah. But I was pretty sure she'd end up going with London, and she did. So president and vice president, so those were interviewed and selected. And then the rest of them, we've kind of done, like, do we need to interview the people or not? So we put out a call for what positions were available. So some of those first positions were mechanical, electrical. Well, we really didn't need to ask on electrical. It was pretty much only Noah was the person that we knew was going to be that. And Glenn for programming was pretty much known. We kind of brought this position back. We had a machinist position. We added the position shop manager fabrication because we had a student from Norway a few years back, and he knew all about all the different machines that we had, the mills and the lathe and so forth. And he was very good at not just using them, but at keeping them up, taking care of them. And so, so we've been trying to work that in as a permanent position, someone whose responsibility is to make sure the shop is in order, that we have all the tools that we're supposed to have. If there's something missing, who's the person that's supposed to know?
oh, we need blades for the bandsaw kind of thing. And so that is basically, that's Jackson right now. The other two candidates were Alex and Brunon. Alex was also interested in social media, which was kind of, surprised me a little bit. Alex is a girl, but I did not expect her to be interested in social media. So anyway, so she's taking care of social media right now. That's a good position for her because she's not a Conner ISD student. She's a Tomball ISD student, and she can't make it to all the meetings right at the beginning. And social media is something that she can kind of do wherever she happens to be. We're at a competition, she can tweet something, what have you, so.
Is that also the person who does your blog and stuff?
Hmm?
Yeah, the blog you have on your website?
We don't have I don't think we have a blog.
Oh, yeah, okay, just a wiki. So wiki, I guess, is everyone kind of.
Well, their wiki's private.
No, but I mean, someone is keeping it up to date, right? That's not a position?
But everybody's doing it. Yeah, so all the different sub-teams update their wiki when they need to add information.
Say what?
The people who update your wiki is any of the sub-team members.
Yeah.
Who are
Sub-team members would update their section of the wiki. That's their responsibility. Oh, sorry, I gotta fix this. It's not an S in his name. Okay. So our outreach coordinator, looks like it's gonna be Kelly Zhao, but Jessica also applied. I think we're gonna have co-leads there. It's still kind of up for discussion. When I say it's up for discussion, the leadership for the team right now is these two people, and then myself and Matt Davies, which is a teacher mentor, and then Sherry Coates, who is a parent/teacher mentor. Son used to be on the team, he's no longer on the team. He's graduated. Both their sons were on the team at different points. But we're kind of the people that have been doing the interviews and sitting down and talking to these people. And so we're trying to still sort out who should be in certain positions. Most of this is right now just based on their past history, that we're trying to get these people in place. The sooner that we get out, we want to get outreach done fairly soon because we have all these things that are going on, and outreach is, those activities, that's what this person, Kelly and Jessica, need to be handling. And so until they're in place, that means Claire and London are basically taking care of them. Part of that's because the person that was outreach was a senior, she graduated, but she wasn't doing as much as she needed to do anyway. Bella's in charge of media. I think I can go ahead and, the reason why they're bold is that that position is finalized, so.
So just to kind of give the antithesis of this, so that's how their team works, and that works well for them. We are the farthest end of the spectrum from that you can possibly get.
I see what you did there.
I did, I know. We have, literally there's no student on our team has a title other than the ones they give themselves.
And driver.
But that's literally because they have, like, other people give them that title. Like, that switches out, and basically outside of the 3 in-season events that they go to, that's the only time that those are guaranteed their spots. The off-seasons, those switch around all the time. Like, if you saw what we did at TRI, I don't know who drove any of the qualification matches. I think we swapped to Sarah and for Elam. Actually, I know we did. But other than that, that's it. So people are, whatever they needs to get done that day gets done. Like, we have one of the more, like, it's a very fluid who shows up. Like, the 4 or 5 people are always there, and then everyone else is who's there that day. So everyone does a little bit of electrical, a little bit of mechanical. There's normally a couple people who end up specializing in, like, the harder tasks of, like, diving deep into programming or electrical and things like that. But a lot of, everyone's done a little bit of CAD. If they really like it, they'll keep doing it, and they'll CAD subsystems, and they'll do even more, and then they'll eventually end up being the CAD leader, but there's no one who appoints them that. If they stop doing CAD, they're no longer the CAD leader. Someone else is going to take that role. Like, if they stop running the router and we need stuff routed, I'm going to teach somebody else to do it, and they're going to start doing it. Because we have so many people who are doing other sports, other things, debate, band, all sorts of stuff where they may not be there, or they may lose interest. Whatever happens, we don't require them to be pretty much anywhere at any time. We want everyone to be there as much as they can, but it's not required.
Like when you said, use the example, someone stopped running the router and you pick someone else to run it, do you look at the group you have available and say, I think this person has the right qualities?
That's a lot of it, and some days if there's nobody there who wants to do it, I'll run it, like, I mean, I can, or I'll grab somebody else who doesn't necessarily want to, but I know can, or like, who knows